All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. If you have not subscribed to the channel as of now, I would want you guys to hit the subscribe button as soon as possible. Okay? And today is the first session of the 11th portion, that is basic mathematics and vectors. Okay? We will be completing two chapters, not just one chapter. We'll be completing two chapters. Every single thing I'll be discussing over here, whatever the topics you have in the basic mathematics and in the vectors. Like you have in basic mathematics, you have trigonometry, okay? Like you have the integral calculus, you have the differential calculus, that is integration and differentiation. You have the maxima and minima concept, okay? So this chapter or this session is extremely important for all the NEET aspirants or the JEE aspirants, because if you see all the chapters out there in your JEE or NEET, we say this, the application of this chapter is, involvement of this chapter is over there in all those chapters. So that's the reason we say this chapter is extremely important if you want to build the basics. If you want to solve the problems in a very less amount of time, then basic mathematics and vectors you should learn very properly, okay? And before that, I would want you guys to tell me in the chats if everything is perfectly fine, and smash the like button if you have not liked this session yet, okay? Smash it, okay? Everyone means everyone, because marking the attendance is extremely mandatory, okay? Great. Let the people come, let the people join, and we are starting the session accordingly. Mostly we'll finish the session by 10 o'clock, okay? 10 o'clock we'll finish the entire session, because we have to complete the two chapters. That's why it will take a bit longer. Okay, great. So guys, I think without wasting the further time, let's dive into the session. Let's talk about each and every single thing over here, whatever is mandatory for your NEET physics, okay? Okay. So, the very first thing, when it comes to the basic mathematics, we'll be starting with the chapter basic mathematics, okay? The very first thing that we need to start with is the trigonometry. Okay, extremely mandatory. All those things, if there is a student who have already studied this, then he is supposed to listen to the class, okay, silently. Now see, let's take a look exactly over here. When it comes to the trigonometry, the first thing that we need to learn is the angle, okay? Everybody knows what is angle, sir. 30 degree, 40 degree angle, 50 degree angle, like we say, it's something like that. Let's understand the basic definition of the angle first, okay? Let's suppose, my dear friends, I'll take a circle over here. This is the circle that I'm taking, okay? And let's suppose you are exactly sitting at this point A. You are sitting at point A, okay? And there is another person who is exactly present at the center, okay? So you are sitting at point A. Now you started moving from point A, and you reached this point B. Okay? You reached this point B. Now if I join this center with this point B, it will be something like this. Don't you think that if there is a person who is observing you, clearly, it seems that you have basically cut an angle. You have moved an angle. You are moving angularly. I'll say from moving from A to B. On moving from A to B, we have cut some angle. Or you can also say we have covered some angle. We have covered some angular distance also, you can say. Whatever the English you want to use over here, you can. Okay? And let's suppose we call that as theta. On moving from A to B, You have cut an angle. That angle is, we say over here, we say theta. That is angle is the theta over here. Okay. Yes, sir. Now, my dear friends, so I can clearly say, sir, this is how we define the angle. How much you are moving angularly. Okay, like if I say, sir, you have moved by 30 degrees, means angle is 30 degrees. Angular displacement is 30 degrees. So now, my dear friends, while moving from A to B, this is the linear displacement that you have covered. Let's suppose this is S. Let's suppose this is S. And everybody knows that, sir, from center to this point, this is the radius R. This is the radius R. Now, sir, we got the feel. What is the angle? Okay, we got the feel of the angle. On moving from A to B, we have cut some angle. We are moving angularly. That angle is theta over here. Now, the question is, how do we exactly find this angle? How do we exactly find this angle? We say this angle is simply arc upon radius. This angle is simply arc upon radius. This is the basic formula. What is angle over here? Angle is theta in this case. What is the arc in this particular case? How much linear displacement you have covered? That is S. Okay, S is the arc. And what is the radius in this particular case? That is R. Now, can I say from this? We say this will be S is equal to R theta. S is equal to R theta. Where theta is the angle, R is the radius, S is the linear displacement covered or the arc over here. Okay. Yes. Now, guys, let's suppose I'll give one more example exactly over here. Another example that I'm taking. Let's suppose there is another person. That person is moving from point A to, we say, point B. That is exactly over here. If you join this point A with the center, if you join this point B with the center, don't you think that in this particular case, this is the angle covered? And we can say here, this angle theta is equal to 90 degrees. This angle theta is equal to 90 degrees. Sir, magnetism and matter. I have already covered the magnetism and matter. That will be in the video section. Okay, that will be in the recorded format, not in the live format. Go check that out. Okay, so my dear friends, on moving from A to B in this particular case, how much angle you have covered? We say, sir, 90 degrees. Okay, this much angle. How much angularly you are moving? That's how we define the angle in this particular case. Okay, as simple as that. Now, guys, let's talk about the unit of angle. Let's talk about the unit of angle. Guys, if I ask you the simple question over here, let's suppose we have got a block over here. We have got a block. There is a block in front of me. We have got a block. Let's suppose we have got a block over here. And its mass is, let's suppose, M. The mass of the block is M. And if I say, sir, mass in this particular case is, we say 10 kgs. What is this kg? Kg means unit. Okay. We say, sir, it is 20 kgs. Okay, 20. What is this kg? It is unit. Or let's suppose you say, sir, it is 10,000 grams. What is this 10,000 grams? 10,000 grams is a unit. Gram is a unit. Similarly, if you have to measure the angle, what is the unit? What is the unit? The unit of angle, either you measure it in the radians or you measure it in the degree, okay, or minute per second. We don't usually use this. You can ignore this simply. We have to deal with these two exactly over here. Now, guys, let's suppose if I say, sir, angle covered is equal to, I would say, sir, in degrees, if I say it is 30 degrees, okay. Similarly, I can say in radians, this angle will be, that is pi divided by 6 radians. Like you have 1 kg mass, you can also say 1000 grams. Gram is also unit, kg is also unit. I'll show you how to do the conversion, okay? Just a second. Like if I say, sir, angle over here is 60 degrees. And in radians, you can also say, sir, angle is pi by 3 radians. So means we usually measure the angle in degrees and radians. Let's first understand the conversion. Over here. Okay. Let's first understand the conversion over here. See guys, convert angle from a radian to degree. Convert angle from radian to degree. First we have pi by 2 radians. Guys, see. I would want you guys to remember one single trick in this particular case. Okay, you don't have to do the long method, just one single trick. Let's suppose you are moving from point A, okay, to we say point B. This is point A to point B. Could you please tell me, sir, everybody knows it, how much angle we have covered? We say from A to B, I can simply say how much angle we have covered. We say theta is equal to 180 degrees. On moving from A to B, this angle covered will be 180 degrees simply. Okay. Or you can also say, sir, it is pi radians. You can also say it is pi radians. If you move from A to B, either you say 180 degrees or you say pi radians. Like you say 1 kg is equal to 1000 grams. Similarly, 180 degree is equal to pi radians. So remember the general rule. We say, remember as 180 degrees, or we say simply like this, pi radians is equal to 180 degrees. Okay. If you are moving an angle of 180 degrees, means you are moving an angle of pi radians. Now, if somebody asks you, what is the value of 1 radian? What will you say? So 1 radian will be simply that is 180 degree divided by pi. Take this pi over here. Yes. Now, this is the thing which I want you guys to remember. This point I want you guys to remember. 1 radian is equal to 180 by pi. Now let's move on to the question. See, it is pi by 2 radians. Guys, this is pi by 2 into 1 radian. You can write it something like that also. So 1 radian is equal to 180 divided by pi. So instead of this 1 radian, I would want you guys to write, see, this pi by 2 as it is. Instead of this 1 radian, you will be writing 180 divided by pi. That's it. You don't have to do anything else. So pi and pi will cancel. 2 ones are, 2 nines are, and zeros are. So this will come out to be that is 90 degrees. Simple. Instead of this radian, you will be writing 180 by pi. That's it. Like. Next question. You have pi by 4 radians. Guys, what will you write? Sir, this is pi by 4. Instead of this 1 radian, we can write 180 divided by pi. As simple as that. Now, pi and pi will cancel, and this will be equals to 4. 4s are, 5s are. So this will come out to be 45 degrees. Simple. Sir, what about this one, pi by 3? See, I can write this as pi by 3 as it is. Instead of this radian, 1 radian, what will you write? You will write 180 divided by pi. This pi and pi will cancel. 3 ones are, 3 sixes are, 3 zeros are. So this will be exactly 60 degrees. 60 degrees. As simple as that. Now, what about this one? Sir, in this particular case, I can write 5 pi divided by 6. Instead of 1 radian, what will you write? 180 divided by pi. Okay. So simply, this pi and this pi will cancel. Okay. 6 ones are, 6 threes are, 18, 6 zeros are. Now, 5 into 30, that will be 150. 150 degrees. This will be 150 degrees. So 5 pi by 6 radians is 150 degrees. 150 degrees. Okay. Now what about this one? So here you can write 2 pi divided by 3. Instead of 1 radian, what will you write? 180 divided by pi. Now this pi and this pi will cancel. 3 ones are, 3 sixes are, 18, 3 zeros are. So this will come out to be that is 120 degrees. Please give me the signal in the chats. How many of you understood this properly and how many of you is clear with this particular concept over here? Everyone means everyone. Let me know in the chats. Okay. Great. Super clear. That's nice. That's nice. Now, guys, let's take a look exactly over here. Convert angle from degree to radians. Now, if you have given the angle in degrees and you are supposed to convert it in the radians. See, guys, the first thing you guys are supposed to remember, we say 180 degrees is equal to how many radians? That is pi radians. Okay. This is the basic thing that we know. Could you please tell me 1 degree will be equals to how much? So pi divided by, I can say 180 degrees will be this. Pi divided by 180 will be in this particular case. Pi divided by 180 radians will be in this particular case 1 degree. 180 is equal to pi radians. 1 degree will be pi divided by 180. Now, guys, don't you think that we can write this 30 degree as this will be 30 into 1 degree? Because 30 into 1 degree will be 30 degree. Simply. Now, can I say in this particular case, this will be 30 into, instead of 1 degree, what can I write? Pi by 180. So I'll just write over here pi divided by 180 radians. Now tell me, 0 and 0 will cancel. 3 ones are, 3 6s are. So this will come out to be pi by 6 radians. Clearly, 30 degree pi by 6 radians. You check over here. You check over here. 30 degree. Okay. 30 was not given in this case. Okay. Chalo. 30 degree is equal to pi by 6 radians. Let's check this one. Let's check 60 degrees. Guys, what is the value of 60 degree? 60 degree in radians is pi by 3 radians. Let's check if it is coming out to be pi by 3. Let's check. Guys, when it comes to the 60 degree, you can write this is 60 into 1 degree. Then you can write 60 into, instead of 1 degree, you can write pi divided by 180 radians. Now 0 and 0 will cancel. 6 ones are, 6 3s are. So this will come out to be pi by 3 radians. This comes out to be equal to pi by 3 radians. Check. Simple method. Okay, what about 120 degrees? You'll be saying, sir, this is 120 into 1 degree. So this will be 120 into, instead of 1 degree, what can I write? It will be pi divided by, that is 180 radians over here. This and this will cancel. Okay. 2 6 2s are 12, 6 3s are 18. So that is 2 pi divided by 3 radians. 2 pi divided by 3 radians will be 120 degrees. And what about 90 degrees? 90 degree in this particular case will be, that is 90 into 1 degrees. So this will be 90 into, instead of 1 degree, it will be pi divided by 180. It will be pi divided by 180. Pi divided by 180 radians. Now tell me, 0 and 0 will cancel. 9 2s are 18. So this will be pi divided by 2 radians. Okay. Simple. So this is the conversion of degree to, similarly, you can go for the 70 degree also. You can go for the 70 degree also. How can you write this? This will be 70 into, we say 1 degree. This will be 70 into, instead of 1 degree, what can you write? It will be simply, that is pi divided by 180 radians in this particular case. Okay, this and this will cancel. So this will be 7 by 18, 7 pi by 18 radians. Similarly, for 45 degrees, it will come out to be pi by 4 radians. It will come out to be pi by 4 radians. So this is the conversion of degree to angle, degree to radians. Okay. I hope everybody is clear with this. I hope everybody is clear with this. Now, guys, let's talk about the trigonometric ratios. Let's talk about the trigonometric ratios. Everybody knows that when it comes to the trigonometric ratios, let's suppose we have got the triangle over here. In this triangle, could you please tell me what is the value of sine of theta? These sine theta, cos theta, tan theta, this is what we call the trigonometric ratios. How do we find the sine theta? You might have heard that some people have curly black here to present beauty. Okay, so that is the phrase you guys are supposed to remember. Some people have sine theta, that is perpendicular by hypotenuse. So this will be perpendicular by hypotenuse. Similarly, if you find the cos theta over here, cos theta will be base divided by hypotenuse. Similarly, if you find tan theta in this triangle, so that will be perpendicular divided by base. So these are called the trigonometric ratios. Sir, only these three we have got total of 6. So inverse of cos is cosec. Sorry, sine is cosec. Cosec theta will be, if it is perpendicular by hypotenuse, that will be hypotenuse by perpendicular. And opposite of this is, I can say sec theta. So if it is base by hypotenuse, that is hypotenuse upon base, hypotenuse upon base. Okay. And opposite of this is cot. We say cot theta, that will be base divided by perpendicular. It is perpendicular by base. So total of 6 trigonometric ratios: sine, cos, tan, cosec, sec, cot. Okay. And remember this also, when it comes to the sine, we say sine theta is 1 upon cosec theta. It is just the opposite of cosec theta. Similarly, we say cos theta is 1 upon sec theta. Similarly, you can say this tan theta is 1 upon, we say cot theta. 1 upon cot theta. Okay. So this is sine, cos, tan. Okay. Inverse of cosec, inverse of sec, inverse of cot. So these are what we call the trigonometric ratios. Please give me the signal in the chat still over here if everything is crystalline clear. I would want you guys to tell me in the chats if everything is crystalline clear. ASAP, as soon as possible, with the fire emojis. And if you have not liked the session yet, I would want you guys to smash the like button as soon as possible. Okay, great. Great. Next, my dear friends, you have got the trigonometric table. Okay. And I'll be showing you the trick. How do we exactly draw this trigonometric table? Okay, guys, see the trick. Let's suppose you have made the table over here. This is 0 degree, 30 degree, 45, 60, 90, 180, 120, 135, 150, 180. Okay. Sine, cos, tan. Okay. Now, guys, take a look. Everybody listen to me very carefully. First and the foremost thing is, you draw a mirror over here. This is the mirror that I'm placing. Okay. So for what? We place the mirror so that it will create the image. Okay. Exactly over here at 90 degrees, we have to place the mirror. Guys, see. Guys, everyone means everyone. Look at the board. You just have to remember this line. Only you have to remember this line. Rest of all the things I will derive with the trick. See, when it comes to the 0 degrees, we say sine of 0. Sine 0 degree is 0. Sine 0 is 0. Please remember it. Okay. Then we say 30 degrees. Sine 30 degrees is 1 by 2. Sine 30 is 1 by 2. Then we say 45 degrees. Sine 45 is 1 by root 2. Done. Then we say sine 60 degree, that is root 3 by 2. Done. And then we say sine 90 degree, that is 1. Okay. 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. So these are the things you guys are supposed to remember. Done, sir. Now, when we talk about the cos, see, if you have got 90 degree over here, I would want you guys to focus exactly. See, if you have got 90 degree over here, at 90 degrees sine is 1. Just take this 1 exactly from over here and place it in front of this, okay, in the starting. Take this 1 from here and place over here. So cos 0 is 1. Then take this root 3 by 2 and place over here. Cool. So cos 30 is root 3 by 2. Okay. And this 1 by 2 place it as it is at the similar position. Then you reached here. Take this and place it over here. So means cos of 60 degrees 1 by 2. Then take this 0 and place over here. So means cos of 90 is 0. What you are supposed to do when you write this, take this 1 place over here, root 3 by 2 here, 1 by root 2 as it is. So 1 by 2 and this will be 0. Done with this? Yes, sir. Now, guys, when you place the mirror, don't you think that this mirror is going to create the image of this on this side. Yes, guys, if you are placing the mirror, if you place the object in front of the mirror, mirror will create the image behind it. So if it is root 3 by 2 over here, don't you think that behind the mirror here also it will be root 3 by 2, root 3 by 2, root 3 by 2? Yes. Okay, then we say if it is 1 by root 2, here behind the mirror it will be 1 by root 2. Okay, then in front of the mirror it is 1 by 2, here it is 1 by 2, here it is 0, and here it is 0. So you can say sine of 120 is root 3 by 2, sine of 135 is 1 by root 2, sine 150 is 1 by 2, sine 180 is 0. So done with the first line. Next, guys, see. Similarly, this mirror will create its image. So if it is 1 by 2 over here, so write 1 by 2. Okay, sir, why is this minus? Here you have to do this, okay? When it comes to the cos, you have to put the negative sign after 90 degrees, okay? 120 minus. Okay, here we have 1 by root 2, here you have 1 by root 2. Here you have root 3 by 2, here you have root 3 by 2. Here you have 1 and you have got 1. Just place the negative sign. Just place the negative sign over here. Done. Then we have got the tan theta. Guys, always remember one more thing, that is, we say tan theta is always equal to sine theta divided by cos theta. Tan theta is sine theta by cos theta. Now guys, sine by cos will be tan. So 0 by 1 is 0. 1 by root 2 divided by root 3 by 2 will be 1 by root 3. Solve it will come out to be 1 by root 3. 1 by root 2 divided by 1 by 2, it will come out to be 1, because this and this will cancel, so it will be 1. Root 3 by 2 upon 1 by 2, 2 and 2 will cancel, it will be root 3. And here we say this is undefined. At 90 degree, it is undefined. Now, this mirror will create the image of all of these. If it is root 3, here it is root 3. Just place, when it comes to the cos and tan, place the negative sign from the other side. Okay. So it is root 3, it is root 3. It is 1 over here, it is 1 over here. It is 1 by root 3, it is 1 by root 3. It is 0 over here, it is 0 over here. Just put the negative sign. Please give me the signal in the chats if everything is crystal and clear. Tell me, guys, if everything is crystal and clear. That's nice. That's great. Okay, great. Now, guys, an important point over here. You see, value of sine theta is between -1 and +1. Clearly, you can see. Guys, when it comes to the value of sine theta, since this table is still 180 only, but when it comes to the value of sine, it will be between all the values of sine. It will be between -1 and +1. Okay, all the values of sine, 120, sine 60, sine 35, okay, sine 40, sine 37, whatever it may be, all those values lie between -1 and +1. Cool. And when it comes to the values of cos, it will be between -1 and +1 also. This is the maximum value of sine. Maximum value of sine is +1. Maximum value of cos +1. You can't say, sir, can the value of sine be 2? No, value of sine cannot be 2. Sir, can the value of sine be 6? No, it cannot be 6. It can lie between -1 and +1 only. Similarly, value of cos for all the angles will be -1 and +1. But when it comes to the value of tan, it will be between -infinity and +infinity. Okay? Okay? As simple as that. -infinity to +infinity. Next point. This I will make you understand with this example. See guys. Let's suppose you have got a question over here. You have got a question over here. If tan theta is equal to 2, guys, see, this will clear the confusion. If tan theta is equal to 2, then find sine theta and cos theta. If tan theta is equal to, guys, let's suppose I'll make the triangle over here. This is the triangle that I'm making. This is the triangle that I'm making. Okay. Now, in this particular case, if I say this is theta, so what does the question say? Sir, question says that tan theta is given as 2. I can also write 2 by 1. And we know that tan theta is perpendicular divided by base. Tan theta is perpendicular by base. So what is perpendicular? 2, what is base? 1. So this is 2 and this is 1. Can you find the hypotenuse? Guys, hypotenuse will be simply, that is, use Pythagoras theorem. Under root of base square plus perpendicular square. 1 square plus 2 square. 2 square is 4 plus 1 is 5. So hypotenuse will be root 5. So this came out to be root 5. Now, tell me in the same triangle, if somebody asks you, what is the value of sine theta? What will you say? Sir, sine theta is perpendicular upon hypotenuse. That will be 2 by root 5. Cool. Sir, when it comes to the value of cos theta is base by hypotenuse. And what is base? That is 1 by root 5. So, value of tan theta was given as 2. You calculated the value of sine theta and cos theta. Similarly, if I say value of sine theta in this particular case is given as 3 by 5, then find the value of cos theta. Okay, take this one. If value of sine theta is given as 2, then find the value of cos theta and tan theta. I can say it is not possible. Not possible. Why? Because maximum value of sine theta is 1. So all the values of sine theta lie between -1 and +1. This is not possible. Value of sine theta cannot be 2. Similarly, if I say if cos theta is equal to 2, then find the value of sine theta and tan theta. That is also not possible. Is this clear? Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Give me the signal in the chats. Everyone means everyone. Okay. Cool. Now there is a famous triangle that is 53-degree triangle. Why am I showing you this triangle? Because you will find that in maximum number of questions out there in a lot of chapters, this triangle will be basically will be using this particular triangle over there. Now take a look. Let's suppose if I talk about the 53-degree triangle. Sir, this 53-degree triangle looks something like this. It looks something like this. This is the 53-degree triangle. And if I say this angle is 53 degrees, then directly remember, if you have got a triangle in which this angle is given as 53, then directly remember this side over here is 4, this side over here is 3, and this side over here is 5. And one more triangle I can say, 37-degree triangle. So if you ever see this 37-degree triangle, means if this angle is 37, then directly remember this side will be 3, this will be 4, and this will be 5. Guys, in both the cases, hypotenuse will be same, 5, 5. But when you check over here, this side is 4. In this case, this side is 3. What does it mean? 53 is bigger than 37. In front of the bigger angle, you have got bigger side. In front of the smaller angle, you have got smaller side. So 37, 3. 53, 4. And here this will be 3. Here this will be 4. Now, if somebody says that find the value of sine of 53 degrees, what will you say? Sine is perpendicular upon hypotenuse, that is 4 by 5. Find the value of cos of 53 degrees. Cos 53 degrees is 3 by 5. Find the value of tan 53 degrees. Tan 53 degrees is 4 by 3 in this case. 4 by 3, perpendicular by base. Next, if somebody asks you, Find the value of sine of 37. Sine of 37. What will you say? 3 by 5. Perpendicular by hypotenuse. Find the value of cos of 37. What will you say? That is base by hypotenuse, 4 by 5. Find the value of tan of 37 degrees. What will you say? That is 3 by 4, perpendicular by base. So this is what we call the 37-degree triangle and 53-degree triangle. Okay. Now guys, you have got over here trigonometric identities. The first trigonometric identity that we have is sine square theta plus cos square theta is equal to 1. Okay, everybody have basically heard about this. You might have studied this in your previous classes, class 9. Sine square theta plus cos square theta is 1. Similarly, cosec square theta minus cot square theta is equal to 1. There is the identity between cosec and cot. This is between sine and cos. Similarly, tan square theta minus sec square theta is equal to 1. Okay. So these are the three identities which I want you guys to remember and keep in your mind. Okay. Just basic simple trigonometric identities. One more thing I want you guys to remember. Since you are remembering every single thing, remember this also. If you ever see sine of a plus b, you will say, sir, sine of a plus b will be equal to sine of this angle, sine of a cos b, then plus sine b cos a. If you get sine of a minus b, then you say sine a cos b minus sine b cos a. If it is plus over here, you take plus over here. If it is minus over here, you take minus over here. Sine of a plus b is sine a cos b, cos a sine b. Simply. And sine of a minus b is sine a cos b minus cos a sine b. Simple. Similarly, if you ever get cos of a plus b or alpha plus beta, here you will be seeing that cos alpha, cos beta, cos a, cos b minus. If it is plus over here, you will get minus over here. Sine a, sine b. Cos a, cos b, sine a, sine b, but place the minus over here. If you get cos of alpha minus beta, here it is minus, then you say similar thing, but instead of minus, you'll put plus over here. So it is cos alpha, cos beta plus sine alpha, sine beta. Means if you take minus over here, here it will be plus. If you take plus over here, here it will be minus. But when it comes to the sine a, sine b, then sine a cos b plus sine a cos a sine b. Okay. Then we have tan of a plus b. Here we have tan of a plus tan of b, tan of a plus tan of b divided by 1 minus tan a tan b, 1 minus tan a tan b. These are the identities that you guys are supposed to remember in this particular case. Let's suppose we are getting the question something like this. If a is equal to b, if the value of this angle is exactly given as the value of this angle, if a is exactly given as b, then find the value of sine of a plus b. Guys, see. Can I say when it comes to the sine of a plus b, you will simply say, sir, it is sine a cos b plus we say cos a, then we say sine b. Now tell me guys, in this case, it is given that if a is equal to b is equal to, let's suppose, theta. If both the angles are same over here, can you not say in that particular case sine of, guys, this a plus b, that is theta plus theta, so it will be 2 theta will be equals to, then you have got over here sine of, we say theta, cos of theta. Instead of a, I'll write theta. Instead of b, I'll write theta. Then I can say over here, this is cos of theta, and we say sine of theta. Now tell me one thing, guys. Sine theta, cos theta. Sine theta, cos theta. Don't you think it is twice? So you can say 2 times of sine theta, and we say cos of theta. So I can say from now onwards, sine of 2 theta is equal, because maximum times we have been using this equation also in many of the questions out there. Sine of 2 theta is equal to 2 sine theta cos theta. Okay. This we use in the range of the projectile. When you find the range of the projectile, over there you will be using this identity. So from now onwards, you will remember that sine of 2 theta is 2 sine theta cos theta. Okay. Next, let's suppose you are given sine of 120 degrees. How can you solve this sine of 120 degrees exactly over here? And please tell me in the chats if everything is crystal and clear till over here. Everyone means everyone. See guys, don't you think that you can write this as sine of, guys, don't you think you can write this as sine of 2 into 60 degrees? Sine of 2 into 60 degrees. So it became something like this, sine of 2 theta, and theta in this case is 60 degrees. So what is the value of sine of 2 theta? You can say it is twice sine theta cos theta, because you recently studied sine 2 theta is 2 sine theta twice sine theta cos theta. So here 120 you can write 2 into 60, that is also 120. So it will be 2 sine theta cos theta. So can you write in this particular case, this will be 2 sine of theta, theta is 60, so sine 60. Then we say cos 60. You can write it, you can break it something like this also. Then you can write this as 2. Guys, what is the value of sine theta? Sine 60. Sine 60 is a root 3 by 2. What is the value of cos 60? That is 1 by 2. Okay. Now this and this will cancel. So answer will come out to be root 3 by 2. Let's check if sine of 120 is root 3 by 2. Let's check from the trigonometric table. Sine of 120 is root 3 by 2. Exactly same. Yes. So it is correct. It is correct. Okay. Let's talk about this one. Could you please tell me the answer of this particular question over here? So we say if A is equal to B, then what is the value of cos A plus B? Guys, tell me one thing. When it comes to the cos of A plus B, I recently told you the cos of A plus B will be simply, guys, take a look. It will be cos of A, cos of B, then minus sine of A, then we say sine of B. See guys, let's cross check it. Value of cos of alpha plus beta, cos alpha cos beta minus sine alpha sine beta. Yes, minus sine alpha sine beta. Now, if I am saying if A is equal to B is equal to theta, let's suppose I'm saying this, A is equal to B is equal to theta. Don't you think that here I need to put, so this will be cos of A plus B, that is theta plus theta. Once again, it will be 2 theta is equal to. Now, from this side, you can say, sir, this is cos of theta, again cos of theta, because A is theta, B is theta. Then minus, you can say this is sine of theta, and then we say sine of theta, because A is theta, B is theta. A is theta, B is theta. Now, can I say in this particular case, cos of 2 theta will come out to be cos theta into cos theta will be simply cos square of theta minus sine theta into sine theta will be simply, that is sine square of theta. So cos of 2 theta will be simply from now onwards, it will be, that is cos square of theta minus sine square of theta, minus sine square of theta. Is this clear? Is this clear? Okay, great. Now guys, let's take a look. if somebody asks you what is the value of sine 75, how can we solve this value of sine 75? Guys, simple. Can I write this as, this will be sine of 45 plus 30 degrees? Because 45 plus 30 itself is what? I can say sine of 75. Now, how can you write this? Sine of A plus B. So what can I write in this particular case? Sine of A, sine A cos B. Sine A plus B is sine A cos B plus cos A sine B. Sine A cos B. Okay. This is A, this is B. So sine A cos B. Then I can say plus cos A cos 45. Then I say sine B sine 30. Sine A cos B plus cos A sine B. Now, tell me in this particular case, what is the value of sine of 45? So this will be 1 by root 2. Okay. Multiplied by, what is cos 30? Cos 30 is, I can say, root 3 by 2. Then we say plus. Cos 45 is 1 by root 2. Sine 30 is 1 by 2. Okay. Okay. Now, guys, in this particular case, what can you write? Further, you can do the calculations, okay? So take this root 3 by, okay, 1 by root 2 you can take common. So 1 by root 2 you can take common. So it will be a root 3 by 2 plus, I can say in this particular case, 1 by 2. Okay. Now 1 by a root 2 and this will be root 3 plus 1 divided by 2. Okay. Please check it from your end also. So this is the value of sine of 75 in this particular case. Okay. Okay. Great. You can write it something like this. This will be a root 3 plus 1 upon 2 root 2. This is the value of sine of 75. This is the value of sine of 75. Okay. Now, guys, take a look. Small angle approximation, extremely important. This is also used in many of the questions that you see in the upcoming time. Small angle approximation. Guys, take a look in this case. Let's suppose you have got over here a triangle. And in this triangle, you say this is perpendicular, this is base, this is hypotenuse, and this is angle theta. Okay. Now, my dear friends, tell me one thing. Can I say, sure, what is the value of this hypotenuse? We know from the Pythagoras theorem, I can say this hypotenuse will be under root of base square plus perpendicular square. Everybody knows it. Okay. So if you are given a triangle, perpendicular is given, base is given, and you have to find the hypotenuse, that will be under root of base square plus perpendicular square. Now, guys, if let's suppose you decrease this angle, okay, so you take this hypotenuse down, okay. So don't you think that in this particular case, if theta is very small, guys, if you decrease this theta over here, if theta becomes very small, don't you think that because of that, this perpendicular will also decrease? So we say perpendicular also becomes small. Okay. And if there is a quantity which is extremely small, and if we do it square, it will become more small. So we can neglect this perpendicular. So you can neglect this perpendicular from over here. So I can say this hypotenuse will be under root of, we say, base square only. If you decrease the theta, perpendicular will decrease. So we say if perpendicular becomes very small as compared to the hypotenuse, in that case, you can ignore it. It is like let's suppose you have got an ocean. You are adding a bucket of water to the ocean. Will it create any difference? Ocean had got the billions of liters of water. If you are adding 1 liter, 2 liter to the billions of liters of water, will it create any difference? No, no. Similarly, B is very large as compared to P. So if you are adding P with B, it will not create any difference. You can neglect this P, so it will become under root of B square. This and this will cancel. So hypotenuse will be equal to, in that particular case, base. H will be equals to base. Okay. Now guys, if I say from this particular thing, this angle, could you please tell me also, what is the formula for the angle? You say, sir, angle is equal to arc upon radius. Okay. Tell me guys one thing. What is the angle over here? That is theta. And what is arc over here? Arc is this perpendicular. This is angle, arc, and this is radius. So arc is perpendicular. Okay. And what is this radius in this particular case? Sir, base is the radius, or you can directly write r. So can you not say in this particular case, perpendicular will come out to be r into theta? Perpendicular will come out to be r into theta. Yes. Now. What did I say? Please don't confuse yourself. We have got a triangle. Hypotenuse is equal to under root of base square plus perpendicular square. If theta becomes very small, perpendicular becomes very small, then hypotenuse will be base, equal to base. Then this hypotenuse will be equal to the base. They are exactly similar. Now take another formula. Angle is equal to arc upon radius. Angle is theta. Arc is this. This is the arc. Because if this is a circle, we say this is the arc. Okay. Same, this is the arc. P by R. R is the radius. Now tell me one thing, my dear friends. Can I say, and this hypotenuse is equal to base is equal to, we can say this is the radius. This is the radius. This is the radius. Now guys, tell me one thing. From this triangle, now, could you please tell me what is the value of sine theta? Sir, sine theta is perpendicular upon hypotenuse. Okay. And what is perpendicular? Perpendicular we got as r theta. And what is hypotenuse? Hypotenuse is base, base is radius. Okay, equals to r. R and r will cancel, so it will be theta. So what I'm trying to say is that directly, if theta is very small, then sine of theta will be equals to theta. If theta is very small, in that case, sine theta will be equals to theta. Because when you decrease the value of theta, then hypotenuse become equal to the base, then it is equal to the radius. And then only you can say P is equal to r theta. Then we got this relation. If theta is very small, sine theta is equal to theta. Also, guys, could you please tell me what is the value of tan theta? That is perpendicular by base. And what is perpendicular in this particular case? That is r theta. And what is base? Base is also r divided by r. R and r will cancel. This is also theta. So if theta is very small, we can say tan theta is also equal to theta. Tan theta is also equal to theta. Let's talk about cos theta. If theta is very small, let's talk about the cos theta. Guys, I can say cos theta is base by hypotenuse. Guys, tell me one thing. What is base? Base is r. Hypotenuse is also r. So it is 1 by 1. So it will be r divided by r. It will come out to be 1. So if theta is very small, you can say cos theta is equal to 1. From now onwards, if in a question they say, sir, theta is very small, what will be the value of sine theta? That will be theta. Like. Example is sine of 2 degree. 2 degree is a very small angle. And we recently studied the if theta is very small, don't you think that in that particular case, we say then sine of theta will be equals to theta. So here I can say value of sine of 2 degree will be equal to 2 degree itself, because this is theta. Similarly, if tan of 3 degree, 3 degree is also small. So what is the value of tan of 3 degree? That is 3 degree directly. Similarly, if you have cos 3 degree, 3 degree is also small. What is the value of cos 3 degree? Sir, if theta is small, if theta is very small, then cos of theta is equal to 1. So can I say cos of 3 degree will be equals to 1? Guys, give me the signal in the chats if everything is crystalline clear. Everyone means everyone. Tell me. Okay. If theta is in the radians, then convert the theta in the degrees first, okay? If that comes out to be very small, then you accordingly make the decision. Now, guys, trigonometric function of allied angles. Trigonometric function of allied angles. Let's take a look exactly over here. This is also important. See, guys, let's suppose I draw a line over here, this kind of y-axis, this is kind of x-axis, okay? Like you have seen in the graphs, x-axis, y-axis. I see. We say, sir, this is what we call the first quadrant. This one is what we call the first quadrant. This is called the first quadrant. Okay. Then this is called the second quadrant. Okay. This is called the third quadrant. Okay. And this is called the fourth quadrant. Okay. First quadrant, second quadrant, third quadrant, and this one is the fourth quadrant over here. This one is the fourth quadrant over here. Now, guys, take a look. Let's suppose you are sitting exactly at this point at 0 degrees. Okay. Now, when you move from here to here, could you please tell me how much angle you have covered? Sir, 90 degrees, because this angle is 90. So you can say, sir, this is 0 degree, and from moving here to here, this is 90 degrees. Then, if you move further and reach over here, how much will be this angle? That will be 180 degrees. So on this line, you will be mentioning 0 degrees. On this line, you will be mentioning 90 degrees. 90 degree, or you can also say that is pi by 2. Pi by 2 radians, because pi by 2 radians is also 90 degrees. Then from here to here, sir, it becomes once again, it is 180 degrees, or you can say pi radians, because we have studied 180 is equal to pi radians. Okay. Then further, if you cut further angle, okay. Now, how much is this angle? This is 270 degrees. 270 degrees. From here to here, this angle is 270. And 270 means 3 pi by 2. 270 means 3 pi by 2. 270 means 3 pi by 2. Okay, 270 means 3 pi by 2. 3 pi by 2 radians or 270. Then if you do the complete If you complete the entire circle over here, one cycle over here, it becomes 360 degrees. This is called the 360 degrees. Either you say 360 degrees, when you complete 360 degrees, you reach onto the same line. Either you say this is 0 or 360 or 2 pi. It's one and the same thing. So guys, take a look. This is 0 degrees. Okay. 0 degrees. And this is from 0 to 90. This is 180. This is 270. This is 360. Okay. So one complete cycle. One complete cycle. Okay. This is first quadrant, second quadrant, third quadrant, fourth quadrant. Now guys, let's suppose if we talk about the first quadrant over here, let's take a look. If we talk about the first quadrant over here, guys, see, from the right side of the first, from this side, we say value of x. Guys, you might have seen here value of x is 0. And we say here value of x is 1, 2, 3, 4, okay, plus 1, plus 2, plus 3, plus 4. And here it is minus 1, minus 2, minus 3, minus 4. From the left side value of this x is minus. Here it is plus. Similarly, from the upper side it is plus 1, plus 2, plus 3. From the lower side minus 1, minus 2, minus 3 and so on. Okay. Now guys, let's suppose if I say, I'll draw a line over here, something like this. Don't you think that this will be the perpendicular of that line? This will be the base of that line. And this line is in the first quadrant. This line is in the first quadrant. I am asking you the simple question. Tell me what is the value of sine theta? Sine theta is perpendicular upon hypotenuse. This is hypotenuse. Okay. Now, guys, perpendicular is from the upper side. And we say it is plus 1, plus 2, plus 3. From the lower side, minus 1, minus 2, minus 3. So here perpendicular is positive. Hypotenuse is also positive. So if this is positive means value of sine theta is positive. So can I not say the value of sine theta in the first quadrant is positive? Yes, sir. Now, let's talk about cos theta. Cos theta is base by hypotenuse. Guys, this base, from the right side, this is positive. From the left side, we say it is negative x-axis, it is negative. So, base is also positive. Hypotenuse is also positive. Okay. So, means cos theta is also positive. So, what we can conclude is, in the first quadrant, value of sine is coming out to be positive. Value of cos is coming out to be positive. Similarly, tan theta is perpendicular by base. Base is positive. Perpendicular is also positive. This is upper side. This is right side. So, tan is also positive. Now, my dear friends, can I say in the first quadrant, all the values of sine are positive, all the values of cos are positive, all the values of tan are positive? So can I say, my dear friends, when it comes to the first quadrant, I can say all are positive. All are positive. I hope this is crystal and clear. Okay. I hope you got the feel. What does this all positive actually mean? All positive means in the first quadrant, sine, cos, tan, everything is positive. Everything is positive. Okay. Yes. Let's talk about the second quadrant, guys. This is the second quadrant. Let's take a line, draw a line in the second quadrant. Now, this is the perpendicular. This is the base. This is the hypotenuse. My dear friends, in this particular case, we say, what is the value of sine? Perpendicular by hypotenuse. Okay. So, in this particular case, you guys can say sine is positive. Why? Because perpendicular positive, height is positive, hypotenuse is positive. Sir, cos, what about cos theta? Base by hypotenuse. Sir, base is from the left side. It is minus 1, minus 2, minus 3, minus 4. Plus 1, plus 2, plus 3, plus 4. So, cos will be negative. Even tan will be also negative. Because perpendicular by base is negative. So, can I say in the second quadrant, we say only sine is positive. Only sine is positive. Okay. Similarly, my dear friends, when it comes to the third quadrant, we say tan is positive. Only tan is positive. The rest of the sine and cos are negative. And when it comes to the fourth quadrant, we say only cos is negative. Okay. Sorry, only cos is positive. So what do we exactly say over here? We say add sugar to coffee. Add sugar to coffee. So means in the first quadrant, all are positive. In the second quadrant, S means sine is positive. In the third quadrant, T is positive. Okay. In the fourth quadrant, we say C is positive, cos is positive. Okay. 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 So that is add sugar to coffee. All sine, tan, cos. In the first quadrant, this is positive, all are positive, sine positive, tan positive, cos positive. Now, what do we have to study in this particular case? Guys, see. What I will write over here, just remember, I say sine function can be changed to cos function and vice versa. Okay. So sine function we can change to cos function. Similarly, cos function we can change to sine function. Sir, what does this change actually mean? Wait. Okay. Sine can be changed to cos and cos can be changed to sine. Okay. Yes. And my dear friends, how do we exactly do it? Just wait a second. Similarly, tan can be changed to cot. Cot can be changed to tan. You can change the sine to cos. Okay. And cos to sine. Tan to cot, cot to tan. Now take a look. Exactly over here. Let's suppose you are given sine of 90 minus theta. Whenever you see, sir, 90 minus theta plus theta, means you have to change the function. What did I say? Sine function can be changed into cos function. So you can say sine of 90 minus theta is, first you write this is cos theta. Because sine can be changed to cos. Now is it plus cos theta or minus cos theta? Guys, tell me one thing. 90 minus theta it is mentioning. Tell me one thing. This is 0 degrees, this is 90 degrees. If I say 90 plus theta, so means this will be in the second quadrant, 90 plus. Guys, plus means anti-clockwise, minus means clockwise. So if I say 90 minus theta, that will be in the first quadrant. Okay. So remember this. Plus means anti-clockwise. ACW. Minus means clockwise. So if I'm saying 90 minus theta means it will be in the first quadrant. This 90 minus theta will be 30 degree, 40 degree. 90 plus theta will be greater than 90. In the first quadrant, we say all are positive. Sine, cos, tan, everything is positive. So can I not say this will be plus cos theta? First of all, sine can be changed into cos. So we change sine to cos. Now, how do we say it is positive or negative? It is in the first quadrant. In the first quadrant, we say cos is. In the first quadrant, we say sine is positive. Now, we say cos of 90 minus theta. Is it in the first quadrant or second quadrant? First quadrant. So cos of 90 minus theta. Cos function can be changed to sine function. Sine of theta. But plus or minus, let's take a look. Sir, cos of 90 minus theta. Cos of 90 minus theta will be first quadrant. So in first quadrant, sine, all are positive means sine is positive. So you have to check whether in the first quadrant if cos is positive or negative. Cos is positive, so it will be positive. Sine of 90 plus theta. So first it will be cos theta because sine can be changed to cos. Now 90 plus theta. 90 plus theta will be the second quadrant. And in the second quadrant, what is the value of, guys, it is mentioning sine. It is mentioning sine. You have to check this sine. In the second quadrant, what is the sine? Sine is positive. If you are converting sine to cos, you have to check in that quadrant if this sine is positive or negative. You don't have to check if cos is positive or negative. No. You have to check if sine is positive or negative. Sine is positive, so it will be plus. Here mention the reason. Because in the second quadrant, sine is positive. Okay. Here, because in the first quadrant, sine, sorry, it is cos over here. Cos is positive. Cos is positive. Now, cos of 90 plus theta. Cos function can be changed to sine function. 90 plus theta. Now, 90 plus theta will be which quadrant? Sir, plus is anti-clockwise. That will be second quadrant. And in the second quadrant, cos is, here only sine is positive. Cos is negative. In the second quadrant, cos is negative. So it is cos of 90 plus theta. So in the second quadrant, cos is negative. So it will be negative. Mention the reason. Because in the second quadrant, cos is negative. That's why we are putting the negative sine theta. Give me the signal in the chats if everything is crystalline clear. Guys, tell me. Tell me. Is this crystalline clear? Okay, great. Now take a look. If you ever see sine of 180 minus theta, okay, if you ever see sine of 180 minus theta, sir, you said sine function can be changed to cos function. Shall I mention over here cos theta or sine theta? Write sine theta only. Because whenever you say 180 degrees, 360 degrees means it is which axis? It is horizontal axis. 180, 360. Horizontal axis does not change the function. I'll write only vertical axis changes the function. Horizontal axis does not. On horizontal axis, what is the angle that is mentioned? 180 or 360 degrees. On vertical axis, what is the angle mentioned? That is 90 or 270 degrees. You clearly see in this particular case, 90, 270, 180, 360. So what should I mention over here? Sine of 180 minus theta means horizontal axis. So it is sine theta only. Now is it plus or minus? 180 minus theta. Guys. This is 180 minus theta. Minus is clockwise. Plus is anti-clockwise. So clockwise means second quadrant. In second quadrant, only sine is positive. In second quadrant, only sine is positive. So sine is positive in the second quadrant. So here it will be plus sine theta. Mention because in the second quadrant, sine is positive. In the second quadrant, sine is positive. Okay, next. What about this cos of 180 minus theta? Sir, Will this horizontal axis change the function? No. So it will be cos theta only. Cos theta only. But plus or minus. See guys, 180 minus theta will be second quadrant. In the second quadrant, only sign is positive. So cos will be negative. So it is minus cos theta. Okay. Because in the second quadrant, we say cos is negative. Cos is negative. What about this one? Sine 180 plus theta. Sir, horizontal axis does not change the function, so it will be sine theta only. But 180 plus theta. 180 plus theta will be third quadrant. See? 180 plus theta is the third quadrant. And in the third quadrant, only tan is positive. So means sine is negative. So this will be negative sine theta. Cos of 180 plus theta. So it will be cos theta only. But 180 plus theta means third quadrant. In the third quadrant, only tan is positive. So this will be also negative. Because cos is negative in the third quadrant. Sine of 270 minus theta. Sir, this is vertical axis. It changes the function. It is cos theta. It is cos theta. 270 minus theta. Let's check which quadrant is this. Sir, it is 270. This is 270 line. Minus theta. That will be third quadrant. In the third quadrant, we say only tan is positive. Means sine is negative. So it will be minus cos theta. I hope from now onwards, there will be no problem in the allied angles. Please give me the signal in the chats, ladies and gentlemen. Everyone, guys, tell me if this is crystal and clear to each and every single student. I don't think you would face any sort of problem afterwards when it comes to this. Okay. Binomial approximation. Binomial approximation. Take a look, guys. See. When it comes to the binomial approximation, we have got 1 plus x whole square. Guys, see. What does this binomial approximation mean? Let's suppose we have got 1 plus x whole square. Can I say it is like a plus b whole square? A plus b whole square. How do we open it? A square plus b square plus 2ab. Okay. And how do we open this? Sir, 1 plus x whole square. That is a square. 1 square plus b square, that is x square, plus 2ab, 1x, 2x. Okay. Now, guys, if I say, understand this point, if x is, we say if x is much less than 1, if value of this x is much less than 1, we say if there is a quantity which is very small, its square will be more small. So you are adding a very small quantity to a very large quantity. In that case, you can ignore this. So I can write this will be 1 plus we say 2x over here. What is the logic that I'm using? If there is a quantity which is very small, okay, so its square, let's suppose you have 0.01, do its square, it will be more small. If it is very small, if you are adding it to a very large quantity, adding a bucket of water to the ocean will not create any difference. This is the bucket of water, this is the ocean. Adding a bucket of water to the ocean will not create any difference. So ignore this bucket of water. You can directly write 1 plus 2x. So you can say 1 plus x whole square will be equal to 1 plus 2x if x is much less than 1. This is the condition. If this condition is not present over here, then you cannot say this. Okay, this is called the binomial approximation. If there is a quantity which is small, its square will be more small, then you can ignore that quantity in the expression. This we use in, I would say, hundreds of problems in physics of JEE and NEET. This binomial approximation. Next, if you have 1 plus x whole raised power n, here also I say x is much less than 1. If x is much less than 1, guys, what did you do over here? 1 plus 2x, 1 plus x whole square, it will be equals to 1 plus 2x. Here you will be writing 1 plus, here you will be writing 1 plus x whole square will be equal to 1 plus x whole raised power n will be equal to 1 plus nx. 1 plus nx. When is it true? It is only true if x is much less than 1. Like here you said 1 plus x whole square will be 1 plus 2x. Here it will be 1 plus nx. Similarly, if you have this, and if I say if x is much less than 1, then you say 1 plus x raised power minus n, that will be equal to 1 minus nx. That will be equal to 1 minus nx. Is this clear? If the power is negative, then you can say 1 minus nx. Sir, when is this true? It is only true if x is much less than 1. Give me the signal in the chats if binomial approximation is also clear. Tell me, guys. Great. Now, we have over here that is GP series. We have over here that is GP series. This topic, GP series. Now the question is, what is this GP series all about? What is this GP series all about? See guys, let's suppose if we have a number 1, it is multiplied with 2. If we have a number 1, it is multiplied with 2. Then again with 2, then again with 2, and so on. Like 1, multiply this 1 with 2. So it will be 1 into 2 is 2. Again multiply this 2 with 2. So 2 into 2 is 4. Again multiply this 4 with 2. 4 into 2 is 8. Again multiply this 8 with 2. 8 into 2 is 16. Multiply this with 2. It will be 32. And so on. This is called GP series. This is called GP series. If you have a number, you multiply it with certain number, let's say 2. Whatever comes out to be the result, multiply that with the same number once again. 2 into 2 is 4. Again multiply with the same number. 4 into 2 is 8. 8 into 2 is 16. This is called GP series. Okay. Now here, 2, 4, 16, then 7, 8. This is not a GP series. A proper pattern is not being followed over here. This is not a GP series. This is the geometric progression series. Okay. Like, if I say, you have got 1, then you have 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on. This is a GP series. This is a GP series. Now, in this GP series, what kind of questions they might ask us? In this GP series, what kind of questions they might ask us? They will ask us, find the sum of all these infinite terms. This is till infinity. Find the sum of all of this. See guys, sir, where do we use this in the physics? In maximum number of questions, electrostatics, gravitation, in magnetism, everywhere we use this particular thing. See guys, we say we have to add all of these. Sir, can we just do the cross multiply and keep on adding this? If you do that, it is till infinity. It will take you your entire life, but still you won't be able to add all of these because this is till infinity. See guys, what do? We say to add all the terms, all the infinite terms of GP series. To add all the infinite terms of GP series, we use the formula. What is the formula that we use? This is the formula that we use. That is S sum is equal to, we say A upon 1 minus R. Sum is equal to A upon 1 minus R. What is this A? A is what we call the first term. A is called the first term. And what is this R? R is what we call the common ratio. I'll show you. Wait a second. In this GP series, what do you think? What is the first term? Sir, that is 1, means value of A is 1. And how do we find the common ratio? Sir, value of A is 1. And how do we find the common ratio? See guys, when it comes to the common ratio, sir, R is the common ratio. I would want you guys to do one thing. We say, take any term over here, whatever you like, any term. Sir, I'll take 1 by 8. Okay, take 1 by 8. Divide it with, if you take the term 1 by 8, divide it with the term which comes before it. What comes before 1 by 8? That is 1 by 4. Now 4 ones are, we say 4 twos are 8. So this will come out to be 1 by 2. Common ratio is 1 by 2. Sir, I'll not take 1 by 8. I'll take 1 by 16. Okay, 1 by 16 divided by term which comes before it, 1 by 8. 8 ones are, 8 twos are. So 1 by 2 here also. So common ratio, common term in all of this is 1 by 2. That is 1 by 2. Now guys, put in the sum. So can I say now sum will be equals to, that is, guys, A, instead of A, what will I write? 1 upon 1 minus R, that is 1 minus 1 by 2. 1 minus 1 by 2. So what will you write sum over here? Sum will be 2 into 1 is 2. 2 minus 1 is 1 by 2. So this is 1 upon 1 by 2. So this will be 2. So sum of all of this is what? 2. Sum of all of this is 2. Sum of all of this is 2. Guys, is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Let's suppose we have got the question over here. The question is, find the equivalent resistance. Find the equivalent resistance. Find the equivalent resistance. Find the equivalent resistance. See guys. If there is a student who is watching for the first time and he hasn't studied the current electricity with me, he can ignore this question. But rest of the students who have studied the current electricity, they have to listen to me. Now guys, see, take a look over here. This is the resistance over here. This resistance and this resistance are in parallel. Now you have got 1, 2, 3, 4. These resistances are in parallel also, identical resistances. This, all of these are parallel. Now see, 1, 2 resistors, 4 resistors. Then you say 1, 2, 3, 4, 5, 6, 7, 8. 8 resistors in parallel. And 16 resistors in parallel. 32 resistors in parallel, and so on, it is till infinity. How do we find the equivalent? See guys, first resistor I'll make over here, this will be R only. Whenever 2 resistors are in parallel, identical resistors, first of all, if there are n resistors in parallel, identical, equivalent resistance will be R by n. If there are 2 resistors, equivalent resistance will be R by 2. If there are 4 resistors, equivalent resistance will be R by 4. If there are 50, equivalent resistance will be R by 50. How many resistors are in parallel over here? 1 and 2. So here I would say equivalent of these 2 is, we say, sir, R by 2. Similarly, equivalent of these 2 is, 4 is 1, 2, 3, 4, that will be R by 4. Equivalent of these is, I can simply say, that is R by 8. And similarly, we say equivalent of next one will be R by 16. And so on, it is till infinity. Now, you have to add these resistors. When the resistors are in series, how do you add the resistors? R1 plus R2 plus R3 plus R4, R5, and so on. So I can say R equivalent in this case will be, that is R plus R by 2 plus we say R by 4 plus we say R by 8 plus we say R by 16 plus so on up to infinity. What you can take common in this one is R equivalent will be, take R as common, so it will be first 1, then it will be 1 by 2, then plus 1 by 4 plus 1 by 8 plus 1 by 16 plus so on. Now guys, don't you think this is a GP series? This is a GP series and this is a GP series. Now you have to add all of these and then you will get the resultant, you will get the net. Now already we solved this in the previous question, 1 plus 1 by 2 plus 1 by 4, 1 by 8, and this is the method. How much came out to be the sum? 2. So instead of all of this, I can write 2. So I can write, so R equivalent will be simply this R, and instead of all of this, I can write this is 2. So it will be 2R. So equivalent resistance of all of this is 2R. I don't have to solve this once again because I did it in the previous question. That's why I directly wrote it over here. That is 2R. Is this crystalline clear? Please tell me in the chats. Guys, tell me. Is this clear? I'll follow this sequence only, okay? Guys, if you have not liked this session, and I would want you guys to smash the like button, everybody out there. Okay, next we have binomial approximation is done. Let me delete it over here. Okay, we have a graph over here. Okay, guys, let's take a look exactly at the graph. The graph says that plot y is equal to x on the graph. Okay. Sir, how do we plot the graph? How do we plot the graph? Everybody, listen to me very carefully. When it comes to the graph, we have got the y-axis. Okay. We have got the y-axis. This is the y-axis. And we have got the x-axis. We have got the x-axis. When it comes to the graph, we have got the y-axis and we have got the x-axis. This is y and this is x. Okay. Yes. Now guys, if it is mentioned that y is equal to x, we have to plot the graph of y is equal to x. What does it mean? It means that if value of x is 1, we say value of y will be also 1. If x is 1, y is 1. If I say value of x is 2, we say value of y is 2. x2, y2. If I say value of x is 3, we say value of y is 3. Okay. Now, value of x is 1 over here, value of 1 is over here. So join these 2 points. So here will be the common point. 1, 1. Value of x is 2 over here, value of y is 2 over here. So common will be over here. Value of x is 3 over here, value of y is 3 over here. So common point will be over here. Now I would want you guys to join this and over here. I would want you guys to join these points. So this is the graph of y is equal to x. Straight line, straight line. This is the graph of y is equal to x. That is a straight line. If x is 0, y is 0. Okay, okay. Similarly, if somebody asks you plot the graph of y is equal to 2. See guys, this is y-axis, this is x-axis, this is y-axis. Y is equal to 2 means value of y is constant. It is not changing. It is 2 only. It is not changing. So here value of y is 1, here value of y is 2. So graph will be this. So y is equal to 2. Okay. Plot x is equal to 3 on x-axis. This is y-axis, this is x-axis. Value of x is 3, constant. So this will be x. Like here x is equal to 1, x is equal to 2, x is equal to 3. Okay, something like this. Okay, this is how we plot the graphs exactly over here. Okay, now guys, let's move on to the slope. Very important, extremely important. Let me just give you the feel of the slope today. Okay, important, very important. Guys, before understanding the slope, let's suppose I'll take over here, I have got, this is the surface of the ground. Okay, and you are placing, this is basically like you have got something over here. Okay, this is the inclination over here. Inclination means, let's suppose if I say you have to climb this inclination, you have to go up. Okay, this is at what inclination? Okay, this is at inclination of theta over here. Okay, let's suppose this is the surface and this is the line. This line is at what angle? This is theta, at theta angle. Similarly, when it comes to the second case, this is the surface. Here, this is less inclined. This is less inclined. Theta in this case is less. Here, inclination is more. Steepness is more. Here, steepness is less. Okay. Can I write in this particular case, it has got less steepness. Okay. And sorry, it has got more steepness. I can write over here more steepness. When it comes to this one, it has got less steepness. It has got less steepness. Now, guys, what does the steepness actually mean? Steepness means inclination. How inclined? Sir, this is zero steepness, no inclination. Sir, inclination is good. Very good. Sir, inclination is extremely large. It is very difficult to climb this. So, this steepness means slope. This steepness means slope. Slope means a line. How much is it inclined with the x-axis? Or something, let's suppose you take a track. How much it is inclined with the x-axis? That is called the steepness. Okay. And here also we have got less slope. Less slope. Why? Because when it comes to the slope, slope means simply steepness or inclination. Now take a look. Guys. If somebody asks you which is more steeper, obviously first one is more steeper as compared to the second one. Now, this steepness, we gave it a new name, that is what we call the slope. Now tell me one thing. When it comes to the first case, don't you think that in this case perpendicular is more? In the second case, perpendicular is less. If perpendicular is more, we say slope is more. So can I say slope is directly proportional to perpendicular? Slope is directly proportional to perpendicular. More perpendicular, more will be steepness, more will be slope. Okay, upon, guys, here, base is less, and you check here, base is more. So if base is more, slope will be less. If base is less, slope will be more. So I can say slope is inversely proportional to base. Slope is directly proportional to perpendicular, inversely proportional to base. Okay. Now, my dear friends, tell me in a trigonometric ratio in which you have got perpendicular and base, sir, it is clearly tan theta. So now you got the perfect feel. Why do everybody says that, sir, slope tan theta? Why do you say tan theta? Because Slope means perpendicular by base. More is perpendicular, more is slope. More is base, less is slope. Similarly, tan theta is also perpendicular by base. Sir, in cot, also there is perpendicular and base, but that is base by perpendicular. So only tan is perpendicular by base. So from now onwards, you'll say that when it comes to the slope, slope is simply perpendicular divided by base. Or we say slope is simply tan theta. Okay. Now, if theta is more, so if theta is more, then tan theta is more. If you increase theta, tan theta will increase. If tan theta increases, we say slope increases. Slope is more. As simple as that. So theta is directly proportional to tan theta. Tan theta is directly proportional to slope. Now, let's take a look exactly over here. Slope. Okay. See guys, I'm taking y versus x graph. Let's understand the slope in y versus x graph. Can I say in this y versus x graph, this is the graph over here that I are taking? Guys, on this x-axis, don't you think that this is base? And here you mention x. If this is base, so it is x. And on this perpendicular, what is mentioned? Y. So this perpendicular will be y. Yx. Now tell me, what is the value of slope over here? You say, sir, slope in this case is tan theta. Tan theta is perpendicular by base. And what is perpendicular? Y by x. So from now onwards, so in case of yx graph, you can simply say slope is y by x. In case of y versus x graph, slope is y by x. Sir, we have heard slope is delta y by delta x, dy by dx. Wait. I'll tell you everything. I will tell you everything. Okay. Okay. Now, guys, let's discuss slope between the 2 points. I'll just write over here. Slope between the 2 points. Slope between the 2 points. Slope between the 2 points. Guys. Understand this point over here. You have got y versus x graph. Guys, see. I've got y versus x graph. This is the graph over here. This is a straight line. Okay. Let's suppose you take this point over here. One point on this line. Its coordinates are x1, y1. This is the x coordinate and y coordinate. Please don't tell me what is this coordinate. Don't ask me what is this coordinate. Similarly, you have got another point. Its coordinates are x2, y2. Okay, how far is it on the x-axis? Okay, if it is x2 means, sir, this will be x2 from here to here. And if this has the x-coordinate x1, so this is at x1. And here it is at y1. How far it is on y-axis, how far it is on x-axis. So similarly, this is x2, this is y2. Now, guys, tell me one thing. In this particular case, you have to find the slope between the 2 points. Okay. Do one thing. If from here to here it is x1, from here to here it is x2, how much will be this? Sir, this will be whole x2 minus x1. x2 minus x1. If this is x2 minus x1, so we say this is x2 minus x1. Similarly, if this whole is y2, this is y1, how much will be this? y2 minus y1. So this will be also y2 minus y1. Now, guys, don't you think that this is perpendicular? This is base. You have to find the slope between this point and this point. Take a look at this triangle. Okay. Okay. Now, my dear friends, when it comes to this triangle, how do we find the slope? Sir, slope is tan theta, that is perpendicular by base. What is perpendicular over here? That is y2 minus y1, x2 minus x1. y2 minus y1, x2 minus x1. And how do you write this? Delta y by delta x. So from now onwards, you'll remember that slope between the 2 points, you say delta y divided by delta x. This is what you need to understand. Slope between the 2 points is what? Delta y divided by delta x. Like over here, you took one point, another point. So then draw this line as base, draw this line as perpendicular. Then is this triangle, tan theta. Whole is x2, this is x1. So this will be x2 minus x1. So this is x2 minus x1. So this will be y2 minus y1, perpendicular by base, delta y by delta x. So between the 2 points, my dear friends, always remember slope is delta y by delta x. Okay. Yes, sir. Yes, sir. Now. Take a look at this question first. Take a look at this question first. Which of the two lines have more slope? This is the line second, this is the line first. This line is making alpha beta angle. This is making alpha angle. Can I say here alpha is greater than beta? This angle is greater than beta, alpha is greater than beta. If alpha is greater than beta, can I not say then tan of alpha is greater than tan of beta? If theta is more, tan theta is more. If tan theta is more, so I can say clearly slope of 1 is greater than slope of 2. Slope of 2. So this line has more slope as compared to the second line. Okay. Yes. Tell me one thing, my dear friends. What about the slope of this line? You say slope of this line. How much angle this is making? Theta in this case is 0 degree. It is making 0 degree with the x-axis. If theta is 0, what is the value of tan theta? Tan 0, that is 0. If tan 0 is 0, what is the value of slope? Slope will be 0. Because slope is tan theta. So if tan 0 is 0, slope will be 0. In this case, this. So from now onwards, you'll remember, if the line is parallel to x-axis, if the line is parallel to x-axis, then slope of that line is 0. If the line is parallel to x-axis, then we say slope of that line is 0. Okay? Okay. And what about this line, guys? This line is making how much with the x-axis? In this particular case, this is 90 degrees. And when it is 90 degrees, could you please tell me what is the value of tan 90? That is infinite. So simply slope in this particular case is infinite. Slope in this case is infinite. Slope in this case is infinite. Okay. Let's take a look at the positive slope and negative slope. Let's take a look at positive slope and negative slope. See, guys. This is the y-axis that we have got. This is the x-axis that we have got. Okay. Now, this is the line, something like this. Let me show you over here. Let me show you over here. this is y and this is x. And over here, this is x and this is y. Now guys, see, I'll just write over here positive slope. Positive slope. Okay. And I'll just mention over here negative slope. Positive slope and negative slope. Let's suppose I'll draw a line something like this. This is a line something like this. Could you please tell me how much is this angle with the x-axis? Sir, when it comes to this angle, we say this angle theta, it is greater than 90. This theta over here is greater than 90, but less than 180 degrees. Guys, this is 180 degrees total, but it is less than 180, greater than 90. If theta is less than 90 and greater than 180, then if remember this, guys. Remember this. If theta is less than 180, greater than 90 degrees, in that particular case, then we say tan theta is negative. In that case, tan theta comes out to be negative. If tan theta is negative, means in that case, slope will be negative. Sir, what you are saying is we are not able to understand. Let me show you. Let me show you from the trigonometric table. Here is the trigonometric table. Guys, see. If theta is greater than 90, less than 180, guys, this is 90. If theta is greater than 90, means 120, 135, 140, 160. Okay, all of these. What is the value of tan? Value of tan is negative, 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 negative. So if theta is greater than 90, less than 180, in that case, value of tan is always negative. Value of tan is always negative. Okay. So I can say, my dear friends, if tan is negative, in that case, means slope will be negative because slope is tan theta. Okay. So means this line will have the negative slope. Always remember, from now onwards, check the angle with the x-axis. If theta is coming out to be greater than 90, less than 180, then you say tan is negative, slope is negative. And if I say the graph is something like this, in this particular case, theta is less than 90 degrees. This is 60, 30, 40. So if theta is less than 90, like tan 45, tan 30, tan 60, we say in that particular case, tan theta will be positive. If tan theta is positive, means slope in that case will be positive. This is called the positive slope and negative slope. This is called the positive slope and negative slope. Okay. Similarly, here, if theta is greater than 90, less than 180, tan theta is negative, slope is negative. And one more important thing, guys, if you ever get a question something like this, okay, this is a straight line. In case of a straight line, always remember, slope at every point is same. Why? Because the angle it is making here with the x-axis, let's suppose 30 degrees. Here also it will be making the same angle with the x-axis, 30. Here also 30, 30. If this line is making same angle with the x-axis at every point, then slope at every point will be same. So slope at point P is equal to slope at Q, slope at R, slope at S, P, Q, R, S. So in case of a straight line, slope at every point is same because theta is same. In case of a straight line, slope at every point is same because theta at every point is same. Yes. Tell me here, guys, in this case, don't you think that these are the parallel lines? This line is making with the x-axis, let's suppose 30-degree angle. How much this will be making? Same 30. Same 30. Because parallel lines make the same angle with the x-axis. Here also slope will be same. If theta is same, we say slope is same. We say in this particular case, we say here, because parallel lines make the same angle with x-axis. Parallel lines make the same angle with the x-axis. Parallel lines make the same angle with the x-axis. So if theta is same, so means slope is same. So m, sometimes you will find that m, what does this m mean? M means slope. If you ever see m somewhere, means that is slope. Okay, tell me, what about this one? What about this one? Let's suppose this is A and this is B. You are supposed to tell me, find the ratio of slope of A and slope of B. See guys, in this particular case, when it comes to the slope of A divided by, when it comes to the slope of A divided by, I say, slope of B, it will be simply, guys, this A is making how much angle with the x-axis? That is 60 degrees. Because you always check the angle with the x-axis, that is 60 degrees. Okay, so that will be tan of, how much this A line making with the x-axis? 60. So that will be tan of 60 degrees divided by, we say, tan of 30 degrees. Okay, what is the value of tan 60? It's 1 by root 3, I guess, huh? 1 by root 3. And what is the value of tan 30? It is root 3. Please correct me if I'm not wrong. Tan 60 is root 3. Tan 30 is 1 by root 3. Tan 60 is a root 3. This is 1 by root 3. Take this in the numerator, so it will be root 3 into root 3 divided by 1. So that will be 3 divided by 1. 3 is to 1. 3 is to 1. Is it clear? Okay. Great. Next. Okay. Let's talk about this one. Guys, see. Let's suppose you have got the graph over here, y versus x, and this is the graph something like this. The graph is something like this. Tell me how much this is making with the x-axis. Theta is less than 90. So can I not say in this case slope will be positive? Slope will be positive. Okay. Sir, what is the C? C is called the intercept. M is called the slope and C is called the intercept. Mention it over here. M means slope. C is called the intercept. Intercept means where the graph is cutting the y-axis. The graph is cutting the y-axis from the upper side, means here on the positive side. So it is +1, +2, +3, -1, -2, -3. So intercept in this case is positive, slope in this case is positive. Always remember this. Okay. Intercept is positive, slope in this case is positive. Guys, before this, let me just tell you one thing. If I say equation of a straight line, equation of a straight line. Straight line. Let's suppose if I make the graph over here. Let's suppose if I make the graph over here. The graph is something like this. This is y, this is x. This is y and this is x. See guys? We say equation of a straight line is simply y is equal to mx plus c. What is this m? M means the slope. M means the slope. X means this x-axis, y means this y-axis, and c means the intercept. Okay? We say equation of this straight line is this, y is equal to mx plus c. Now guys, in this particular case, where it is touching the y-axis or from where the graph is starting, origin, so means here intercept is 0. Intercept is 0. And guys, sure. Can I not say slope of this graph is positive? Slope of this graph is positive. Slope of this graph is, why? Because theta is less than 90 degrees over here. Theta is less than 90 degrees over here. Now tell me, let's suppose if I give you the example something like this. Let's suppose the graph is given over here. This is y-axis, this is x-axis. This is y and this is x. And tell me, my dear friends, in this particular case, the graph is something like this. Can you tell me what is the value of slope? Here, theta is greater than 90, less than 180. If this is the case, we say slope here is negative. Slope here is negative. And graph is touching the y-axis over here. Graph is starting from over here. So we say in this case, C is positive. C is positive. Let's suppose if somebody gives you the graph something like this, equation of straight line. If somebody gives you the graph something like this, this is y and this is x. Somebody gives you the graph something like this. Guys, tell me, graph is touching the y-axis over here, so it is starting from over here. So intercept in this case is negative. From the upper side it is positive, from the lower side it is negative. And here theta is less than 90 degrees. So means slope of this is negative. Positive. Slope of this is positive. Intercept is negative, slope is positive. Intercept is positive, slope is negative. And here intercept is 0, slope is positive. Now I hope you are getting what I'm trying to say. Even if somebody gives you the graph something like this. This one. Guys, tell me, here intercept is 0, starting from here origin. And what about the slope in this particular case? Guys, tell me, draw a line over here with this is the x-axis, okay? How much angle it is making with the x-axis? Theta is greater than 90, less than 180. So in this case, slope is negative. I hope this is crystalline clear. Please tell me in the chats. Guys, is this crystalline clear? Everyone means everyone. So equation of a straight line is y is equal to mx plus c. Is this crystalline clear? Okay, great. Now tell me. Let's take a look at this. Tell me guys here. Intercept of this is positive. Slope of this is positive. Why? Because theta is less than 90. Tell me here. Intercept of this is positive. Okay? And slope of this is negative. Why? Because theta is greater than 90, less than 180. In this case, mention it. We say theta is greater than 90 degrees, less than 180 degrees. Here. Guys, intercept in this case is negative. See? and slope is positive. Slope is positive. M is positive, C is negative. In this case, guys, see, theta is greater than 90, less than 180. So slope in this case is negative, and intercept is also negative. You check here, intercept, it is negative from the negative side. I hope there is no confusion in this one now. Okay, now before this, let me show you this variation of slope. Okay, let's talk about this one. See, guys, listen to me very carefully. Listen to me very carefully. I say, if I make the graph over here, if I make the graph over here, this is y and this is x. And I am making a straight line over here. I'm making a straight line over here. I'm making a straight line over here. See, guys, I'll just say, in case of a straight line, slope is same at every point. In case of a straight line, slope is same at every point. At every point, we say slope is same. Why? Because theta at every point is same. This is theta, okay? Theta. And here also it is theta. Here also it is theta. Because theta is same. But when it comes to a curve, let's suppose I'll make it. So this is x-axis, this is y-axis. Y and this is x. If you have got a curve, okay, this is the curve. Okay. Now, my dear friends, don't you think that in case of a curve, slope is increasing? Here it is less slope, it is less inclination, less steepness. Steepness is increasing, and here at this particular point it is very difficult to climb. At this point it is easy to climb. It becomes difficult. Here it is extremely difficult. Why? Because if you check at this particular point, inclination, sir, inclination is extremely large. Let's suppose this is theta 1. Okay. And at this point, if you check the inclination, sir, this is theta 2. Clearly, you can say over here, theta 1 is greater than theta 2. Okay. So I can say steepness at 1 is greater than steepness at 2. Steepness at 2. Steepness at this point is greater than steepness at point 2. Inclination is large. So can I not say in case of a curve, we say slope is changing at every point. So in case of a curve, slope is changing at every point, or slope is different at every point. Slope is not same. And here in this case, slope is increasing. Slope is increasing here. Slope is increasing. Okay. Okay. Now, my dear friends, if you have to find the slope, let's find the slope between the 2 points. Slope between the 2 points on the curve. On the curve. See, let's suppose the curve is given something like this. This is the curve. Okay. And you have to find the slope between this point P, between this point Q. If you find the slope between the P and Q, what you are supposed to do is you join this point P and Q. Join this point P and Q. Okay. Let's suppose this point P, it has got the coordinates, it is at x1 distance from the origin. Similarly, this point Q is at x2 distance from the origin. Okay? Yes. Now, my dear friends, this point P is at y1 distance from the origin. This point Q is at y2 distance from the origin. Okay? Could you please tell me, if I draw a line over here, this line and this line, could you please tell me how much will be the angle of this? How much will be the value of this, sir? x2 minus x1. This is x2 minus x1. How much will be the value of this? y2 minus y1. Now, if this is theta, what is the value of tan theta over here? Let's find the slope now. Slope will be tan theta. Tan theta is perpendicular by base. That is y2 minus y1 upon x2 minus x1. So can I say in this particular case, slope will be simply, that is delta y divided by delta x. So between the 2 points, slope is delta y by delta x. And how do you find it in case of a curve? Join those 2 points, make the perpendicular, make the base, and this is delta y by delta x. Okay? Okay? Yes. Guys, please understand very carefully. Please understand very carefully. So, slope between the 2 points, whether it is a curve, whether is it a straight line, it is delta y by delta x. It is delta y by delta x. Take a look over here. Let me take you back. Slope between the 2 points in case of a straight line is delta y by delta x. Even I will add over here, even slope at every point is same as slope between any 2 points, on a, in case of a straight line. In case of a straight line. So, my dear friends, in case of a straight line, whatever is the slope between the 2 points will be the slope at every single point. This is the very important point that you need to understand. Whatever is the slope between the any 2 points, same will be the slope at one single point, at every point in case of a straight line. Now, but same is not the case in case of a curve. We say slope between the 2 points, between these 2 points will be different. If you take any other 2 points, slope between this point and this point will be different, between this point and this point will be different, between this point and this point will be different. Even slope at every single point in case of a curve will be different. What I'm saying is that in case of a straight line, slope at every point is same. Even slope between the 2 points will be same as the slope at every point. But when it comes to the curve, slope between any 2 points, every 2 points will be different. Between these 2 points, different. Even slope at every point is different. Slope at every point is different. Please give me the signal in the chats if you understood this point. Please tell me. Please tell me. Give me the signal in the chats. Whosoever is watching, I would want you guys to tell me if this is crystal and clear. If this is crystal and clear till over here, because this is important. We'll take the break at 5 o'clock, exactly at 5. Now see guys, let's suppose if I make the graph over here. This is X, this is Y. And I'll write the heading over here. Slope at a point in case of a curve. Slope between the 2 points we already calculated. Slope between the 2 points we already calculated in case of a curve. Let's find the slope at a point in case of a curve. Let's find the slope at a point in case of a curve. See, let's suppose I'm taking the curve something like this. Okay? Yes. Now guys, I have to find the slope at this particular point. See, what is the method that we actually use? What is the method that we actually use? What I'm saying is that we say take this point P, okay? Zoom this point, okay? To find the slope at point P. To find the slope at point P. I would say zoom it. Zoom it. Guys, when you keep on zooming this point, let's suppose this is the point over here. When you keep on zooming this point, don't you think that it will look like something like this? It will look something like this, okay? Okay, we are zooming it a lot. I know it's a single point. Or you can basically do one thing. You can take a point which is near another point which is extremely near it, which is very close to it, Or you can zoom it. When you zoom this particular point, now you have to find the slope of this particular point. Okay. Don't you think that this is a zoomed view? Don't you think that, sir, this will be the base of this point? This will be the perpendicular of this point. Sir, this point is extremely small. Yes. So its base will be also extremely small. Its perpendicular will be also extremely small. And guys, if there is a quantity which is very small, we write that quantity with over here, this is dx. We write this quantity perpendicular as dy. Previously, this we were taking as delta y, delta x. When base is large, perpendicular is large. But in case of a point, we said this base of this particular point will be very small. Base of this particular point will be very small. Okay. And perpendicular of this point will be very small. Now tell me, let's suppose if this is theta, tell me what is the slope of this point? Sir, that is tan theta. And that is perpendicular by base. That is dy divided by dx. I hope this is crystal and clear why we are taking over here dy and dx. Because we are talking about a single point. In case of a single point, we say perpendicular will be very small, base will be very small. So this is the slope at a point. So from now onwards, you'll be remembering that slope at a point is always dy by dx. Slope between the 2 points is delta y by delta x. Okay, so this is what we call the slope at a point. Slope at a point, dy by dx or delta y by. So that is between the 2 points is delta y by delta x. Okay. Now guys, one more thing I just want to mention over here. I hope everything is crystal and clear. Let's suppose if you have got this curve, you want to find the slope at this particular point. Sir, we know slope at this point will be simply, that is dy divided by dx. Okay, this is the slope at this point. Okay, let's suppose if in the question they are giving you the angle at this particular point, we say, sir, this is theta, 30 degrees. Then you say simply draw a tangent at this point, check how much angle it is making. So slope at this point will be simply tan of theta. Tan theta. Like we say slope is tan theta here also. How do we find the slope? Draw a tangent at the point. Check how much angle it is making with the x-axis. You can find the slope. How to find the slope at this point? Sir, draw a tangent at this point. Check how much angle it is making with the x-axis. Then find tan of that angle. Okay. So at this point, you can say slope at this point will be what? Tan of alpha, because angle is alpha. Or you can say dy divided by dx. Why? Because we say slope at a point is dy by dx. How do we find? If you have a curve, you have to find the slope at a point. Draw a tangent at that point. Check how much angle it is making with the x-axis. So tan alpha, you can say it is dy by dx. Dy by dx, here it is tan theta, and this will be slope, and this will be dy by dx. Tell me, is it crystalline clear? Tell me, is it crystalline clear, guys? This is the maximum detail about the slope. Maximum detail. You will hardly find this much of detail in any of the marathons on YouTube. Okay, I'm telling you, this is the maximum detail about the slope. And if you have not liked the session, and I would want you guys to smash the like button. Okay. Now, guys, let's suppose you have got a curve, something like this. This is the curve that I'm getting. This one. This is the curve. If somebody asks you to tell me the slope at this point, what will you do? You draw a tangent at this point. Check how much angle it is making with the x-axis. Don't you think that theta at this point is less than 90? So what will be the slope at this point? That is positive. If theta is less than 90, slope is positive. Cool. Guys, tell me, slope at this point. Draw a tangent at this point. This tangent is parallel to x-axis. So theta is 0. So slope at this point is 0. Okay. Now, sir, what about the slope at this point? Draw a tangent at this point. Check how much angle it is making with the x-axis. We say, sir, theta is greater than 90, and I would say less than 180. Slope in this case is negative. Positive slope, 0 slope, negative slope. Positive, 0, negative. Positive, 0, negative. Okay. Let's suppose, my dear friends. Okay, here you have got an amazing question. Take a look. Guys, let's suppose the graph is something like this. And here in this particular case, okay, one more thing I just want to say over here. If when it comes to the slope over here, you say, sir, when it comes to the slope over here, initially slope is positive. Okay. Then we say slope is 0. Okay. Then we say slope is negative. Tell me what is happening with the slope. Slope is decreasing. Because positive, 0, negative, slope is decreasing. In this case, slope is decreasing. Okay. Let's take a look at this point. Guys, here already discussed. This way discussed already. What about this one? Sir, if we have to find the slope at this point, let me show you. So this is y-axis, this is x-axis. The graph is something like this. Now take a look. Let's suppose if we take this point, we say draw a tangent at this point. Draw a tangent at this point, okay? Check how much angle it is making with the x-axis. Theta is greater than 90, less than 180. So can I say slope at this point will be negative? At this particular point, slope will be 0. Why? Because it is parallel to x-axis. At this particular point, we say theta is less than 90. Okay. So I can say in this particular case, slope will be positive. Now, what is happening with the slope? Slope is negative, then it is becoming 0, then it is becoming positive. So mean slope is increasing. Slope is increasing. See? Take a look. We have y versus x graph. Okay, done. Let's talk about this one. Guys, see, at this particular point, we say draw a line over here. Slope is less, or we say take this point. Slope in this particular cases, we say something. Okay? Okay. Or here, at this particular point, slope is 0. Because if you draw a line over here, that becomes parallel to x-axis. Slope at this is 0. Okay? And slope at this is positive. So in this case, slope is increasing. M is increasing. M is increasing. From 0 to positive, slope is increasing. What about this one? Guys, at this topmost point, we say slope is 0. Sir, what about this point? Okay, we say here, at this particular point, theta is less than 90. If theta is less than 90, slope is positive. So initially slope is positive. Then slope becomes 0, means slope is decreasing, M is decreasing. Here, at this particular point, we say slope is 0. At this particular point, we say slope is decreasing. Sorry, slope is negative. Why? Because this line is making the angle with the x-axis that is greater. See, this theta is greater than 90, less than 180. Slope is negative, then 0, means slope is increasing. Slope is negative and then decreasing, then 0. So means slope is negative. Means slope is increasing. Negative, from negative to 0, slope is increasing. Okay, yes. What about this one? Guys, here, at topmost point. At this topmost point, we say slope is 0. At this point, slope is negative. Why? Because see, theta is greater than 90, less than 180. So slope in this case is negative. Now what is happening with the slope? From 0 to negative means slope is decreasing. Here increasing, decreasing, 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 increasing. Guys, is this clear? Tell me. Next, we have got the magnitude of slope. Guys, previous one was slope. Now we need to talk about magnitude of slope. See guys, what does magnitude of slope actually mean? Guys, what is the value of slope at this particular point? You say, sir. At this point, is there a slope in the curve? Yes. See. What I'm trying to say is that, let's suppose we have got the two graphs. This is the first graph, this is the second graph. Tell me, in which graph slope is there? In which graph slope is not there? Sir, slope in this case is 0. Okay, no slope, no. Slope in this case is there. Slope is there. Yes, slope is there. Because this is inclined. Sir, what about this? Is the slope there? Yes, slope is there. Sir, positive, negative, not that. That we'll see later on. Or we have already done that. But in this case, slope is present. Okay. No doubt it is a decreasing slope. It is increasing. But slope is present. Slope is present here. Slope is 0. This is called the magnitude of slope. Whether the slope is present in the graph or the slope is not present in the graph. Okay, tell me one thing. Here slope is present at this point. Yes. Here slope is not present. Slope is 0 at this point. Slope is present. Tell me, sir, what about the magnitude of slope? What is happening with the slope? See, maximum number of students get confused with this. When I say slope is decreasing, means initially slope is positive, then 0, negative. Positive, 0, negative means decreasing. Negative, 0, positive means increasing. That's one thing. Another thing is, when it comes to the magnitude of slope, here slope is there. Positive, negative, I'm not talking about that. I'm just talking about, is the slope, is there steepness present over here? Yes, steepness is there at this point. Steepness is there at this point. There is no steepness at this point. Steepness means magnitude of slope. Steepness means steepness is there, steepness is not there. So we say in this case, magnitude of the slope is decreasing. Means steepness is decreasing. Steepness is decreasing. Because slope is decreasing, steepness is, magnitude of slope is decreasing. And when it comes to the slope only, guys, sir, slope initially is positive, then it is becoming 0. Slope in also is decreasing. Magnitude of slope is also decreasing. Now see. This graph, guys, tell me, at this particular point, is there steepness? Yes. Slope is there. Magnitude of slope is there. Positive, negative, I'm not talking about that. Is there steepness? Yes, this is steeper. Is there steepness? No. Tell me what is happening with the steepness. Sir, steepness is decreasing. Means magnitude of slope is decreasing. Magnitude of slope is decreasing. Means steepness is decreasing. Okay. Sir, what about the slope? Sir, initially at this point, slope is negative. See. Draw a tangent over here. That is making greater than 90, less than 180, negative. Then 0. Slope is increasing. Okay. From negative to 0 means slope is increasing. But when it comes to the steepness, magnitude of slope, that is decreasing. Give me the signal in the chats. Is this crystalline clear? Write down in the chats. Every single student, I would want you guys to tell me. Whosoever is watching. Is this clear? Magnitude of slope and slope. Tell me. And in this case, guys, here slope is not, steepness is not there, steepness is 0. Steepness is 0, but here steepness is there, no doubt. Initially, steepness is not there, steepness is there. What about the magnitude of slope in this particular case? Sir, magnitude of slope is increasing. So we say steepness is increasing. Steepness is increasing. Steepness is increasing. And what about the slope, guys? Slope is 0 and slope here is negative. Okay, so means slope is decreasing. Slope is decreasing, but steepness is increasing. Slope is not there. Steepness, no steepness. Steepness is there. There is a difference between the value of slope and the steepness. Value of slope or the magnitude of slope. I hope this is crystalline clear. Next. Finally, we have arrived on to the differentiation. Now we are starting the differentiation. Okay. Now we are starting the differentiation. Okay. Guys, let's understand the concept of differentiation first. Let's understand the concept of differentiation first. See. In this particular case, let's suppose when it comes to the differentiation, see, Okay, let's understand with this example. Let's understand with this example, or let's start with this example itself. See, my dear friends, if the car is moving from this point to this point, from A to B, from A to B, okay, like from Delhi to Mumbai, the car is traveling from Delhi to Mumbai, okay, and when the car reached exactly at Mumbai, I am asking you, what is the speed of the car? You say, sir, when it comes to the velocity of the car, we say velocity. You say simply, that will be, how do you calculate velocity? Total displacement traveled, total time taken. So I am saying total displacement traveled, okay, upon, we say total time taken. Okay. So guys, V is equal to total displacement traveled. You say, sir, that is 100 kilometers. Sir, how much is the total time taken? Or you say, sir, this you can write total displacement traveled will be delta D. Total time taken will be delta T. And how much is delta D? Sir, it will be simply that is D2 minus D1. D2 minus D1 upon T2 minus T1. Sir, how much is the total displacement? Guys, either you write total displacement traveled, delta D, D2 minus D1, it's one and the same thing. So, my dear friends, so this is delta D and this is delta T. So, you'll say, sir, this is 100 divided by 10. This and this will cancel. So, it is 10 kilometer per hour. Now, this 10 kilometer per hour you got. What is this? This is the speed from A to B. Okay. So this 10 kilometer per hour is the average speed from A to B. This 10 kilometer per hour is the average speed from A to B. Okay. Now, my dear friends, what does it mean? It means every hour you were covering how much distance? 10 kilometers. Every hour, 10 kilometer. Every hour, 10 kilometer. Okay. Yes. Now, guys, what I'm trying to say in this particular case is, if I ask you, find the speed at any particular instant. Guys, the speed that you are telling me from A to B is in general. Average speed, sir, from A to B, how much is the distance traveled, how much is the time taken? So divide them, you'll get the average speed. But what if I ask you to tell me the speed exactly at this point? Okay, from Delhi to Mumbai, it is not possible. From Delhi to Mumbai, just a second, guys. From Delhi to Mumbai, it is not possible that the speed of the car can be 10 kilometers constant. No. Sir, at this point, it can be 5. At this point, it can be 25. Sometimes you stop over there, okay, in order to have some tea, in order to have lunch. Okay, so speed at different points is different. So find the speed at any particular instant. That is called the instantaneous speed. Now, this became the biggest problem in solving this question. So, we introduced the concept of differentiation. Differentiation helped us to find the speed at any particular instant. What is this? What is this? Guys, what is this? So, this 10 kilometer per hour. This is a rate of change of displacement with respect to time. So, I can say, so we introduced the concept of differentiation. which helps us to find the rate of change at any particular instant. So we introduced the concept of differentiation, which helps us to find the rate of change at any particular. Sir, what is this rate of change? Bro, you are telling me displacement upon time. What does displacement upon time mean? It means rate of change of displacement with time. With what rate displacement is changing with time? If I say 10 kilometer per hour, so it means a rate of change of displacement with time is 10 kilometer per hour. Means every hour 10 kilometer displacement is getting covered, or every hour 10 kilometer displacement is changing. If I say 100 kilometer per hour, what does it mean? It is a rate of change of displacement with respect to time. Means every hour 100 kilometer per hour, 100 kilometers you are covering. So here rate of change is more, rate of change is distance. With what rate you are changing the distance? Every hour 100, every hour just 10. So here rate of change is more, here rate of change is less. So this is the rate of change from A point to B point. If I ask you to tell me the rate of change at any particular instant, so rate of change between the 2 points is d by delta t. Rate of change at any particular instant will be so that will be the instantaneous speed or instantaneous rate of change. That will be simply dd divided by dt. Sir, can you show the questions on this? Yes, later on. As of now, directly. We were supposed to find from A to B what is the rate of change of distance with respect to time. That was speed. Rate of change of distance with respect to time is speed. Rate of change of velocity with respect to time is acceleration. Okay. So from A point to B point, we were supposed to find the speed or rate of change of distance with respect to time. We easily calculated. But at any particular point, when we have to find rate of change of distance with respect to time or speed at any particular instant, we use the concept of differentiation. So that is dd by dt. Guys, you have heard, you said differentiation is dy by dx. What is this? This is rate of change of y with respect to x. What did I do? Instead of d, I am writing y. Instead of t, I am writing x. This is also differentiation. This is also differentiation. Now this is differentiation of y with respect to x. This is differentiation of distance with respect to time. Similarly, you can write dv by dt. Sir, is this also differentiation? Yes. So this is differentiation of velocity with respect to time. Sir, is this differentiation? Is this, guys, is this differentiation? Is this acceleration? Is this rate of change of velocity with respect to time? What is it? It is everything. All the three are same. It's one and the same thing. Either you call it rate of change of velocity with respect to time, or you call it differentiation of v with respect to time, or you call it slope. That is also the same thing. Okay, so dy by dx is, I guess, slope that you studied recently. Sir, according to this, we say differentiation means slope. Yes. Either you say rate of change of one quantity with respect to another quantity, agreed. Or you say differentiation of y with respect to x, agreed. Or you say, in this case, velocity at any particular instant, agreed. All the three are same. Please give me the signal in the chats. Please give me the signal in the chats. Okay. So I can write over here differentiation helps us to find a rate of change of one quantity with respect to another at any particular instant. Okay. So differentiation helps us to find the rate of change of one quantity with respect to another. Okay. Like you can say, sir, ds by dt, differentiation of displacement with respect to time. It will help you to find velocity at any particular instant. Like you can say dv divided by dt. This is rate of change of velocity with respect to time, or differentiation of velocity with respect to time. It will give you acceleration at any particular instant. Okay. Or you say dy by dx, that is general. Differentiation of y with respect to x, or rate of change of y with respect to x. Let's understand graphically. See guys. Let's suppose this is a graph. I am asking you to tell me what is the slope between point P and point Q. You say, sir, this is the base, this is the perpendicular. This is the base and this is the perpendicular. Already we studied. Sir, this perpendicular is y2 minus y1. This base is x2 minus x1. We have already studied this. Now, how do we find the slope? Slope is tan theta. Okay. So slope is, if that is tan theta, that is delta y by delta x. Perpendicular by base. How do you find the slope over here? You say slope in this case will be tan theta. Okay. That is you say y2 minus y1 divided by x2 minus x1. That is delta y divided by delta x. Okay. Okay. Yes. Done. Now, my dear friends, if I ask you, find the slope at any particular instant, at any particular point. What will you say? Sir, when it comes to the slope at any particular point, this is y and this is x. If you have to find the slope at any particular point, let's suppose you have to find the slope at this particular point. Sir, we remember that you said zoom this point. Okay. Then you take small dy, small dx. That will be the slope at this point. Who is telling you this? It is differentiation. Differentiation told you, you take this particular point, you zoom it, or you take one more point near it. Okay. Then if you zoom this point, this will be its base. Base will be dx. Perpendicular will be dy. Small change in x, small change in y, or small y, small x. Then you say in this particular case, slope is tan theta, that is dy divided by dx, dy by dx. So differentiation helps you to find the slope at a point. Or you can also say in real life, differentiation helps you to find the rate of change at any particular point, at any particular instant. Please give me the signal in the chats if this is crystal and clear to each and every single student. Okay. So differentiation helps. What is this? This is differentiation. Either you call it the differentiation or you call it the slope at a point, or you call it the rate of change of y with respect to x. One and the same thing. All the three quantities are similar. I hope for the first time in your entire life, you are getting the crystal clear feel of differentiation. What is the real meaning of differentiation? In real life also and graphically also. I hope this is crystalline clear. Okay. Now, guys, comes how to differentiate. Now we have to understand how to differentiate. Okay. Now there are the formulas that you already studied, that you know. Okay. Let's suppose if we have got y is equal to x raised power n, and you have to do its differentiation. Now, what is this differentiation meaning? Differentiation means now you have to find the rate of change of y with respect to x. You have to find with what rate y is changing with respect to x. Okay, like you were finding velocity 10 km/h. With what rate distance was changing with respect to time? That was velocity. Here, with what rate y is changing with respect to x? How do we find? Sir, power down, take this n down. Okay, x raised power minus 1, n minus 1. Like. You have y is equal to x square. And you have to do its differentiation. See, how do we do the differentiation? dy divided by dx is power down, 2 down, x raised power minus 1, n minus 1, n down, n minus 1, 2 minus 1. So that is 2x, 2 minus 1 is 1, so it will be 2x. Like you have over here. Let's suppose y is equal to 3x cube. You have to do its differentiation. Guys, dy divided by dx will be, if this is 3x cube, take this 3 out, because 3 is constant, take it out. What is the differentiation of x cube? Guys, see. We say power down, 3 down, x raised power minus 1, 3 minus 1. 3 minus 1. Okay. Now, 3 into 3 is 9x. 3 minus 1 is 2, 9x square. Let's suppose you have got y is equal to 16x square. How do we do its differentiation, sir? Its dy divided by dx will be simply take 16 out. Okay. Then you have got this x square. Whenever you have constant, take it out. Differentiation of constant is always 0. Okay. Take it out. Now, my dear friends, take this power down, 2 down, x raised power 2 minus 1, 2 minus 1. So it will be 2 into 16 is 32, x raised power 2 minus 1, 32x. Now, what is 1 by x? Differentiation of 1 by x. Guys, can I write it something like this? Take this in the numerator, x raised power minus 1. If you take it in the numerator, it will become x raised power minus 1. So can I say dy divided by dx will be, guys, power down, minus 1 down, then we say x raised power minus 1, power minus 1, minus 1, minus 1. Power down, power minus 1. So it will be minus x raised power minus 1, it will be minus x2, minus 2. Minus 1 is minus 2. If you take this in the denominator, it will be minus 1 by x raised power 2, because if in the denominator it will become, power will become positive. So minus 1 by x square. Minus 1 by x. Y is equal to root x. See, guys, we can write it something like this. X raised power 1 by 2, because the power of root, value of root is 1 by 2. So you can say dy divided by dx. dy divided by dx will be, guys, power down, 1 by 2 down, x raised power minus 1, 1 by 2 minus 1. So it will be 1 by 2, x raised power minus 1 by 2 minus 1 is how much? 1 by 2. Okay. 1 by 2 minus 1 is minus 1 by 2. Minus 1 by 2. So it will be 1 by 2. How is it minus 1 by 2? Guys, see, minus 1 by 2. 2 into 1 is 2. 1 minus 2 is minus 1 by 2. Do the cross multiply. Huh? So if you take this in the denominator, it will become x raised power plus 1 by 2. Because in the numerator it is minus 1 by 2, it will become plus 1 by 2. Now you can write 1 upon 2. X raised power plus 1 by 2, you can write x 1 by 2 root x. Because power of, instead of 1 by 2, you can put the root over here. y is equal to x raised power 3 by 2. Here dy divided by dx will be power down x raised power 3 by 2 minus 1. Now this will be 3 by 2 x raised power. Guys, 3 by 2 minus 1. 2 into 1 is 2. 3 minus 2 is 1. So it will be 1 by 2. Now you can say this is 3 by 2 root x. Okay? Okay? Because value of root is 1 by 2. You can write it something like this. Okay? Now let's take a break. We'll take the break till 5:45 p.m. This is a long break, guys, huh? Break till 5:45 p.m. check. Okay, guys, welcome back. Let's get started. Okay. Now, guys, let's take a look exactly over here. Let's move on to, we say, differentiation of trigonometric functions. Differentiation of trigonometric functions. Guys, the very first thing over here is, let's suppose if you have got sine x over here, y is equal to sine of x. Sir, what is the differentiation of sine x? You'll simply say, sir, dy by dx of sine x is cos x. Okay. And if you say y is equal to cos x, what is the differentiation of cos x? That will be minus sine x. Differentiation of cos x is minus sine x. Simply. And then you have, if y is equal to, I would say cot x. In this particular case, we say differentiation of cot x will be cos x square of x. Cos x square of x. Okay. And if you have y is equal to cosec x, we say differentiation of cosec x is cosec x cot x. Okay. Then if you have y is equal to tan of x, if you have y is equal to tan of x, we say differentiation of tan x is sec square of x. Sec square of x. Okay. You have to remember this directly. If you have y is equal to sec x, differentiation of sec x is sec x plus tan x. Like over here, for sine it is cos, for cos it is minus sine, for cot it is cos x square of x, for cosec it is cos x cot x, cot x. Then you have tan x, for tan x it is sec square of x, for sec x it is sec x plus tan x. And if you have got e raised power x, for e raised power x it will be e raised power x only. Differentiation of e raised power x is e raised power x only. And if you have y is equal to log of x, so you can say it will be simply 1 by x. It is 1 by x. So this is basically the differentiation of trigonometric functions. Okay. Now guys, let's take a look exactly over here. Differentiation of a constant multiplied with a function, like already we did. How do we, if let's suppose this is a 5 is constant, it is multiplied with the function. How do we do the differentiation of this one? We say simply dy divided by dx. Whenever a constant is multiplied with the function, take that constant out. Okay. Then you do the differentiation of d by dx of what? That is x cube. Now you have to do the differentiation of x cube. I'll directly write over here. Differentiation of x cube will be power down, 3 down, x raised power minus 1, 3 minus 1. So this will be 5 into 3 is 15, and then we say x square. 15x square. Okay. It is 15x square. Like you have y is equal to sine x. What is the differentiation of 2 sine x? D by dx of, guys, take this 2 out. Take this 2 out. Then what is the differentiation of sine x? Whenever you see the constant, take it out. What is the differentiation of sine x? That is cos of x. So this is simply, that is 2 cos of x. That is 2 cos of x. Next we have addition rule of differentiation. Sir, what does addition rule say? Let's suppose if you have got a function y is equal to a plus b. You are supposed to differentiate this. Simply, you will do the differentiation of a separately. You will do the differentiation of b separately. Like example is given over here. y is equal to 4x square plus 2x. You can consider this as A and you can consider this as B. Okay. Let me just tell you, when it comes to the differentiation dy divided by dx, what will you say? For 4x square, it will be 4 into 2. It is simply, we say 8x. For 4x square, it will be 8x. Sir, how? Because for 4x, how do we write it? Sir, 4. And then we say, for x square, power down, 2 down, x raised power 2 minus 1. Then we say plus, plus. What is the differentiation of this 2x? So it is, guys, it is 2. If you have, sir, 4x, what is the differentiation of 4x? See, what is it? Dy divided by dx of what will be? Guys, if y is equal to 4x, what will you say? Dy by dx is equal to d by dx of, instead of this y, what will you put? 4x. Take this 4 out. What remains over there? Dx divided by dx. This and this will cancel, so it is 4. That's why I simply said differentiation of 2x with respect to x is 2. So it is 2. Okay. Now this will be, that is 8x plus 2. Simply, if you have the two functions over here, a plus b, you will differentiate a separately, you will differentiate b separately. So that will be the differentiation. Okay, let's suppose I'll give you one more question in this one. You have y is equal to e raised power x plus, we say cos of x plus, we say log of x. You are supposed to do the differentiation of this one. What will you do? Sir, simply in this case, differentiation dy by dx will be, what is the differentiation of e raised power x? It is e raised power x only. What is the differentiation of cos x? It is minus sine of x. It is minus sine of x. What is the differentiation of log x? It is 1 by x. It is 1 by x. Differentiation of log x is 1 by x. So can I say in this particular case, this dy divided by dx will be, so it is e raised power x, then plus into minus is minus. We can say sine of x, then we say plus 1 divided by x. 1 divided by x. Okay. Okay. I hope this is crystal and clear. I hope this is crystal and clear. Now guys, let's move on to the subtraction rule. Let's move on to the subtraction rule. When it comes to the subtraction rule, you have got y is equal to a minus b. Okay. Simply in this case, you first differentiate this a, then minus differentiation of b, like addition only. Like here, differentiation of, you can consider this quantity as a, you can consider this quantity as b. So I can write over here dy divided by dx will be, differentiation of sine x will be simply, that is cos x, minus, what is the differentiation of x square? Power down, power minus 1, so that will be 2x. This is the answer in this case. Simply a minus b. Differentiation of a minus differentiation of b. Then you have got the multiplication rule. Then you have got the multiplication rule. Sir, what does multiplication rule actually say? Guys, see. If I say y is equal to a dot b, a multiplied by b, and you are supposed to differentiate in this particular case. See guys, we say dy divided by dx will be equals to, that is, we say a, see, if this is one, this is another function a and b, keep this a as it is, keep this a as it is, then db by dx means, then you do the differentiation of this quantity b. If you have got a and b, okay, these are the two functions in the multiplication. First do the differentiation, first keep the a as it is, this function, and then do the differentiation of b, that is db by dx. Then plus, you keep b as it is and do the differentiation of a, that is dA by dx. Like my dear friends, we have got an example over here, that is y is equal to x square. y is equal to x square into sine x. You can consider this as a over here. You can consider as b over here. How do we do the differentiation of the, in case of multiplication? See, I can say dy divided by dx will be simply, keep this a as it is. Then we say differentiation of b, db divided by dx. Then we say plus. Keep this a as it is. Then we say differentiation of a, then keep b as it is. Then differentiation of a, dA by dx. Now guys, see, we said dy divided by dx I can write over here. Keep a as it is. A in this case will be x square. dB by dx, differentiation of sine x. Guys. We say, what is the differentiation of sine x? That will be cos of x. Keep a as it is. Then differentiation of b. Differentiation of sine x is cos x. Then we say plus. Okay. Keep b as it is. B is sine of x. Differentiation of a. What is differentiation of x square? Power down, power minus 1. That will be 2x, 2 minus 1. That is 2x only. Okay. So you can say this will come out to be, that is x square, this cos of x plus, take this 2x over here, 2x sine of x. This is the differentiation in case of the multiplication. Keep a as it is, differentiation of b. Then keep b as it is, differentiation of a. Okay. Like you have this one, y is equal to tan x log of x. Guys, can I say in this particular case, I can consider this as a and I can consider this as b. How do we do the differentiation? I can simply say in this particular case, dy divided by dx will be, keep a as it is. Guys, keep a as it is. That is tan of x. Then differentiation of b. Guys, we can write it something like this, d by dx of log of x. This is called the differentiation of b. As of now, I didn't do the differentiation. I'm just writing the formula. Then we say plus. Keep b as it is. We say log of x. Then differentiation d by dx of a. That is tan of x. Now tell me guys, what is the differentiation of tan of x? You see over here, tan of x, it has differentiation sec square of x. Now, can I write in this particular case? Guys, this tan x I'll write as it is. What is differentiation of log of x? That is 1 by x. Then plus. Keep log of x as it is. Okay. Then differentiation of tan of x, that is sec square of x. Okay. It is log to the base e. Okay. Log to the base e. Now, my dear friends, what I can write in this particular cases, so this will be tan of x divided by this x. Then we say plus, this is log of x into, we say sec square of x. So this will be the final differentiation in this particular case. I hope this is crystal and clear to each and every single student. Okay. Yes. Next, division rule. Division rule of differentiation. Let's take a look at this, guys. Let's take a look at this. What does division rule actually say? Let's suppose if you have got a and if you have got b over here, y is equal to a by b. Previously it was y is equal to a into b. Now it is y is equal to a by b. In this case, if you have to do the differentiation, first what will you do? You do the differentiation of a, that is dA by dx. First do the differentiation of a. But keep this b as it is. Keep b as it is, differentiation of a. Okay. Then we say minus. Keep a as it is and differentiation of b, dB by dx. Then divided by b square. First, what you are supposed to do, differentiation of a, keep b as it is. Whatever is in the denominator, keep that as it is. Minus, keep a as it is, differentiation of b, divided by b square, divided by b square. Let's suppose we have got this. In this particular case, you can consider this as a over here. You can consider this as b over here. What does it say? In case of division rule, we say dy divided by dx will be simply, that is differentiation of a, dA divided by dx. Okay, but keep b as it is, keep b as it is. Then we say minus differentiation of b, dB divided by dx. Okay, and keep a as it is. Then we say divided by, we say b square. First, you have to do the differentiation of a, keep b as it is. Then differentiation of b, keep a as it is, divided by b square. Now see guys, can I write dy divided by dx in this particular case? Differentiation of a. What is a? Sin x. What is the differentiation of sin x? That is cos x. So I can write cos of x over here. What is b? Keep b as it is. B is x square. So I'll write over here x square minus differentiation of b. What is the differentiation of x square? Sir, that is 2x. Power down, power minus 1. So I'll write over here 2x. Keep a as it is. What is a? That is sine of x divided by, I can say, b square. That is x square whole square. That is x raised power 4. This is the differentiation. This is the differentiation. That's it. Okay. This is the differentiation. Let's suppose if you have got one more example. Y is equal to cos of x divided by e raised power x. In this particular case, you can consider this as a and you can consider this as b. Now tell me, how do we write dy by dx? We can say dy divided by dx will be simply, guys, differentiation of a, differentiation of a. What is differentiation of a? That is minus sine of x. Okay. Then keep b as it is. B is e raised power x, so keep e raised power x as it is. Then we say minus differentiation of b, differentiation of e raised power x. So differentiation of e raised power x is e raised power x only. Okay. And then we say keep a as it is. Keep a as it is. A is cos of x. So I'll write over here cos of x. Then b square. I can write over here e raised power x. I can say whole square. Okay. Okay. Simply. This is the thing. That is what we are supposed to do over here. Now comes basically the chain rule of differentiation. Now comes basically the chain rule of differentiation. Okay. Now guys, y is equal to sine of x square. See guys, what does chain rule of differentiation say? See, when it comes to the chain rule of differentiation, we say, directly remember guys the formula. It is like dy divided by dx will be, first I'll write over here differentiation of outer function multiplied by differentiation of inner function. Let me show you how do we do it. Guys, see, let's suppose you are having over here this y is equal to sine of x square. It is not x over here, sine of x square. And in this case, you have to do the differentiation of this one. See guys, I can say, sir, first here we need to use the chain rule. What does chain rule say? You first do the differentiation of outer function, then you do the differentiation of inner function. See, sir, what is the outer function? First you have to define that. Outer function is this. I'll write over here, outer function. It is simply sine of x square. Outer function is this, which is the general function out. And when it comes to the inner function is whatever is in the angle, that is x square. Sir, in case of sine x, could you please tell me what is outer function? Sir, outer function is sine x, inner function is x. Inner function is x. Now, what does the chain rule say? Differentiation of outer function multiplied by differentiation of inner function. Now, apply the chain rule. dy divided by dx will be differentiation of outer function. Guys, what is the differentiation of sine? That is cos. So, I'll write cos of. If it was x over here, then I would have written cos x. It is cos of x square. So, it is sine x square. So, I'll write cos of x square. Because the differentiation of sine is cos. So, this is the differentiation of outer function. Now, differentiation of inner function. What is the differentiation of inner function for x square? What's the differentiation of x square? That is 2x. So, I'll just write over here. That is. So, differentiation of this will be 2x cos of x square. This is how do we apply the chain rule. Guys, in this one, could you please tell me what is the outer function? Outer function. You say outer function is sine of 4x. Sir, inner function in this particular case is, we say 4x. Inner function is 4x. Outer function is sine of 4x, inner function is 4x. Now, what will be the dy by dx? Dy divided by dx in this case will be simply differentiation of outer function. Sir, for sine it is cos, so it is cos of 4x. Okay. Differentiation of inner function, for 4x it will be 4. So it is 4 cos of 4x. Now guys, one more thing. Sir, what about sine of x? What is the differentiation of sine x? You directly said differentiation of sine x is cos x. Can we use the chain rule over here? Yes. Use the chain rule. What is the outer function? Sir, that is sine x. What is the inner function? That is x. Now apply the chain rule. Chain rule says differentiation of outer multiplied by differentiation of inner. dy divided by dx. Differentiation of outer function, that is sine x, it is cos x. Okay. Differentiation of inner function, what is differentiation of x? That will be 1. Sir, how? See guys, see. If I say y is equal to x, do its differentiation. So I say dy divided by dx will be d by dx of, instead of this y, can I put x? Yes, because y is equal to x. Now dx will cancel, it will come out to be 1. Okay. If I say y is equal to 10x, what will be the differentiation? You will say, sir, dy divided by dx will be, that is d by dx of, guys, instead of y, can I write 10x? Yes, 10x. Take this 10 out because 10 is constant. So 10 out, then it remains dx divided by dx. This and this will cancel, so it will come out to be 10. Differentiation of 10x is 10. Now tell me, so cos x into 1 is cos x. So that's what I was saying. Differentiation of sin x is cos x. Differentiation of sin x is cos x. Okay. Now let's talk about this one. Use the chain rule. I say use chain rule. Can I say in this particular case, guys, when it comes to what is the difference, what is the outer function? When it comes to the outer function, that will be simply whole, that is 2x square plus 3 raised power 4. What is the inner function? Inner function is whatever is inside, that is 2x square plus 3. This is how do we define the outer and inner function over here. Okay. Now tell me guys, when it comes to the dy divided by dx, that is differentiation of outer function. Guys, consider this as x over here. So if it is x raised power 4, what will you say its differentiation? Power down, x raised power 4 minus 1. So it will be 4x cube. Yes. Do the same thing over here. So power down, 4 down. Then I say, whatever is inside, keep it. Don't do anything with that. So keep it as it is. So 2x square plus we say 3. Then 4 minus 1. 4 minus 1. This is the differentiation of outer function. Then differentiation of inner function. That is 2x square plus 3. Now guys, for 2x square, it will be 4x. For 3, it will be 0. How, sir? For 2x square, it will be 2 constant. For x square, it is 2 down, x raised power 2 minus 1. 2 into is 4x. That's what I said. So can I write over here? This is 4 and this is 2x square plus 3. This is 4 minus 1 is 3 and this is 4x. Now 4 into 4 is 16. So it is 16x and then we say this is 2x square plus 3 whole cube. This is how do we do the differentiation. Whatever is the outer function, keep it as it is and then separately do the differentiation of this whatever is placed inside. Okay. Like I'll give you one more something like this. You have got y is equal to, we say 3x square plus 2 whole raised power 5. Tell me in this case, how do we do the differentiation? We say dy divided by dx will be simply, guys, this is the outer function. So power down. So this will be as it is 3x square plus 2 power minus 1. 5 minus 1 is 4. Then this is the inner function which is placed inside. Okay. Yes, you have to multiply it over here. You can. Okay. 4 into 4 is 16x. You can multiply this with this one. There is no problem in that. Now in this case, differentiation of inner function. For 3x square, how much it will be? 3 into 2 is, we say 6x. Now 5 6 are 30x. This is 3x square plus 2 raised power 4. Guys, give me the signal in the chats. Is this clear? Tell me, is this clear? And smash the like button if you have not liked this session yet. Let's suppose you are having the question something like this. Y is equal to 4 sine of 4x square plus 3x. When it comes to the outer function, that will be 4 sine of 4x square plus 3x. When it comes to the inner function, that is this one which is placed inside. That is 4x square plus 3x. Now do the differentiation. Differentiation of outer function. So dy divided by dx. Guys, 4 sine of x, you can consider this as x. Sir, 4 will be out, it is constant. Differentiation of sine is cos, so it is cos. Whatever is in the angle, place it as it is. 4x square plus 3x. This is the differentiation of outer function. Now differentiation of inner function. Guys, what is the inner function? That is this one. So what is the differentiation of 4x square? 4 into 2 is 8. 8x plus what is the differentiation of 3x? That is 3 over here. Okay. Now you can multiply this. 4 into 8 is 32. X plus 4 into 3 is 12. Okay. So you can write it something like this. That is 32x plus we say 12, and then we say cos of 4x square plus 3x. Okay. I can multiply this with this one. No problem in that. But I cannot multiply this with this one because it is inside cos. It is in the angle of cos. That's why. That's why I'm multiplying this with this term over here. Y is equal to e raised power sine x. Guys, see, when it comes to the outer function, that is e raised power sine x. When it comes to the inner function will be sine of x, whatever is placed over here. Now, guys, we can say dy divided by dx in this case. Guys, tell me one thing. Dy by dx over here. What is the differentiation of e raised power x? It will be e raised power x only. What is the differentiation of e raised power sine x? It is e raised power sine x only. This is called the differentiation of outer function. Then differentiation of inner function. What is the differentiation of sine x? That is cos of x. So you can say this is cos of x e raised power sine of x. This will be the differentiation. Okay. First, e raised power sine x will be e raised power sine x only. Why? Because it is like e raised power x. Differentiation of e raised power x is e raised power x only. Okay. This one. This is simple. This is simple. So for this, dy divided by dx will be power down 4 into 2x square plus 3. 4 minus 1 is 3. This is the differentiation of outer function. Then differentiation of this inner function. That will be 2 into 2 is 4x. Now 4 4s are 16x. 2x square plus 3 whole cube. Done. It is simple. Okay, what about this one? Guys, dy divided by dx. See, guys, in this case, you have to use the addition rule as well as you have to use the chain rule. For this, guys, if I say e raised power minus beta x, could you please tell me what is the outer function? This will be the outer function. Okay. What is the inner function? Sir, inner function in this case will be this minus beta x, whatever is in the angle. Now tell me, for this, differentiation of outer function, e raised power minus beta x, differentiation of e raised power minus beta x will be e raised power minus beta x only. Because differentiation of e raised power x is e raised power x only. Okay. Then differentiation of inner function. Guys, differentiation of minus beta x. What will be the differentiation of minus beta x? Beta is constant. See. It is differentiation of minus 4x. What will you say differentiation of minus 4x? Sir, it is dy divided by dx. Y is equal to minus 4x. So you can write d by dx of, sir, instead of this y, you can write minus 4x. Sir, minus 4 will be out. It is constant. Then dx divided by dx. This and this will cancel, so it is minus 4. Sir, can I say similarly differentiation of minus beta x? If I say y is equal to minus beta x, dy divided by dx will be d by dx of, what is the value of y? That is minus beta x. Okay. Now guys, take this minus beta out over here. So it is dx divided by dx. This and this will cancel. It is minus beta. Okay. So differentiation of, we say minus beta x will be minus beta, then plus. Guys, tell me what about this? Differentiation of outer function, e raised power minus alpha x. This is the outer function. And what is the inner function over here? Alpha x. So differentiation of alpha x is minus alpha. So can I say this will be, take this beta over here. So minus beta e raised power minus beta x minus alpha. So minus alpha e raised power minus alpha x. I hope this is clear. When the power is given, you have to apply the chain rule. Yes, you need to apply the chain rule over here. Yes. Okay. Chain rule is basically the normal differentiation only. So if you get a, see, if I say here it is x raised power 4. Sir, do you have to apply the chain rule over here? No, directly you can say, sir, power down x raised power 4 minus 1. But if you have, instead of this x, you see over here 2x square plus 3 whole raised power 4. Here it is difficult for you to differentiate. That's why in this case, we apply the chain rule. Depends upon the question. The more practice you do, more you would be able to understand in which question I am supposed to use which rule. Okay. Next, what about this one? This one you can do easily. Let me show you this. Guys, you can write it something like this. Cos of x whole square. It's one and the same thing. Cos square of x or cos of x whole square. Now, what is the outer function over here? Outer function in this case is cos of x whole square. What is inner function over here? Inner function is whatever is placed inside, that is cos of x. Okay, now see, what is dy by dx? Differentiation of outer function. Outer function is this. So that will be power down, 2 down, cos of, we say 2 minus 1. That is 2 minus 1. Okay, cos of x 2 minus 1. Then differentiation of inner function. What is that differentiation of cos x? That is minus sine of x. Now I can write over here, take this minus over here, minus 2. 2 minus 1 is 1. Cos x. Then you have this sine x. Differentiation of outer function, differentiation of inner function. Guys, tell me in the chats, is this clear? Is this clear? So cos of x whole square is the outer function. Cos x is the inner function. So differentiation of the outer function, that is power down, power minus 1. Then differentiation of inner function, that is cos x. For cos x, it is sine x minus sine. What about this one? Let's see. Here you can write it something like this. It is 2x plus 3 whole raised power 1 by 2. Because value of root we consider as 1 by 2. Now what is the outer function over here? We say outer function in this case is whole. That is this one only. 2x plus 3 whole raised power 1 by 2. What is the inner function in this particular case? That is 2x plus 3. Now I can say dy divided by dx. Differentiation of outer function. That is power down 1 by 2. This will be 2x plus 3 1 by 2 minus 1. Okay? Because here whatever is placed inside, you keep it as it is. Power down, power minus 1. So this is the differentiation of outer function. Then differentiation of inner function. Inner function is this. For 2x it will be 2. For 3 it will be 0. Because differentiation of constant is 0. Constant is not changing. Differentiation means change, rate of change of y with respect to x. Constant does not change, so its differentiation is 0. Okay. Okay. Now guys, in this particular case, I can write This will be 1 by 2. Take this 2 over here, so it will be 2 by 2. Okay, so 2 and this 2 will cancel over here. So what remains over here? That is 2x plus 3 whole raised power 1 by 2 minus 1. That is minus 1 by 2. You can write it something like this. If you take this in the denominator, it will be 1 upon 2x plus 3 whole raised power plus 1 by 2. Because if this goes in the denominator, power becomes positive. So now you can write 1 upon under root of, this will be 2x plus 3. Because instead of 1 by 2, you can put the root also. You can put the root also. Okay. Okay. Similarly, this I'll give you as homework. Outer function is whole. Then you have got the inner functions over here. You can do it by yourself. Okay. Do let me know the answer of this in the comments. This is already we have done. This is okay. You have got the double differentiation. Guys, give me the signal. Is this clear till over here, everyone? Is this clear till over here? We say, what does double differentiation actually mean? See guys, let's suppose you have got y is equal to x square. I say double differentiation means differentiating a function twice. What is the differentiation of x cube? You say dy divided by dx will be simply, guys see, we say dy divided by dx will be simply, that is power down x raised power 3 minus 1, that is 3x square. So this is called differentiation once. If we do it differentiation twice, now do the differentiation over here. That is d2y divided by dx2. This means double differentiation of y with respect to x, d2y by dx2. Now tell me in this case, for 3x square, how do we do the differentiation? Sir, 3 out, and for x square, what do we do? Power down, 2 down, x raised power 2 minus 1. So this will be 3 into 2 is 6x. So double differentiation of x cube is 6x. Single differentiation of x cube is 3x square. So double differentiation means differentiating twice. Let's suppose you have got this. Y is equal to e raised power alpha x. Guys, see. When it comes to the differentiation, dy divided by dx, use the chain rule in first differentiation. Outer function, differentiation of outer function, that is e raised power alpha x only. Because differentiation of e raised power x is e raised power x only. So differentiation of e raised power alpha x is e raised power alpha x only. Multiplied by differentiation of inner function. So differentiation of alpha x will be alpha. So what comes out to be, so alpha e raised power alpha x is the final answer. This is the differentiation once. If we do the differentiation twice, that is d2y divided by dx2. Guys, take this alpha out. Now once again start the chain rule of this. Differentiation of this function, outer function e raised power alpha x, okay, multiplied by differentiation of inner function. For alpha x, it will be again alpha. Now alpha into alpha will be alpha square, e raised power alpha x. This is called the double differentiation. If you again do its triple differentiation, this becomes alpha cube e raised power alpha x. First, differentiation of e raised power alpha x is e raised power alpha x outer function multiplied by differentiation of inner function, that is alpha. Take this alpha out. Now do the differentiation of this once again. Alpha is constant, take it out. Differentiation of e raised power alpha x is e raised power alpha x multiplied by differentiation of alpha x, that is alpha. So alpha into this alpha will be alpha square e raised power alpha. Let's suppose you have got this. Let's suppose you have got this. Y is equal to a sine kx. Guys, what is dy divided by dx? A is out. Differentiation of sine x, that is cos of kx. Okay, cos of kx. Now, this is the outer function. What is the inner function kx? So I can write differentiation of kx will be k. Guys. Constant. Take constant out. Now this is the function. So this whole will be the outer function. This will be the inner function. Differentiation of sine is cos of kx. Then differentiation of inner function kx, it will be k. Now it will be a into k. That is a into k cos of kx. This is differentiating once. This is differentiating once. Let's do the differentiation once again. That is d2y divided by dx2. Simply. Guys, this is ak. Okay, this is ak. Now tell me, differentiation of cos of x. Differentiation of, guys, see. Once again, use the chain rule. Differentiation of cos x is minus sine of kx. Okay, then differentiation of inner function. This is outer function. Then differentiation of inner function, that will be again k. Okay, k into k becomes k square. So minus out, minus a k square. Then I say sine of kx. A k square sine of kx. So this is the double differentiation of this. Come on, give me the signal in the chats if everything is crystalline clear. Tell me, guys. Guys, is this clear? Please tell me in the chats. When should we use the double differentiation? When they ask you to use the double differentiation, then you are supposed to use the double differentiation. What kind of question is this? Now, guys, let's understand the concept of maxima and minima. Let's understand the concept of maxima and minima. Okay. See, guys, let's suppose I am taking a graph over here. I'm taking a graph y versus x. This is a very important concept. In maximum number of concepts questions in the upcoming time, you'll be using this. This is very important. Okay. See, guys, take a look. If you have got a graph y versus x, you have got a graph y versus x. Okay. And the graph is, let's suppose, something like this. Could you please tell me what is the highest point on the graph? Sir, this is the highest topmost point on the graph. as of now, please consider it maxima. Okay, as of now, I am saying consider it. Okay, later on we'll prove it. So we say this is what we call the maximum value of y, that is called the maxima. Sir, what is the minimum value of y? This is the lowest point, minimum value. So this is called y minimum. Maxima and minima, the highest point on the graph at which the value of y is maximum is called the maxima. The lowest point on the graph at which the value of y is minimum is called the minima. Okay, and this maxima is at x1. This maxima is at x1. This minima is at x2. Let's suppose this is x2 over here. Okay, yes. Now guys, see. If you take this particular point, if I am saying find the slope, you draw a tangent. Now this tangent is parallel to the x-axis, so slope at this point is 0. Okay, and if you draw a tangent over here also, so here also slope is 0. So dy by dx, either you say slope or you say dy by dx, okay, is 0. Okay, now guys, be it minimum, be it maximum, we say at both the points dy by dx is 0. I can write the first point at maxima and minima. We say slope dy by dx is equal to 0. So from now onwards, if you ever see any point on the graph at which dy by dx comes out to be equal to 0, then simply consider that point either as maxima or minima. Okay, how do we exactly find any particular point as maxima or minima? See guys, so what is the first thing I told you? At maxima and minima, dy by dx is 0. Highest point dy by dx is 0, lowest point dy by dx is 0. Okay, now take a look. Let's see. This is, if you say, sir, this is maxima over here, topmost point. Now tell me one thing. We say, if you check over here at this point, what is the value of slope? Sir, value of slope is positive because theta is less than 90. So value of slope is positive here. And value of slope here is 0. Here it is positive, here it is 0, and value of slope here is negative. Why? Because it is greater than 90, less than 180. Now see, if you take this maximum curve, at maxima slope is 0. Initially slope is positive. Finally slope is negative. Okay. Now guys, tell me one thing. In this particular case, could you please tell me, sir, what is happening with the slope over here? Is slope decreasing or increasing? Sir, positive 0, negative, slope is decreasing. So I can say slope is decreasing. Okay. Now, listen. If there is a quantity which is decreasing, okay, its change will be negative. Like, let me give you the example. See, I'm saying there is a car over here. This car is moving with a speed of 10 meters per second. And here its speed is, let's suppose, 5 meters per second. Okay, or it is 20, this is 10 meters per second, 10. Speed is decreasing and time, let's suppose 1 second. Could you please tell me what is the change in velocity? You say, sir, change in velocity is final velocity minus initial. 10 minus 20 divided by 1. Change in time. So here it is 10 minus 20 is minus 10 meter per second square. Okay, so the quantity velocity is decreasing. Its change came out to be negative 10 minus 5. If the quantity is increasing, guys, if there is a car which is moving with 10 meters per second Here its speed becomes 20 meter per second. Find the change. Change is final minus initial. 20 minus 10 divided by time is 1. So that is plus 10. Plus 10. If there is a quantity which is decreasing, its change will be negative. What does change mean over here? Change means dv divided by dt. Final velocity minus initial velocity, dv by dt. Here also dv by dt. Yes, now take a look. Now take a look. Now take a look. If I am saying in this case slope is decreasing, what is slope? Slope means dy by dx. dy by dx is decreasing. Guys, I'll give you the crystal clear feel. dy by dx is decreasing. If dy by dx is decreasing, could you please tell me, guys, see. What I'm saying is that if dy by dx is decreasing, okay, or you say slope is decreasing, I recently told you, if there is a quantity which is decreasing, its change will be negative. So can I say then change in slope will be negative. If there is a quantity which is decreasing, its change will be negative. Okay, its change will be negative. See, guys, its change will be negative. How do you write the change in slope? That is d by dx of slope. If you say dy by dx, what does this mean? This is change in y with respect to x. Now, what is change in slope? Change in slope with respect to x. Okay. And how can you write this? How can you? And this will be negative. How can you write this? This is d by dx of what is slope? dy divided by dx. Okay. dy divided by dx. Now, guys, can I say in this particular case, this will be negative? What does this mean? This we can write it something like this: d2y divided by dx square. Dx into dx is dx square, d into d is d2y by dx square is equal to negative. What is this? This is double differentiation. Now tell me guys, in this case, in case of maxima, slope is decreasing. If slope is decreasing, we say change in slope will be negative. That is double differentiation of y with respect to x is negative. So I can say at slope, at maxima, dy by dx is negative. d2y by dx is negative. So I can write over here. So at maxima, d2y divided by dx2 is equal to. Wait. I am saying, guys, if there is a, let's suppose this is a point. Is this maxima or minima? You will say, sir, at this particular point, dy by dx is 0. If at a point dy by dx is 0, either it is maxima or it is minima. With this information, you can say either it is maxima or minima. How can you exactly say it is maxima? If d2y divided by dx2 is negative, then it is maxima. If d2y by dx2 is negative, then it is maxima. What is the proof? That I gave you already. Because in case of maxima, slope is decreasing. If slope is decreasing, change in slope will be negative. Change in slope is double differentiation. Change in slope is double differentiation of y with respect to x. So in case of maxima, double differentiation is negative. How many of you understood this? Give me the signal in the chats. Tell me, guys. Now, tell me when it comes to the minima. See guys, when it comes to the minima, okay, this was the case of minima. At this particular point, we say slope is positive. Sorry, negative. At this particular point, slope is 0. At this particular point, slope is positive. Tell me, is the slope increasing or decreasing? Slope is increasing. Slope is increasing. If slope is increasing, means dy by dx is increasing. Okay. And if there is a quantity which is increasing, its change will be positive. Now, we can say d2y divided by dx2 in this case will be positive. What does it mean actually? It means change in slope has to be positive. Why? Because slope is increasing. If any quantity is increasing, its change will be positive. So how do we write change in slope? That is d by dx of slope. So it is positive. And what is slope? You can write d by dx of what is slope? That is dy by dx is positive. Okay. Now tell me, what does it mean? It means d2y divided by dx2 is equal to positive. So in case of minima, guys, in case of minima, we say dy by dx is equal to 0 and d2y divided by dx2 will be positive. In case of maxima, d2y by dx2 is negative and dy by dx is 0. So for both minima and maxima, dy by dx is 0. But for minima, d2y by dx2 is positive. For maxima, d2y by dx2 is negative. I hope this is crystal clear to each and every single student. Same thing is mentioned exactly over here. Same thing is mentioned in this particular slide. In this slide. See, for maxima, dy by dx is equal to 0, slope. But d2y by dx2 is negative, change in slope. For maxima, dy by dx is equal to 0. d2y by dx2 is equal to, this is minima, that is maxima. This is positive. This is positive. Let's take a look at the question. The question will give you the more feel. The question will make you understand more. Okay. Now guys, let's have a look over here. Let's have a look over here. If y is equal to x square minus 4x plus 5, then find the maximum and minimum value of y. Okay. See, we are given a quantity over here. Y is equal to x square minus 4x plus 5. This is the quantity. And in this particular case, we have to find the maximum and minimum value of y. See guys, see. First and the foremost thing is, we say at maxima and minima, dy by dx is equal to 0. If it is maxima or minima, we say dy by dx has to be 0. Let's find dy by dx. You'll say, sir, dy divided by dx will be differentiation of this. That is 2x minus, we say 4. 2x minus 4. Guys, why? Because for x square, differentiation is 2x. For 4x, it is 4. For 5, it is 0. For constant, it is 0. And this dy by dx, make it equal to 0. Because at maxima or minima, dy by dx is 0. Now guys, I can say this is 2x is equal to, take it over there, 4. 2 ones are 2 2s are. So x is equal to 2. Now can I say can I say in this particular case, at x is equal to 2, at x is equal to 2, dy by dx is 0, dy by dx is 0. So either it is maxima or minima. Either it is maxima or minima. Either it is maxima or minima. So at x is equal to dy by dx is equal to 0. So it is either maxima or minima. Now guys, it is like you have got the graph over here. Sir, at x is equal to 1, dy by dx is 0. So either it is maxima or minima. At x2 also, dy by dx is 0. Either it is maxima and it is minima. Okay. Now, my dear friends, can I say over here also at this value of x2, either it is maxima or minima? How do we find it is maxima or minima exactly? If double differentiation came out to be positive, it is minima. If double differentiation came out to be negative, it is maxima. Do the double differentiation. Now, d2y divided by dx2. Now, this is the first differentiation. Do its double differentiation. So, for this, you have to do the differentiation. Differentiation of 4 is 0. Differentiation of 2x is 2, which is positive. Now, tell me, at x is equal to 2, is it maxima or minima? It is minima. So, at x is equal to 2, it is minima. It is minima. Okay. So, at x is equal to 2, it is minima. Now, my dear friends, if it is minima, what is the minimum value of y? Minimum value of y. Like, what does that mean, sir? I will tell you what does that mean. We say at x is equal to 2. Let's suppose it is minima. How much is the minimum value of y? That is this y minimum. How much is the exact value? How do we find? Let me show you. We say put, let's call this equation first. Put x is equal to in equation first. Put x is equal to in equation first. You will get the minimum value of y. So you'll say y minimum. Why, sir? Because at x is equal to value of y is minimum. So this will be 2 square minus 4 into 2 plus 5. 2 square is 4. 5 plus 4 is 9. So 9 minus 8, that is 1. So minimum value of y came out to be 1. Minimum value of y came out to be 1. Okay. Minimum value of y came out to be 1. Is this clear? Let's take one more question on the same concept. V is equal to velocity is given as t cube minus 6t square plus 12. Then find the maximum and minimum value of y. Velocity. Guys, see, velocity in this case is given as t cube minus 6t square plus we said 12. T cube minus 60 square plus we said 12. This is the velocity. First and the foremost thing is, let's differentiate the velocity. dv divided by dt is equal to, dv divided by dt is equal to, we say this will be 3t square. For t cube, what is the differentiation? Power down, power minus 1. 3t square minus 2 6 are, that is 12t. Then plus 0. For this it is 0. This is the differentiation. Now put dy by d is equal to, put dv by dt is equal to 0. Because we know at maximum or minimum, dv by dt is equal to 0 or dy by dx is equal to 0. So dv by dt is equal to 0. Now guys, so this will be 3t square minus 12t is equal to 0. Let's find the values of t. So I can write over here, this will be 3t common. It will be t minus, this is 4. 3t into t will be 3t square. 3t into 4 will be, 3 into 4 is 12t is equal to 0. Now here, value of t came, roots of t came out to be 2. First one is 3t is equal to 0. So first one is t is equal to 0. First root of t is equal to 0. Then we say t is equal to 4. So how? T minus 4 is equal to 0. So t is equal to 4. So there are two values of t. Okay. There are two values of t. Sir, why we are getting two values of t? See, like if you take a look at this graph, there are two values of x. At x1, value of y is maximum. At x2, value of y is minimum. Similarly, you can get the same thing over here. Maybe at t is equal to 0, you'll get maximum. At t is equal to 4, you'll get minimum. In the previous case, we got only one value of x. So at that value of x, we got only minimum. But in this question, we can get maximum also. We can get minimum also. Now, let me make you understand, guys. Let me make you understand. See, first and the foremost thing is, let's find the value of, we say, let's find d2v divided by dt square at t is equal to 0. Let's find d2v by dt square at t is equal to 0. Guys, see. This is dv by dt, differentiation. This is differentiation. Okay. Now, first d2v divided by dt square, double differentiation, that will be equals to, what is the differentiation of this? 3 into 2 is 60 minus, what is the differentiation of 12t? That will be 12. Okay, we got double differentiation. Now guys, we say at t is equal to 2, sorry, t is equal to 0, at t is equal to 0, what is the value of d2v divided by dt square? Put t is equal to 0 over here. 6 into 0 minus 12. This will be 0 minus 12. It will come out to be minus 12. Tell me, at t is equal to 0, you are getting double differentiation as negative. Is this maximum or minimum? It is maximum. So, at t is equal to 0, v is maximum. V is maximum. Now, my dear friends, I want to see how many of you can understand this one. Just a second. Now, guys, let's find d2v divided by dt square at t is equal to 2. At t is 4. At t is equal to 4. T is equal to 4. Now, guys, what is d2v divided by dt square? We recently got differentiation of this, that is 60 minus 12. Now, can I say at t is equal to 4 seconds? I can say d2v divided by dt square will come out to be 6 into 4 minus 12. 24 minus 12 is 12. So it will be 12. So this is positive. Now, at t is equal to 4. So at t is equal to 4. Double differentiation is positive. So V is minimum. V is minimum or minima. Okay. Now let's find the minimum and maximum value. Now let's find the minimum and maximum value of V. Guys, tell me one thing. At t is equal to 0, could you please tell me V maximum will be? Because at t is equal to 0, V is maximum. Guys, what is the value of V? T square, t cube plus 6t square. We say t cube plus 6t square minus 12, I guess. Plus 12. Minus, is it minus? Minus 6t square. Minus 6t square plus 12. Okay. Now at t is equal to 0, let's find the V max. V max will be, this is 0 minus 0 plus 12. So it is 12. Maximum value of velocity is 12. Let's find the minimum value in this particular case. Okay. So at t is equal to 4 seconds, velocity minimum will be, that is t cube minus 6t square plus 12. So that is 4 cube minus 6 into 4 square plus we say 12. So 4 cube is 64 and then you have got 96. 64 minus 96 plus we say 12. That will be minus 20. So this is minus 20. So this is the minimum value of velocity. That is the maximum value of velocity. And minimum we got at t is equal to 4 seconds. And maximum we got at t is equal to 12 seconds. Sorry, t is equal to 0 seconds. Okay. Guys. No. This is just to make you understand so that every question you are able to solve in your upcoming time. Okay. Please let me know in the chats, everybody of you, how many of you understood this particular question? Tell me in the chats, is this crystalline clear? Okay, great. Now, guys, let's move on to the concept of integration. Let's move on to the concept of integration. Okay, let's move on to the concept of integration. Okay. Now, take a look. Guys, let's suppose I'll ask you the simple question over here. You have got a graph, straight line. Okay. Yes. I am asking you how much is the area under this graph. This is the graph over here. Okay. How much is the area under this graph? Okay. How much is the area under this graph? That is the question that I'm asking. Okay. How much is this area over here? This area under the curve. Okay. You'll simply say, sir, this area is length. How much is the length and how much is this breadth? This is the area under the curve. Length into breadth. Area of rectangle. Okay. Let's suppose in a situation, graph is coming out to be curve. I am asking you to tell me what is the area under this curve. How much is this area? How much is this area? You'll say, sir, I'll use length into breadth over here. I say no, because this is not a square that you'll be using. It is a curve over here. You cannot use length into breadth. Sir, can I use area of rectangle, area of triangle, 1 by 2 base into altitude? I say no. This is not a triangle. Okay. Even if I give you the graph something like this, here also you can easily calculate area of triangle. But area under the curve is very difficult to find out. What we can do instead is, we'll do one thing. We'll take a small strip over here. We'll take a small strip over here. This thin strip. Small strip. Okay. And the length of this is, let's suppose, y. Since the width of this is very small and it is dx. Sir, if you are taking this as a strip over here, can we consider this strip as a rectangle? Yes, we can consider this strip as a rectangle over here. We can for sure consider this strip as a rectangle over here. Now, I'll say, in order to find the area under the curve, in order to find the area under the curve, in order to find area under the curve, let's take a small strip. Even I would say this is infinitely small, okay, of width dx. Let's take an infinitely small strip which has an area of, which has a width of dx. Okay. Now, could you find the area of this strip? Yes, we can consider this as a rectangle. We say, I can write over here, and area of the strip will be very small. Area of the strip will be very small. And even I call that as dA. Area of the width will be very small. Even I call that as dA. dA is the small area. And how do we find this dA area? That is the length of the strip, y, and breadth of the strip is dx. Length into breadth, that is y and dx. Okay. Now, guys, what I want you to do in this particular case is, I want you to basically take one more strip over here which is also infinitely small. Take one more strip over here which is also infinitely small. This is dx and length is y. Okay. Okay. Now, you can say, in this particular case, let's take one more strip. Can I say area of that is also y dx? dA is equal to length into breadth. Similarly, you can take infinite number of strips. Similarly, we cut infinite number of strips from x1 to x2. Why are we cutting this in strips? Because in case of the strips, we are able to find the area. We are able to use the length into breadth formula. That's why. Okay. So we cut it into the infinite number of strips from x1 to x2. From x1 to x2. Okay. Okay. We cut it in the infinite number of strips. Then add all those areas to get the total area. To get the total area. What I'm saying is that you cut this in the infinite number of strips, then add all the areas, then add all those strips. Okay? Then you will get the total area. Now, guys, can I say, we say area total will be simply that is dA plus dA plus dA and so on up to what? Up to infinity. So on up to what? Infinity. Now, you have to add all of these. How many? 4, 5, 10, 50, 60? No, these are infinite. When you have a very small quantities, infinitely small quantities, and which are infinite in number, then how do you add? You do not use the summation over here to add these areas. Use integration. Now, we use integration to add infinite quantities. We use integration to add infinite quantities. So what we can do is area total in this particular case will be integration of this dA. Okay, and this will be from x1 to we say x2. Total area will be integration of dA from x1 to x2. What does it mean? It means you are adding all the strips from x1 to x2. That will give you the total area. So can I say, my dear friends, from now onwards, integration helps us to find the area under the curve? Integration helps us to find the area under the curve. Can I say? And differentiation helps us to find the slope. Differentiation helps us to find the slope and integration helps us to find the area under the curve. So my dear friends, I can write over here. So integration helps us to find area under the curve. And differentiation helps us to find the slope at a point. Differentiation helps us to find the slope at a point. Okay. I hope this is crystal and clear to each and every single student. Is this clear? Guys, is this clear? Now, let's talk about, firstly, we understood the meaning of differentiation. Then I told you how to differentiate. Now, my dear friends, in this particular case, we understood the meaning of integration. Okay. Now we will basically discuss how we are supposed to integrate. How do we have to do the integration? Okay. That's what we need to discuss. How we are supposed to do the integration over here. That's what we need to discuss in this particular case. Okay. Now guys, take a look. Let's suppose you have got over here y is equal to x raised power n. You have got y is equal to x raised power n. And you have to do its integration. When it comes to the differentiation, if it was x raised power n, what were you doing? Power down, n down, x raised power n minus 1. But here, what you are supposed to do is, integration of x raised power n will be simply x raised power n plus 1 upon n plus 1. Power plus 1 upon power plus 1. So we say x raised power plus 1, n plus 1 upon n plus 1. This will be the integration. Simple. Like, if you have y is equal to x square, what will you do? You say, sir, integration of x square dx. This is how you write. So integration of, what is the integration of? Like, how do you write differentiation? Dy by dx. Integration, you will be writing integration of x square dx. So it will be integration of this will be simply, that is x raised power 2 plus 1 upon 2 plus 1 plus c. Sir, why do we add plus c plus constant? I'll tell you later on. So it will be simply, that is x cubed divided by 3 plus c. As simple as that. So power plus 1 upon power plus 1. Like you have y is equal to x raised power 3 by 2 integrated. How do we write? Its integration will be integration of x raised power 3 by 2 dx. Now do the integration. X raised power plus 1, that is 3 by 2 plus 1 upon, we say 3 by 2 plus 1. Power plus 1 upon power plus 1. Now what will you say? X raised power. This will be 5 by 2 upon, we say 5 by 2. Take this in the numerator. This will be 2 by 5 x raised power 5 by 2. Okay. I hope this is getting crystal and clear to each and every single student. Tell me. Yo, it is clear. Like you have next one over here, x raised power 1 by 3. This is called the cube root of x. Guys, see. How do we do the integration over here? We say integration of x raised power 1 by 3 dx. This is what we call the integration. So you will simply say x raised power plus 1, 1 by 3 plus 1 upon 1 by 3 plus 1. So you will be saying this is x raised power, 3 into 1 is 3, 3 plus 1 is 4. So 4 by 3 upon 4 by 3. Guys, whatever is the power, add plus 1. In the denominator also power plus 1. So this will be, take this in the numerator. So if you take in the numerator, it will become 3 by 4. So 3 by 4 x raised power 4 by 3. If I say you have got, do the integration of this one, integration of 10 x 9 dx, 10x raised power 9 dx. Guys, simply this 10 is constant. Take this 10 out. Integration of x raised power 9 dx is equal to 10. Guys, how do we do the integration? X raised power plus 1 upon power plus 1. So it will be x raised power 9 plus 1, okay, upon 9 plus 1. So what will you say? Just add plus c. As of now, keep on adding plus c. Why plus c? After some time, I'll tell you. So this will be 10 x raised power 10 divided by 10. This and this will cancel. It comes with x raised power 10. Okay, plus c. You have plus c. It is plus c. Okay, yo. Next. Okay. Now, guys, take a look exactly over here. I'll show you one thing. Guys, take a look, please, everyone. Let's suppose if I say if y is equal to x square. Okay. If we have got a function y is equal to x square, I'm saying that what is the differentiation of x square? Dy by dx. Differentiation. Sir, that will be powered down 2x 2 minus 1. That will come out to be 2x. Differentiation of x square is 2x. Okay. Now take this 2x, do its integration. Now integrate it. If you have x square, its differentiation is 2x. Now integrate this 2x. Integration of 2x and then we say dx. Integration of 2x, then we say dx. Take this 2 out. Now integration of x, we say dx. Guys, this will be 2. Integration of x is x square divided by 2. Because power plus 1, x raised power 1 plus 1 upon 1 plus 1. 2 and 2 will cancel. It will come out to be x square. Guys. You have a quantity x square. If you differentiate it, you will get 2x. If you again integrate it, you will get back x square. X square, differentiation is 2x. If you integrate this, you will get back x square. You are getting the same function back once again. So can I not say integration is the reverse process of differentiation? Can I not say integration is the reverse process of differentiation? Like over here. One more example. If we say y is equal to x cube, what is the differentiation? Dy divided by dx will be powered down 3x 3 minus 1, that is 2. This is the differentiation. Now do the integration of this. Now integrate it. Now integrate. So integration of 3x square dx. So what will you do? Take this 3 out. Integration of x square dx. Now tell me, guys. Here I can write 3. What is the integration of x square? That is x cube. X raised power 2 plus 1 upon 2 plus 1 divided by 3. This and this will cancel. It is x cube. You see, you are getting the same function back again. So from this, can I say, so integration is the reverse process of differentiation. So integration is the reverse process of differentiation. Okay. Now, guys, as I told you, keep on adding plus c. Why do we add plus c? Guys, see. Let's suppose you have got x square plus 2. You have got x square. Okay, first we'll write you have got x square. You have got x square plus 2. You have got x square plus 5. These are the 3 different functions over here. I am asking you what is the dy by dx of this? Dy by dx of this is 2x. Now what is the integration of this 2x? You say, sir, it will be 2. Integration of x will be x square divided by 2. This and this will cancel, so it will come out to be x square. Okay, x square, its differentiation is 2x. If you integrate it once again, it will become x square. Okay, so integration is the reverse process of differentiation. Cool. What is the differentiation of this? Dy divided by dx is equal. For x square, it is 2x. For 2, it is 0. For 2, it is 0. So integration, differentiation of this is also 2x. Now if you do the integration of this, guys, differentiation of this is 2x. Now do the integration of its differentiation. So that is 2x dx. Integration of 2x dx is x square. So you are getting x square. See, guys, here original function is x square. So you are getting the same original function when you integrate. Here original function is x square plus 2. Here in this particular case you are getting x square only. So that is the reason we add plus c. Maybe we say here it would have been some constant over here, something over here. That's why we are adding plus c. Okay. Like in this case, what is the differentiation? Dy by dx in this case is, for x square it is 2x. For 5 it is 0. Now do the integration. Integration of this 2x dx. Once again it will be x square. But originally it is x square plus 5. So in all the three you are getting x square, x square, x square. Now we say plus c because originally it was something was added over there. That's why we are adding plus c constant. Tell me in the chats how many of you understood this. Tell me, guys. Okay. Just a second, guys. I'll get the water. Huh? I'll get the water. Just a second. Just a second. Now, guys, take a look. Since we discussed that integration is the reverse process of differentiation. Okay. Since we discussed that integration is the reverse process of differentiation. Yes, absolutely cool, absolutely normal. Guys, tell me one thing. Tell me one thing. Tell me one thing. When it comes to, let's suppose if we have a function y is equal to sine x. We know that differentiation of sine x is cos x. dy by dx, its differentiation is cos x. And then, don't you think that if you integrate this cos x, if you do the integration of this cos x, you should get the sine x back? Yes. Because integration is the reverse process of differentiation. If you have sine x, its differentiation is cos x. Now integrate it, you should get back cos sine x. So that's why we say first thing over here, integration of cos x is sine x plus c. Okay? Yes. Now, my dear friends, if you have cos x, Differentiation of cos x is minus sin x. Differentiation of cos x is minus sin x. Now, if you do the integration of this sin x, you should get minus cos x. Integration of sin x is minus cos x plus c. Integration of sin x is equal to minus cos x plus c. Minus cos x plus c. Okay. Now, guys, then you have, guys, you have y is equal to tan x. You have y is equal to tan x over here. Y is equal to tan x. What is the differentiation of tan x? Sec square x. Now, if you do the integration of sec square x, you should get tan x. See, integration of sec square x is equal to tan x plus c. If you have y is equal to cot x, now if you do its differentiation, it is minus cos x square x. So, if you do the integration of, we say, cos x square x, you should get minus cot x. Integration of cos x square x is minus cot x plus c. Similarly, if you have y is equal to sec x, its differentiation is sec x tan x. Now, my dear friends, if you do the integration of sec x tan x, you will get sec x back. Similarly, if you have y is equal to cosec x, its differentiation is minus cosec x cot x. Now, if you do the integration of this, you should get this cos x back. Integration of cosec x cot x is minus cosec x plus c. Okay. Okay. And then, my dear friends, if you have y is equal to e raised power x, already we discussed. Differentiation of e raised power x is e raised power x. Now, if you again integrate it, you should get back e raised power x. So, integration of e raised power x is also e raised power x. Integration of e raised power x is e raised power x. Integration of differentiation of e raised power x is e raised power x. Okay. Now, guys, if you have y is equal to log of x, so we say dy by dx is equal to 1 by x. Differentiation of log x is 1 by x. Now, if you do the integration of 1 by x, you should get this log of x back. You are getting the log of x back. Okay. Okay. Done. Done. I hope this is crystal and clear. This is crystal and clear. I hope this is crystal and clear. I hope this is crystal and clear. Okay. Now, guys, take a look exactly over here. Take a look exactly over here. See, let's talk about integration. Integration with limits. Integration with limits. Let's talk about the integration with limits. Guys, when it comes to the integration with limits, I would want you guys to focus exactly over here. When it comes to the integration with limits, see, what does integration with limits mean? Let's suppose I say integrate y is equal to x square plus 1 from 0 to 2. Y is equal to x square plus 1 from 0 to 2. Sir, what does it mean? See, what does it mean? It means that you have to do the integration of x square plus 1 dx from 0 to 2. So basically it is like you are finding the area from 0 to 2. Like if I take you to the meaning of integration over here, What was this? Integration of dA. Here, what is this integration of dA? This is integration of y dx from x1 to x2. What is this x1 to x2? x1 to x2 is limits, means you are finding the area from this point to this point, means area under this curve. That is the meaning over here. That is the meaning of this limits. That is the meaning of the limits. Okay. Now, how do you do it? How do you do it? So basically you say, sir, first you do the integration. Integration is, that is x square. What is the integration of x square? That is x cube divided by 3 plus. What is the integration of 1? Guys, see. Let's suppose you have integration of 1 dx. Take this one out. Take this one out. So it will be integration of dx. Guys, always remember. Integration of dx means you are adding this small distance, x. You are adding. So what is this integration? This means addition of small displacements. So it will give you the large displacement. So it will be 1 into x. Okay. And integration of this is x. Or you can cancel this one and this one, you will get x. So this will be x. So what is the integration of 1? That will be x. Now, what is the limit from 0 to 2? First, I integrated x square. Then I integrated 1 over here. And then I am putting up the limits. Now, guys, what we are supposed to do afterwards? Put the upper limit, then lower limit. See how I'll tell you. In this x, you have to put the upper limit first. That is 2. Instead of x, I'll write 2. That is cube divided by 3. So once you are done with the upper limit, then you say minus lower limit. And in this x, you will put 0 cube divided by 3. Upper limit minus lower limit. Then you say this plus. Now in this x, because x is variable, put the upper limit. That is 2 minus. Then put lower limit. That is 0. Now tell me. So this is 2 cube. That is 8 by 3. Plus this is 0 plus this is 2. Okay. Now 3 2s are 6. That is 14 divided by 3. So value of y is equal to x square. Integration of x square plus 1 from 0 to 2 is 14 by 3. And in this case, you do not add plus c, because when you take the limits, this is the final answer. Without limits, you put plus c. Okay. Now take a look at this, guys. Integration of sine theta with respect to theta from 0 to pi by 2. Guys, see. And when it comes to the integration of sine theta, guys, tell me here from the trigonometric functions, what is the integration of sine x minus cos x? What is the integration of sine theta minus cos theta? Okay. Take a look. I can say over here, integration of sine theta will be simply minus cos theta. And limits are from 0 to pi by 2. Okay. Now you can say minus. Take this minus out. Now put the upper limit. Sir, in this theta you have to put the upper limit because theta is variable. So we'll be saying cos of pi by 2 upper limit minus you can say cos of 0, that is lower limit. Now tell me, guys, cos pi by 2, that is cos 90. Cos 90 is 0 minus cos 0 is 1. Minus into minus is plus, so it will be plus 1. So value of this came out to be integration of sine theta from 0 to pi by 2, it came out to be plus 1. Like you have this. Integration of cos theta d theta. Guys, tell me, what is the integration of cos? See, look at the table over here. Integration of cos is minus sine. Sorry, sine. Integration of cos is plus sine. So I can say in this particular case, integration of cos is plus sine. So it is sine of theta. It is from 0 to pi by 2. 0 to pi. 0 to pi. Now put the upper limit first. So I'll write sine of pi minus. Then in this theta, you have to put the lower limit. Sine of 0. Sine pi, that is sine 180. It is 0 minus sine 0 is also 0. So it is 0. So value of cos theta from 0 to pi is 0. Okay. I hope this is clear, guys. Okay. Constant multiplier rule. Okay, what is this? If you have a function something like this and you are supposed to integrate it, integration of 2 sine of x, okay, dx. As whenever the constant is multiplied to a function, if you have to do its differentiation or you have to do its integration, what you are supposed to do? Take this 2 out. Then you say integration of sine of x, we say dx. Okay, then you can say this 2. What is the integration of sine x? Sir, that is cos x. Okay, so it will be simply 2 and it is minus cos x. Minus 2 cos of x plus you say c. Because limits are not given, so you can say plus c. Now addition rule. Addition rule is simply you have to do the integration of all of these over here and nothing else. See guys, when it comes to the integration of this, okay, you have to do the integration of this and you write over here dx with respect to x. Okay. Now tell me guys one thing. Simply, if you have a minus b plus c, what is the integration of x square? Tell me one thing. Sir, integration of x square is x raised power 2 plus 1 upon 2 plus 1. That is x cubed divided by 3 minus. What is the integration of 2x? That will be 2x square divided by 2. Because, guys, integration of 2x dx will be, take this 2 out, integration of x dx, you will be saying 2. What is integration of x? That is 1 plus 1 upon 1 plus 1. So it will be 2x square divided by 2. Okay. Now this 2 and this 2 will cancel. Plus, what is the integration of 4? It will be 4x. Because integration of 1 is x. 4x will be 4x. Okay. This is the final integration. X cubed by 3 minus x square plus x 4x. Okay. Simple. Okay. What about this one? If somebody gives you the question something like this, integration of sine of x plus e raised power x plus 1 by x, and then you have dx. Tell me guys one thing. What about sine x? What is the integration of sine x? Sir, that is minus cos x. Then plus. What about integration of e raised power x? That is e raised power x only. What about plus? Integration of 1 by x? That is log of x. Okay. Then we say plus c. Done. Done and dusted. Nothing else. Okay. Now you have got the outside inside rule. Now guys, outside inside rule, or you can say chain rule of chain rule of integration. Chain rule of integration. Either you call it the outside inside rule or you call it the chain rule of integration. Now guys, take a look. When it comes to the outside inside rule, or we say chain rule of integration, what does this rule actually say? It says that if you have a function and you are supposed to use the chain rule, integration of the outer function divided by coefficient of x. In case of chain rule of differentiation, differentiation of outer function multiplied by differentiation of inner function. Let me show you here. Guys. Let's suppose you have got e raised power 5x. Okay, it is not e raised power x, it is e raised power 5x. Okay, you say use chain rule. Okay, and they ask you to integrate it. So use chain rule. Now guys, first of all, what will be the outer function? Outer function in this case is whole, e raised power 5x. What is coefficient of x? What is coefficient of x over here? That is 5. Coefficient of x is 5. Now what does it say? Integration of y dx. What does this rule say? It says integration of outer function divided by coefficient of x. You are supposed to use this rule over here because it is not simply e raised power x, it is e raised power 5x. See guys, what is the outside integration of outer function? Integration of outer function e raised power 5x, it will be e raised power 5x only, divided by coefficient of x, that is 5. That will be 5. Simple, that is plus c. Okay, let's suppose you have got y is equal to e raised power 100x. What will you say? Sir, its integration will be simply integration of outer function, that is e raised power 100x divided by coefficient of x, that is 100. Let's suppose if you have got y is equal to e raised power 200x. So what will be the integration? That is e raised power 200x divided by 200 coefficient of x. As simple as that. Let's suppose we have this. What do we do? Integration of outer function. In this case, outer function will be, guys, that is sine of 2x plus 4. This whole is outer function. And what is coefficient of x? That is 2. So now, integration of outer function. Guys, tell me. Sir, what is integration of sine? That is minus cos. Minus cos of whatever is in the angle, 2x plus 4 as it is, divided by coefficient of x, that is 2. Here, in this case, a outer function, this is the outer function. Integration of outer function. What is the integration of cos? That is sine of, I can say 4 minus 3x. Sine of 4 minus 3x divided by, what is coefficient of x? That is minus 3. Coefficient of x is minus 3. Okay. Just do plus c over here, What about this one, guys? Okay. Sir, integration of outer function. Outer function is whole, e raised power minus 3x divided by coefficient of x, that is minus 3. Coefficient of x is minus 3. What about this one? Sir, integration of outer function. That is, what is the integration of sine? That is minus cos of omega t divided by What is the coefficient of t over here? That is omega. Because here we are integrating with respect to c, with respect to t. It is plus c, it is plus. Guys, please tell me in the chats, is this crystalline clear to each and every single student? Tell me. Tell me, guys. So we are done with basic mathematics. Done and dusted. Okay, with the basic mathematics. Okay. Now we need to start the vectors. Now we need to start the vectors. So before vectors, let's take a break, okay? Let's take a break. Okay. Break will be till I must say break will be till 7:15, okay? Or let's keep it 7:20. Okay. Break is till 7:20. Sorry, 8:20, 8:20, 8:20. 8:20 p.m. Okay, guys, let's take a look over here. So we are starting the next chapter, that is what we call the vectors. And we are done with the basic mathematics, okay? Let's start the chapter that is vectors. We have the next chapter. Now, guys, let's take a look exactly over here. When it comes to the vectors, the very first thing you need to understand over here is what is this vector? What is this vector? Okay, what is this vector that we need to understand? We simply say it is that physical quantity which has direction and magnitude and unit. Okay, guys, see. Before this, let me make you understand something. Guys, see. In this particular case, what I want you guys to understand is, let's suppose if I say I have got a block over here. Okay. This block has got the mass of, let's suppose, 20 kgs. Okay. We said this mass is a scalar quantity. It does not have the direction. We do not say the mass of this block is 20 kgs in the direction in north, towards north. We do not say the mass of this block is 20 kgs in that direction. No, we just simply say its mass is 20 kgs. Okay, cool. Now, my dear friends, what I'm saying over here is that if I say I have got a block over here, you are applying a force on this block, and the direction of the force you are mentioning over here, it is towards the right along the x-axis. So this force is a vector quantity. Okay. So when it comes to the physical quantities, we say there are two types of physical quantities, scalar and vector. And what is vector? We say it is that physical quantity which has direction, magnitude and unit. Okay. And one more important point, also follows the triangle of vector addition. What is this? This we will see later on. As of now, the physical quantity which has got magnitude as well as direction and has unit is called the vector quantity. Like you have force, you have velocity. All of these have, we say, direction as well as magnitude. But when it comes to the mass, force, velocity, acceleration, displacement, these are the vector quantities. When it comes to a scalar quantity, it is that physical quantity which has magnitude and unit only. Like you have mass. We say mass of this body is 10 kgs. It does not have the direction, just the magnitude. We say temperature, 20 degrees Celsius. You do not say 20 degrees Celsius in that direction. No, just 20. Okay. Then you say speed. Speed is a scalar quantity. Distance is a scalar quantity. Even current is a scalar quantity. Okay. And we say vector quantity means which has magnitude, direction and which follows the triangle of vector addition. And scalar quantity means which has direction, which has magnitude and unit only. Okay. Simply. So a physical quantity can be divided in two parts. We say vector quantity and a scalar quantity. This has got direction and magnitude. This has just the magnitude in this particular case. Now, guys, understand this point that I'll tell you over here. Now, guys, take a look. When it comes to the representation of a vector, how do we exactly show a vector quantity? See, whenever we write a vector, it means it has got the magnitude magnitude, and we say it has got the direction. A vector quantity, a vector is that quantity, that physical quantity, which has got the magnitude and which has got the direction over here. Now, let's suppose, since we are talking about the force, let's suppose when it comes to the force, I say this force is a vector quantity. So how do we write the magnitude? I'll just write this force. This is what we call the magnitude of the force. And for the direction, I'm writing over here F, and on top of it, I'll write the F cap. This is how do we represent the vector mathematically, magnitude and direction. This mod of F means magnitude. This F cap means direction. Let's suppose I'll take any vector in general. I have got a vector A over here. Okay. This vector A has got magnitude. Okay. And it has got direction. So we say that is A cap. So this is what we call the magnitude of A. This gives the direction of A. Direction of A. Now. What is this? This is the magnitude of F. And what is this F cap? This F cap is what we call the unit vector. And this unit vector is used for the direction purposes. Okay. This gives the direction and this gives the magnitude. Okay. Yes, sir. Now, guys, one more thing I just want to tell you in this particular case. When it comes to graphically, this is mathematically how do we show a vector? We write that physical quantity, on top of it, we place the arrow. We say graphically, we represent a vector with an arrow. Graphically, we represent vector with an arrow. Let's suppose I am saying, sir, there is a vector over here. This is what we call the tail of the vector. Tail. And this tail gives you the magnitude. This tail gives you the magnitude. And this is what we call the head of the vector. And this head gives you the direction. This head gives you the direction. Okay. So graphically, we show it with an arrow having the head and the tail. Having the head and the tail. Okay. Yes. Yes. Okay. So basically, this is what we call the vector, and this is the mathematical representation. Over here, this mod of F is the magnitude. This is the magnitude of F vector. This is the magnitude of F vector. And when it comes to this, this is the unit vector which gives the direction, of F. This is the unit vector which gives the direction of F. This is the unit vector which gives the direction of F. As simple as that. As simple as that. Okay. This unit vector is used for direction purposes, and we say this will give the magnitude. And graphically, if you have to show a vector, you show it with an arrow. This tail will give you the magnitude, and head represents over here, that is the direction of the vector. Okay. Now, guys, let's suppose I'll take the x-axis, I'll take y-axis, I'll take z-axis. And I am making any general vector over here, A. This A vector is along x-axis. I'm showing you over here a vector that is A, which is along x-axis. Can I say A is the vector which is along x-axis? Yes, sir. Okay. Now, guys, we say B is the vector which is in the xy plane. B is the vector which is in the xy plane. This is called the xy plane. This is called the xz plane. This is called yz plane. This B vector is in the x and y plane. This is called the plane, area. And the C is that vector which is along y-axis. C is along y-axis. A is along x-axis. C is along y-axis, B is in the xy plane. B is in the xy plane. Okay? Yes. Yes. Now, guys, let's understand one thing over here. This is an important statement which I want you guys to understand. Scalar can be changed by changing the magnitude only. Scalar can be changed by changing the magnitude only. Okay? Scalar can be changed by changing the magnitude only. My dear friends, when it comes to a scalar quantity, okay, we know it has got the magnitude only. If scalar has got the magnitude only, if you want to change it, means you have to change its magnitude. Like. This will give you the proper feel of the statement. Like in this particular case, I am saying we have got a body which is moving in a circle. There is a body which is moving in a circle. We have got an object, it is moving in a circle. Here, I am saying speed of the object, okay? Let's suppose VA in this particular case is 20 meter per second. Speed here is 20 meter per second. Speed is a scalar quantity. And at this particular point, we say speed is 20 meter per second, okay? And in this particular case, speed is, let's suppose, 20 meter per second. And in this particular case, we say speed is 20 meter per second. 20 meter per second. Okay. Speed is how faster the object is moving in the circle. Can I say in this particular case, guys, we say speed at point A. We say speed at A is equal to, we say speed at B is equal to, we say speed at C is equal to speed at D. Now, if you have to change this scalar quantity, this speed, means you have to change the magnitude. Here, if it is moving with the 20 meter per second, if I say move faster, okay, if I say in this particular case, here it is moving with the 20 and here it is moving with the 40 meter per second. Now, I am saying in this particular case, we say magnitude of the speed is changing. So I can say scalar quantity is changing. So scalar can be changed by changing the magnitude only. But when it comes to the vector, vector can be changed by changing the direction as well as the magnitude. Guys, when it comes to a vector quantity, we know vector has got magnitude, vector has got direction. Vector has got magnitude, vector has got direction. If you change this, we say vector will change. If you change this, we say this vector will change. Either if you change the magnitude or if you change the direction, we say in that particular case, vector will change. The same example I'll just give you over here. Let's suppose the object is moving at this particular point, its speed VA, let's suppose its velocity is over here 20 meter per second. At this particular point, its velocity VB is 20 meter per second. At this particular point, its velocity VC is, let's suppose, 20 meter per second. Tell me one thing, guys. Here, magnitude of velocity at every single point is same. I can say magnitude of VA, how faster the object is moving, that is equal to magnitude of VB is equal to magnitude of VC. Velocity at A is equal to velocity at B is equal to velocity at C. Velocity at A is equal to velocity at B is equal to velocity at C. Okay, magnitude of velocity, I'm saying speed. But when it comes to the velocity, guys, velocity at point A, no doubt, magnitude of this is 20 over here, here also 20, but the direction is upward, the direction is towards left. So direction is different, So I can say velocity at A is not equal to velocity at B, is not equal to velocity at C. So here, speed at A is equal to speed at B is equal to speed at C. Speed means magnitude of velocity, how faster the object is moving, 20, 20, 20. But you said vector can be changed by changing the magnitude and direction. Okay. So I can say in this particular case, we say velocity is different, but speed is same. Like I'll give you another example. There is an object. This object is moving with 20 meters per second in the forward direction. This is the velocity at A. And when the object reached over here, velocity at B is 20 meters per second. In this particular case, direction at A is forward, direction at B is forward. And I say over here, magnitude of velocity at A is equal to magnitude of velocity at B. Even I would say velocity at point A is equal to velocity at point B. Velocity at point A is equal to velocity at point B. Okay, so here direction as well as magnitude both are same, so velocity will be same. In this case, direction is different, so velocity is different, but magnitude is same. Please give me the signal in the chats if this is crystal and clear to each and every single student. Tell me, guys, if this is crystal and clear to each and every single student. Okay, so this was the statement which says that scalar can be changed by changing the magnitude only. Vector can be changed either by changing the direction or by changing the magnitude. I hope this is crystal clear to each and every single student who sir is watching. Now let's talk about the parallel shifting of the vectors. What does parallel shifting of the vectors mean? See, guys, let's suppose you have got over here, this is the surface, and there is a vector over here. This is the vector. Let's suppose this is A, and it is making over here angle alpha. Okay. What I want you guys to do is, I want you to take this vector from this point to this point. Okay, place it over here. This, let's suppose we call it B over here, and here also angle is alpha. Sir, is this shifting of vectors possible? Is this shifting of vectors allowed? Can we take a vector from one position to another position? Yes, but there is a rule. We say we can parallel shift the vectors, but make sure the direction and magnitude of the vector should remain the same. We say in parallel shifting of vectors, direction and magnitude should, or I would say must, remain the same. Direction and magnitude of the vector should remain the same. Like over here, this vector is at an angle of alpha, let's suppose 30. Here also it is at an angle of 30. The length of the vector over here is the length of the vector over here. Even I can say, sir, can I take it over here? Can I take it over here? Yes, you can take it over here also. This is the vector C, and this angle should be also alpha. Let's suppose here I'll make this vector D, and this is the angle beta over here. We say in this particular case, vector A is equal to vector B. We say vector A is equal to vector B is equal to vector C is not equal to vector D, because the direction of the vector B has been changed. It is making the angle beta. So you can take this vector anywhere on the board. You can place it anywhere, but make sure it is making the same angle with the x-axis at every single point. Okay, here if If let's suppose here it is making 30, if you take here, here also it should make 30. Here also it should make 30. This is called the parallel shifting of vectors. You can parallel shift the vectors. You can take the vector from one point to another point. You can take the vector from one point to another point. Okay, provided the direction and magnitude of the vector should remain the same. Okay, when you change the vector's direction, in that case, you can't say this vector will be equal to this vector. Now, angle between the two vectors. How do we define the angle between the two vectors? Guys, see, let's suppose you have got a vector over here. This is vector A. Okay. And you have got another vector over here, that is B. Sir, can we call this as an angle between the two vectors, this alpha? We say no. Sir, can we call this as the angle between the two vectors, this beta? We say no. This beta, alpha and beta are not the angle between the two vectors. So alpha and beta are not the angle between the two vectors. Now see, guys, we say angle between the two vectors is the smaller angle when they are placed head to head or tail to tail. Guys, let me show you how do we draw. Let's suppose these two vectors we have. Do the parallel shifting of the vectors. Sir, take this vector from this point and make it over here. Take this vector from this point and make it over here. This is the vector B. Take this vector from this point and place it over here. This is the vector A. This is the vector A. So this vector is A over here. This vector is B over here. And angle between these two, this smaller angle, this is called the angle between the two vectors. Angle between the two vectors is the angle, smaller angle. When they are connected, when they are placed head to head or tail to tail, means they are connected. Vector A, tail of vector A is connected with the tail of vector B. So then this angle, smaller angle, not the bigger one, smaller angle is considered to be the vector between the two, angle between the two vectors. Okay, okay. So theta is the angle between the two vectors. Sir, can we make it like this? Can we make it like this also? Or. If you have got a vector over here, okay, take this vector from this point and place it over here. Parallel shifting of vectors. This is A. And then they take this vector. If it is in the upward direction, take it, and place it over here. Place it over here. Sir, can we do it something like this also? Yes. See, here direction of this is upward. Here direction of this is upward. Okay, little bit. I'll shift it something like this. Yes. Now, okay, this is the vector. This is the vector A and this is the vector B. This is the vector A and this is the vector B. Sir, can I call this as an angle between the two vectors? Yes. Angle between the two vectors is that angle when the two vectors are placed head to head. Here the two vectors are placed head to head or tail to tail, tail to tail. Make sure the two vectors should be joined together head to head or tail to tail. Then only you can define the angle. Here, head of vector A is connected to the tail of vector B. So you cannot define the angle between the two vectors over here. I hope this is crystal and clear. This is crystal and clear. Okay, now, which of the following correctly represents the angle between the two vectors? Guys, tell me in this particular case, this is in this particular case, one vector A, another vector B. No doubt they are connected tail to tail. But here angle is given this. What kind of angle is this? This is no. It should be between two vectors. Angle between the two vectors is the smaller angle. Okay, between head to head or tail to tail. And this is the vector A, this is the vector B. Okay. So in this particular case, this is the angle between the two vectors over here. But it is mentioning this one. So no. not this one. We say not this one, not this one. Okay, what about this? Head and head are joining and this is the smaller angle. Yes, this is correct. C is correct. What about D? Head of vector B, tail of vector A. No. No. Option C is the correct option over here. Okay. Let's take a look over here. Find the angle between the two vectors. I see. If you have to find the angle between these two vectors, this is given as 150 degrees over here. See. Do the parallel shifting of vectors. I want you to take this vector and place it over here. This is the vector that I'm placing over here. Okay. Take this vector A and place it over here. Okay. And take this vector B from this point to this point. This point to this point. This is vector A. This is vector B. And if you extend this, guys, this angle is given as 150 degrees. 150 degrees. Could you please tell me how much is the total angle? How much is the total angle? Guys, this is the total angle, that is 180. So this will be the angle between the two vectors. So can I say 180 degrees minus this angle 150 degrees, okay, will be equal to the angle between the two vectors? So theta in this case will be simply, that is 30 degrees. What did I do? Basically, I did the parallel shifting of the vectors. I'm taking the vector A from this point and placed over here. Then I'm taking the vector B from this point and placed over here, because parallel shifting of the vectors is done unless and until you keep the magnitude and the direction of the two vectors same. So over here, A vector is in the forward direction. Here also it is in the forward direction. So I'm not messing with the direction over here. When it comes to the B vector, the direction is upwards. Here also it is upwards. Okay. So we say direction of A and B remains the same. Just we are changing the position. Now this angle is the angle between the two vectors, between head and head. Now this is 150. Total is 180. So 180 minus 150 is 30 degrees. 30 degrees is the angle between the two vectors. Is this clear? Please tell me in the chats, ladies and gentlemen. Everyone. Tell me, guys. Now guys, take a look over here. Let's talk about the types of vectors. See guys, when it comes to the types of vectors, the first vector that we have over here, that is the equal vector. Okay. What does equal vector actually mean? See guys, we say the vectors which are having the same magnitude and direction and of the same nature, we call these vectors as equal vectors. Let me just give you the example. Let's suppose this is a block over here. Okay. And I'm saying on this block there is a force acting. This is F1 over here. There is another force acting. This is F2 over here. Okay. And there is another force acting. We say F3 over here. Now guys, when it comes to the F1 vector, we say F1 is equal to, let's suppose, 10 Newton. If F1 is 10 Newton. and we say F2 is, we say 10 Newton, and F3 is also 10 Newton. I see this force and this force, they are having the same nature. This is also this factor, this factor, this factor. All the three vectors are having the same nature. Okay. Same nature means this is force, this is force, this is also force. This is not velocity, this is not velocity. Okay. Sir, force vector and velocity is also a vector. They are of different nature. This is velocity, this is force. Okay. Sir, force and acceleration, they are of different nature. Force and force are of same nature. Now, these two vectors have the same nature. This also has the same nature. Okay. But the direction of F1 and F2 is same. Magnitude of F1 and F2 is same. So we say F1 and F2 are equal vectors. F1 and F2 are equal vectors. Okay. Sir, what about F3? F3 also has the same nature as F1 and F2, but in this particular case, when it comes to the F3, it is in the opposite direction. It does not have the same direction as F1 and F2. It has the direction opposite to F1 and F2. So the equal vectors are those vectors which have got the same magnitude, same direction, and same nature. That's why F1 and F2 are the equal vectors over here. Parallel vectors. What are the parallel vectors? We say parallel vectors are those vectors which have the same direction. Magnitude may or may not be equal. If I am saying this is a vector A in the forward direction, this is a vector B in the forward direction, A and B has different magnitude, but the direction is same. Okay. Example I am saying, like you have the box over here. On this box, you are applying a force, let's suppose 10 Newton. This is F1 is 10 Newton. On this box, you are applying one more force, F2 is equal to 5 Newton. We say F1 and F2 are parallel vectors. No doubt, they have the different magnitude, but the direction is same. We say F1 and F2 are parallel vectors. They are parallel vectors. They have got the same magnitude, different magnitude, but the direction is same. Anti-parallel vectors. Guys, see? Vectors which have opposite direction, okay, are called the anti-parallel vectors. Again, let's suppose this is the block. On this block, you are applying a force over here, that is 10 Newton. This is F1. And you are applying the force F2 over here in this particular case, that is, let's suppose 20 Newton. 20 Newton. In this particular case, this F1 and F2 are opposite to each other. So we say they are called the anti-parallel vectors. We say F1 and F2 are anti-parallel vectors. Because they are acting opposite to each other, that's why we call these two vectors as anti-parallel vectors. That's why we call these as anti-parallel vectors. Okay. Next. Guys, is this clear till over here? Please tell me in the chats. Is this clear till over here? Now guys, zero vector. What does zero vector actually mean? We say that vector which has zero magnitude. Let's suppose we have got a car over here. Okay. This is a car. And I'm saying this car is exactly at rest. If the car is at rest, Could you please tell me what is the velocity of the car? That is 0. What is the velocity of the car? That is 0. Sir, is the velocity vector? Yes. So here, this vector is what we call the 0 vector or the null vector. Okay, 0 velocity means here magnitude of this velocity is 0. And this is a vector. And this is a vector. So we call it the 0 vector. Another example I'll give you. Let's suppose you have got a block over here. On this block, from this side, force F is acting 10 Newton. Let's suppose this is F2. And from this side, this force F1 is also acting 10 Newton. Could you please tell me what is the net force in this particular case? What is the net force acting on this? That is 0. Because this will cancel with this, net force is 0. But is this force a vector? Yes. So we say net force is a vector because force is a vector. And how much magnitude it has over here? 0. So we call this. And here it has 0 magnitude. So we call it 0 vector. Or we say null vector. If the magnitude of the vector comes out to be equal to 0, then we call that as null vector or the 0 vector. Then that is considered to be the null or the 0 vector. Is this clear? Okay. Now guys, let's move on to the next one. Next one is the negative vector. Two vectors having same magnitude but opposite direction and of the same nature. See guys, let's suppose you have got an object over here. Once again, in this particular case, this is the force which is acting over here. F1 is 10 Newton. And on this block, there is another force acting. We say this F2 is, we say 10 Newton over here. Now guys, if you consider this F1 along the positive axis as positive force, positive vector, then you have to consider this as negative. Why? Because this is opposite to this. So we say here F2 is opposite to F1. So we consider in this particular case F2 as, I would say, negative vector. Okay. Or if you are considering this as positive, you have to consider this as negative. Okay. So two vectors having same magnitude but opposite direction and same nature. Same nature, opposite direction, same magnitude. Isn't this 0 vector? No, their resultant is a 0 vector. Their resultant is a 0 vector. I am talking in particularly about F2. F2 I am considering over here as negative vector. Their net is a 0 vector. Net force and F1 and F2 is completely different. Okay? Okay? Simply, sir, let's suppose you have got an object over here. The force acting in the upward direction, let's suppose this is F1. This is, we say, sir, F2. If this is 5 newtons over here, this is 5 newtons over here. In this case, this F2 is opposite to F1. You can consider this F2 as negative over here. As simple as that. Okay, negative vector. Collinear vectors. Collinear vectors. Okay, those vectors which are in the same line. Vector A, vector B, vector C. Okay, they are in the same line. These are called the collinear vectors. No doubt in this case, vector C is opposite to vector B. Doesn't matter. If they fall in the same line, then we can say these are the collinear vectors. And we say if the angle between the two vectors is 0 degree or 180 degree, we can say these are called the collinear vectors in that particular case. Okay. And coplanar vectors. Guys, in this particular case, what I'm saying is that you have got over here y-axis and this is x-axis over here. This is y and this is x. And I can say over here, if this is y and this is x, this is y-axis, this is x-axis, this is called the xy plane. Okay. Now, vector A, vector B and vector C, these three vectors are in the same plane. These three vectors, A vector, B vector, C vector, are in the same plane. So we call these three vectors as coplanar vectors. If let's suppose on this board I'm making 100 vectors, so we call those 100 vectors as coplanar vectors. Why? Because they are in the same plane. If the vectors are in the same plane, in the same area, on the same surface, we consider those vectors as the coplanar vectors. If the vectors are along the same line, we consider the vectors as collinear vectors. Okay, collinear vectors. Collinear vectors and coplanar vectors. I hope everything is crystal and clear till over here. I hope everything is crystal and clear till over here. Now comes the important one, the most important one, that is called the unit vector. Now comes the most important one, that is called the unit vector. Let's talk about the unit vector. Guys, is this clear till over here? Please let me know in the chats. Is this clear till over here? Let me know in the chats. Everyone means everyone. Now guys, let's take a look over here. Unit vector. What is a unit vector all about? What is this unit vector all about? Guys, see, we say as we recently studied, if we take any vector, let's suppose I'm taking a vector over here, A. We know, sir, this vector will have the magnitude that is mod of A and it will have the direction that is A cap. What is this A cap? A cap is the unit vector which is used for the direction purposes. See, when it comes to the A cap over here, I can say this A cap will be this A vector divided by mod of A. So divide it over here. So this will be the unit vector. This will be the unit vector. So my dear friends, if you have to find the unit vector of any vector, so you take that vector, divide it with the magnitude of that vector. Like if I'm saying force vector is equal to mod of F into F cap. F cap is the unit vector over here. And I can say in this particular case, this F cap will be this divided by this. So where A cap is the unit vector, which is used for the direction purposes. Only. It is used to find the direction only. And we say also magnitude of unit vector, magnitude of a unit vector is 1. Always remember, magnitude of a unit vector, we always say it is 1. It is 1. Okay? Yes. Absolutely cool. Absolutely cool. Now, guys, I just want to say one more thing to you guys over here. Okay? See. What I'm trying to say is that I'll write a statement over here. See, guys. The unit vector along x-axis is I cap. What does this actually mean? See. Let's suppose I have got a force over here. This is the force acting on anybody. Its magnitude is 10 Newton. Tell me, is this force along x-axis? Is this force along y-axis? Is this force along z-axis? Obviously, it is along x-axis. How do you have to mention its direction? See, how do you mention? You'll say, sir, this force will be 10 I cap. This I cap is that unit vector which is along x-axis. Means if we attach this I cap with something, means the direction of that something will be along x-axis. So this I cap gives you the idea that force is acting along x-axis. Okay? Like another thing I will tell you. We said the unit vector along y-axis is j cap. Like if you have a block over here, on this block I am saying the force is acting. How much? We say, sir, 10 Newton. Could you please tell me what is the direction? How do we represent this force over here? You'll say, sir, this force will be simply that is 10 j cap. You can't say 10 I cap because the force is acting along y-axis. It is in the y direction. That's why I'm mentioning over here j cap. J cap tells you that the force is acting in the y direction. Yes. Okay. Then you have got the next one. That is the unit vector. Along z-axis is k cap. Means if there is a vector, its direction is along k cap, it's along z-axis, you can simply say like force is equal to 10 k cap, means force is acting along z direction. So guys, always remember mod of I, magnitude of I is equal to magnitude of j is equal to magnitude of k, and this will be equals to 1. Because magnitude of a unit vector is always 1. Okay. Now guys, take a look. We have got a vector over here. This is the vector 3i cap plus 4j cap. Now guys, sir, what is this 3i cap plus 4j cap? If I say I have got a vector over here, that is 3i cap, means it is along x-axis. If I got a vector over here, 4j cap, means it is along y-axis. If I have got a vector over here, 3i plus 4j, means this vector is in xy plane. Because it is having the x component also, it is having the y component also. If it was only 3i cap, means along x-axis. If it was only j cap, means along y-axis. But it is I plus j, it is along I plus x plus y. It's in the xy plane. Now, we have to find its unit vector. Guys, tell me one thing. How do we find the unit vector? That is vector A divided by mod of A. Okay. Now, the point is, how do we find the magnitude of a vector? Remember, guys, directly. If this is the vector, you are supposed to find its magnitude. Directly remember, under root of this square, that is 3 square, plus this square, that is 4 square. 3 square plus 4 square. Whatever is the coefficient over here of I, 3 square, its square, plus this square, and then root. If it was plus k, then that square also. Okay. This square plus root. Now is equal under root of, tell me guys, 3 square is 9, 4 square is 16, 16 plus 9 is 25, root 25, that will be 5. Mod of A is 5. Now, can I say, sir, this A unit vector will be A vector, that is 3i cap plus 4j cap, divided by mod of A, that is 5 divided by 4. You can write it something like this also, that is 3 by 5 I cap plus 4 by 5 j cap. This is the unit vector of this vector. This is the unit vector of this vector. Even you can find the unit vector of this vector also. Guys, here this is A. Could you find the mod of A? That will be under root of 5 square plus 6 square. This square plus this square. So this will be 25 plus 36. Okay, this will be root 61. This will be root 61. Now we are supposed to find a unit vector. Unit vector will be A vector divided by mod of A. So unit vector will be, what is the A vector over here? That is 5i cap plus 6j cap divided by mod of A. Mod of A is root 61. Is this clear? Please tell me in the chats, everyone. Is this clear? Please tell me in the chats. Everyone means everyone, guys. Dot product will teach you after some time. Let me finish. Before that, there are some topics that we need to finish over. We have got A vector is equal to I cap plus j cap plus k cap. Okay. Find the unit vector of A. Guys, this vector is along x-axis, y-axis, and z-axis. See? This is x-axis. This is y-axis. This is z-axis. If I say there is a vector along x only, this is that vector. If I say there is a vector along y only, this is that vector along y-axis. If I say there is a vector along minus x, this will be the minus x. If I say there is a vector along minus j, this will be minus j. If I say there is a vector along z-axis, this will be z. If I say there is a vector along xy, this is y, this is x, so that will be something like this. If I say there is a vector along xz, this is x, this is z, this will be that vector. I hope you are getting it. If I say there is a vector along zy, this is z, this is y, that will be something like this. Something like this. Something like this. If I say there is a vector along xyz, this is x, this is y, and this is z, that would be something like this. It is moving in x, it will be in z, coming out, it is also going up. It is moving forward, it is coming out, it is going up. X, Y, Z, 3D. I hope this is crystalline clear. I hope this is crystalline clear. Okay. Tell me in the chats, is this clear? Now, in this case, what is the magnitude of A? That is under root of 1 square plus 1 square plus 1 square. Okay, so that will be root 3. Find the unit vector of A. Unit vector of A will be A vector divided by mod of A. Now what is A vector? I cap plus j cap plus k cap. A vector you are supposed to put as it is, divided by root 3. Now you can write 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Okay. So this will be the unit vector of A. Now, the question says that check whether the vector I by root 2 plus j by root 2 is a unit vector. Guys, how do we check if the vector is a unit vector? We know the magnitude of a unit vector is 1. If magnitude of this comes out to be equal to 1, this is a unit vector. Let's find the magnitude. Let's find the magnitude. So I would say magnitude of A, that will be under root of, what is the coefficient of I? That is 1 by root 2. So 1 by root 2, I would say whole square. Okay. And what about this plus plus plus? I say this is 1 by root 2 whole square. Yes. Now tell me one thing. Can I write over here? This is the mod of, why am I putting the vector sign over here? This is mod of A. This is mod of A is equal. Guys, tell me one thing. This will be under root of 1 by root 2 whole square. This square and root will cancel. So it will be 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2. Half plus half is 1. So it will be under root of 1. That will be 1. Yes, it is a unit vector. You say yes, it is a unit vector. So if the magnitude of a vector comes out to be equal to 1, so we say it's a unit vector, because unit vector has got the magnitude 1. Okay. Now guys, let's move on to the next one. If a vector A is 4i plus 3j, okay, there is a vector given as A is equal to 4i plus 3j. And there is another vector which is given 24i plus 7j. Can I say these are the two vectors which are in the xy plane? Yes, sir. Because I and j is present. Find the vector which has the same magnitude, of B and parallel to A. See. We have to find that vector which has the same magnitude of B. Understand one thing. Let's suppose we find the vector R. We have to find the vector R. This vector should have the same magnitude of B, means it should have the magnitude of B and parallel to A, and the direction of this should be exactly same as A. What does parallel to A mean? If A is moving in this direction, R should be in the same direction, parallel. Means their direction should be same. And what is the vector that is helping you to find the direction? Unit vector. So whatever is the unit vector of A, same should be for this R, means unit vector of A. Unit vector of A gives the direction of A, and direction of R should be the direction of A. As simple as that. So place the unit vector over here, magnitude of B over here. Now guys, let's first find the magnitude of B. Under root of 24 square plus we say 7 square. Okay. So this gives us the magnitude of B in this particular case. This gives us the magnitude of B in this particular case. Okay. And this will be, I can say over here, that is 25. Okay. This will be 25. Now. Guys, let's now find out. Now, let's find the unit vector of A. Why do we have to find the unit vector of A? Because unit vector of A will give the direction of A, and in the same direction we have to place this R vector, because it says that direction of R should be parallel to A. Now, what is the mod of A, guys? Mod of A will be under root of 4 square plus 3 square. 4 square plus 3 square, and that is root 25, that is 5. Now find the unit vector of A. That will be vector A divided by mod of A. And that will be, guys, what is vector A? Vector A is 4i cap plus 3j cap divided by, what is mod of A? That is 5. You got the unit vector of A. You got the magnitude of B. Now put over here. So R vector will be simply, what is the magnitude of B? That is 25. What is unit vector of A? That is 4i plus 3j divided by 5. 5 ones are 5, 5s are 25. So R vector in this case will be 5 into 4 is 20i plus 5 into 3 is 15j. So this is the vector which has the same magnitude of B. Calculate its magnitude, it will be exactly coming out to be 25. And this is the vector which has the direction of A, which is parallel to A. I hope this is clear. I hope this is crystalline clear. Is this clear? Now guys, we have got over here the orthogonal vectors. What does orthogonal vectors actually mean? What does orthogonal vectors actually mean? We say if the two vectors are perpendicular to each other, like this vector and this vector, they are making the theta is equal to 90 degrees over here. So means we call these vectors as orthogonal vectors. If the two vectors are making 90 degree with each other, then we can say the two vectors are orthogonal vectors. Okay, then we can say the two vectors are orthogonal vectors. Now guys, concurrent vectors. We say those vectors which are exactly acting at the same point, like this vector is acting at this point. This B vector is acting at same point. This vector is acting at this point. This vector is also acting at this point. So we say these vectors are called the concurrent vectors. If the vectors are acting at the same point, the vectors are said to be the concurrent vectors. And orthogonal vectors means if the two vectors make 90 degree with each other, we can call them as orthogonal vectors. Okay. Okay. Now, let's talk about components of vectors. let's talk about the components of vectors. Guys, see, when it comes to the components of vectors, let's suppose, understand this very carefully. Let's suppose you have got a block over here. Okay. You are applying the force on this block along the x-axis. Okay. This force is along the x-axis. We know because of this force, it will move along the x-axis only. Okay. Then if you have got a block over here, if you are applying the force along y-axis, and it will move along y-axis only. This is the force along y. This is the force along x. Okay. Yes. This is the force acting in pure x direction. This is the force acting in pure y direction. It will not move in x. It will only move in y. This will not move in y. It will only move in x. Yes. Now guys, let's suppose if you have got a block over here. You are applying a force on this block, something like this, in this direction. This is the force that you are applying on the block. When you apply the force on the block, it will move something like this along this direction. Don't you think that in this case, it will move along x-axis also, it will move along y-axis also. It will have the effect in x direction, it will have the effect in y direction. Okay. Now, what I'll write over here, if in the third case, the force will have effect along x as well as y direction. The force will have effect along x as well as y direction. Yes, sir. Okay. The force will have the effect along x as well as the y direction. So, if the force has the effect along x as well as y, my dear friends, I can say in this particular case, this effect along x is fx, this effect along y is fy. Okay. So if I say this is the force over here, that is F, its effect along x direction is Fx, its effect along y direction is Fy. Okay. And let's suppose this is theta. Okay. So this force has effect along x-axis, this force has effect along y-axis. So this is what we call the horizontal component, this is what we call the vertical component. This Fx is called horizontal component. Okay. And Fy is called vertical component. Fx is called the horizontal component and Fy is called the vertical component. Okay. Now, tell me one thing, my dear friends. If Fx is called the horizontal component, Fy is called the vertical component, do one thing. Do the parallel shifting of vectors. So take this Fy, exactly place it over here. Take this Fy, place it exactly over here. This is Fy. Okay. Now from this triangle, could you please tell me what is the value of sine theta? Sine theta in this case is, sir, perpendicular upon hypotenuse. Hypotenuse is F, perpendicular is Fy. That is Fy divided by F. Now, can I say this Fy will be equals to F sine of theta? So we got this vertical component as F sine theta. So this F will have one component, that is F sine theta. And I can say cos theta from the triangle is base by hypotenuse. Base is Fx, hypotenuse is F. So Fx from here will come out to be F cos theta. So this is the horizontal component. This is the vertical component. This is the vertical component. So from now onwards, you'll remember that if you have a vector, it will have two components. If you have a vector, it will have two components. Like, let's suppose you have a vector over here, that is A. It is acting at an angle theta. This is the horizontal component, that is AX. And this is the vertical component, that is AY. And what is this horizontal component? This is the effect of A along x-axis. This is the effect of A along y-axis. And we say this AX is simply, that is A cos of theta. And AY is simply A sine of theta. Horizontal component and vertical component. Okay. Now guys, tell me one thing. Can I say in this particular case, we say as, when it comes to this A vector, we say if you resolve this in two components, that is AX and AY, we say, so A vector can be resolved in two components. AX and AY. So this vector A can be resolved in two components, AX and AY. Okay? Yes. What I'm saying in this case is, can we write this A vector, that will be AX into I cap. Why? Because AX is that component of A which is along x-axis, that's why I cap. Plus, I can say AY J cap. This is along. Means. If you combine this and this, it will give you A. Or if you break A, it will give you AX and AY. That's what I'm mentioning. If you combine AX and AY, it will give you A. Or resultant of AX and AY is A. Or if you break A, it will give you AX and AY. Enough. Guys. Can I say in this particular case, this A vector I can write over here. What is AX? That is A cos of theta into I cap plus A sine of theta into J cap. You can write it something like this also. Guys, can you find the magnitude of this? You'll say, sir, magnitude of A will be simply, magnitude of A will be under root of this square, coefficient of I, A cos theta, its square, A square cos square of theta, plus this square, that is A square sine square of theta. Take A square common, so it will come out, becomes A. It will be something like this, under root of A square. Then we say cos square theta plus sine square theta. Guys, this is under root of A square. Cos square theta plus sine square theta is 1. Now A, this and root will cancel. So mod of A comes out to be equal to A. Yes, because original vector was A only. Even if you join this and this, then find its magnitude, that will give you the original vector. That's what I was saying. If you combine AX and AY, it will give you A. If you break A, it will give you AX and AY. Tell me in the chats, is this clear? Guys, tell me in the chats, is this clear? Okay, so this is what we call the components of a vector. So means from now onwards, a vector can be resolved in two components. So means it is the effect of a vector along x-axis, effect of vector along y-axis. Let's suppose you are given a question something like this. You are given a question something like this. You have got a velocity 50 meter per second. You have to find its x component and y component. Guys, what is Vx? Vx will be V cos of theta. Simple. And what is this V? V is given as 50. Then we say cos 37, cos of 37. Tell me, we recently studied in basic mathematics 37-degree triangle. If this is 37 degree, then this will be 3, this will be 4, this will be 5. Cos 37. Cos is, tell me guys, cos of 37 degree will be base by hypotenuse, that is 4 by 5. So you can write over here 50 into 4 by 5. 5 ones are 5 tens are 4 and 10 is 40. So value of Vx is 40 meter per second. Let's talk about Vy. Let's talk about Vy. When it comes to the Vy, it is V sine of 37. And what is V? That is 50. Sine 37 is, I can write over here, sine of 37 is base perpendicular upon hypotenuse, that is 3 by 5. So that will be 3 by 5. 5 ones are 5 tens are 50. So 3 into 10 is 30. So Vy is 30 meter per second. That is Vx and Vy. Similarly, here, guys, F is 20. If this angle over here is given as 30, how much will be this angle? This will be 60. We always check the angle with the x. No, we can check the angle with the y-axis also. If this is the angle, guys, if you are considering this as the angle, then this will be f cos theta, this will be f sin theta. If you are taking this as an angle, like this is 60, then this will be f cos theta, this will be f sin theta. If angle is from this side, then this will be cos. If angle is from this side, then this will be cos. Depends. So we say this will be fx in this particular case is f cos of 60 degrees. This fy in this particular case will be f sine of 60 degrees. Okay. Now this is 20 cos. So I can write over here f is 20. Cos 60 is 1 by 2. 2 ones are 2 tens are. So it is 10 Newton. And what about this f sine 60? F is given as 20. Sine 60. Sine 60 is a root 3 by 2. 2 ones are 2 tens are. That is 10 root 3. So vertical component came out to be 10 root 3. Horizontal component came out to be 10 Newtons. Okay. Okay. Now you have got the rectangular components over here. rectangular components. Guys, see. Let's suppose you have got a cuboid over here. Okay. And this is the vector that I am taking, that is a vector. And this vector is in 3D right now. Guys, see. If I'm saying you have got a vector A over here, this is in this XY plane. The vector is in the XY plane only. This is in 2D. But if the vector is in 3D, see how is it? X-axis, Y-axis, sorry, X-axis, Y-axis, Z-axis. If I say vector is something like this, it is 2D. It is in this plane, XY plane. Okay. If I say vector is something like this, it is in YZ plane, okay, 2D once again. If I say vector is something like this, it is in XZ plane, 2D. If I say vector is something like this, guys, something like this, it is in X-axis, it is in Z-axis, it is in Y. If it is going, if the body is moving something like this, means it is moving forward in X-axis, it is coming out, it is going up. That's what it is over here. So this is from one end to this end. It is not till over here. This is the back side of the cuboid. So from this end till this end. This is the back end. This is the front end. This is the front face. This is the front face. This one is the back face. So from the back end to the front end. This is the vector A. Okay. Now guys, this is the x-axis that I am taking over here. This is the y-axis that I am taking over here. This is the z-axis that I am taking over here. Now see, in this case, this A vector is making the angle alpha with the x-axis. A vector is making the angle alpha with the x-axis. Okay. Sir, this A vector is making the beta angle with the y-axis, let's suppose. And this A vector is making the gamma angle with the z-axis. It is making the gamma angle with the z-axis. It is making the gamma angle with the z-axis. Gamma angle with the z-axis. Okay. Now guys, always remember, if you have a vector over here, this is the vector A. I see. If this is the vector A, this is the vector A. If you are saying this is theta, then which component is this? This will be A cos of theta. This will be A sine of theta. If theta is from this side, this cos, this is sine. And if you are saying, sir, I am taking this as theta, okay, then this will be A cos of theta and this will be A sine of theta. In this case, horizontal component will be sine, vertical component will be cos. It depends from which side you are taking the theta. Okay. So cos component is always from the theta side. From the theta side. Now guys, if this is A, it is making the angle alpha with the x-axis. Don't you think it will be A cos of alpha? Obviously from this side it will be cos component. Yes. Now, if this is A, it is making the angle beta with the y-axis. Don't you think that along y-axis it will be A cos beta? Yes, cos component. Now if this is A, okay, if this is A, it is making the angle gamma with the y-axis. So along this axis it will be A cos of gamma. This A cos alpha, A cos beta, A cos gamma, these are what we call the cosine angles. Cos alpha, cos beta, cos gamma. What is alpha? Alpha is the angle between A and x-axis. What is beta? Beta is the angle between A and y-axis. Gamma is the angle between A and z-axis. Now, here, don't you think that I can write over here in this particular case, guys, this is the x component. I can say AX in this particular case, I can say AX will be simply, that is A cos of alpha. This is the x component along x-axis, A cos alpha. From here you can say cos of alpha is equal to, we say, AX divided by A. Similarly, you can say, sir, AY will be A cos of beta. Sir, AY will be A cos of beta. This is AY along y-axis. So this cos of beta in this particular case will be, that is AY divided by A. This is mod of A. Similarly, you can say AZ will be A cos of gamma. And here this cos of gamma will come out to be, that is AZ divided by A. Now this cos alpha, cos beta, cos gamma, these are what we call the cosine angles. Cos alpha, cos beta, cos gamma, these are what we call the cosine angles. Okay. And one more thing I just want to mention over here. What is that? Guys, you have to remember two trigonometric identities over here. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Sin square alpha plus sin square beta plus sin square gamma is equal to 2. These are the two identities that you need to remember over here. And these cosine angles. That's it. That's it. That's the maximum detail you have about it. That's the maximum detail you have about it. Now guys, find the angle that the vector A, okay, we have got the vector A over here. A vector is 2i cap plus 3j cap minus k cap mixed with the y-axis. Find the angle that this vector A makes with the y-axis. Guys, what is the angle? Guys, see, what is the angle A vector is making with the y-axis, that is beta angle. And how do we find this beta? Cos beta is AY divided by A. We say, in this case, as we know, cos of beta is equal to AY divided by A. This is mod of A. Now, first and the foremost thing is you have to find the mod of A. Guys, mod of A in this particular case will be under root of, that is 2 square plus 3 square plus we say minus 1 square. That will be under root of 4 plus 9 plus 1. That will be, this is a root 14. Now guys, from this, guys, always remember, this is 2 means x component, AX. This is AY and this is AZ. And we can say over here, AY is equal to 3. And we can say over here, AX is equal to 2. And we say AZ is equal to minus 1. Now tell me guys, if I say what is the value of cos beta, that is AY divided by mod of A. AY is, that is 3 divided by mod of A is root 14. Even you can say cos of alpha, that is AX divided by mod of A. We recently studied, what is AX? AX is 2 divided by root 14. Even you can say cos of gamma, that is AZ divided by mod of A. And that is, what is AZ? That is minus 1 divided by root 4. We calculated all the 3 angles, alpha, beta, and gamma. We calculated all the 3 angles, that is alpha, beta, and gamma. A vector is given by A is equal to 3i cap plus 4j cap plus 5k cap. A is equal to 3i cap plus 4j cap plus 5k cap. This is the vector that is given over here. Find the magnitude of A. Okay. Unit vector of A. Let's first find the magnitude of A. Simple. It is under root of 3 square plus 4 square plus 5 square. So it will be under root of 9 plus 16 plus 25. Done with this? Okay. And then we have to find the mod of unit vector of A. How do we find the unit vector of A, guys? Vector A divided by magnitude of A. Vector A divided by magnitude of A. That's how we find it. Okay. Now, solve this. And this comes out to be equal to 5 root 2. Okay. Then we say A cap. That is A vector divided by mod of A vector. So A cap will be, what is A vector? I can write over here 3i cap plus 4j cap plus 5k cap divided by mod of A. Mod of A is 5 root 2. Mod of A is 5 root 2. Okay. Find the magnitude of A, unit vector of A, done. Angles made with A with the coordinate axis. It is asking to find the cos of alpha, cos of beta and cos of gamma. How do we find this? This is AX divided by mod of A. AX divided by mod of A. So I can write over here cos of alpha is equal to AX. What is AX? That is 3. And what is mod of A? That is 5 root 2. Because guys, this is AX, this is AY, this is AZ. Even you can find cos of beta. That is AY divided by mod of A. What is the value of AY? That is 4. What is the mod of A? That is 5 root 2. Even you can find cos of gamma. That is AZ divided by mod of A. What is the value of AZ? AZ is 5 divided by mod of A is 5 root 2. Simple, simple, simple. Is this clear? Please tell me in the chats if this is crystal and clear to each and every single student. Okay. Next, magnitude of a vector. We are done with this. Okay. Find the magnitude of this. Under root of 2 square plus 3 square. Under root of 3 square plus 4 square. Under root of 8 square plus 6 square plus 10 square. Okay. This one also. Done, done, done. Basic properties of a vector. Multiplication of a vector with a scalar. Guys, if I say if f is equal to 2i cap, find 4f. What is this? Vector f is given as 2i cap. Now you are multiplying a scalar with the vector. Is it possible? Yes. So you can say 4f will be equal to 4 into. What is the value of f? That is 2i cap. So 4 into 2 is 8i. Simple. Sir, if scalar is multiplied with a vector, can we do it? Directly do the multiplication. Simple. Okay. Like if I say f is equal to 15j cap. Find 2f. So 2 into 15 is 30. 30j cap. 30j cap. Okay. Addition of a vector with a scalar. It is not possible. If you have got 5 Newton force, this is a force over here, vector, plus you are adding mass. So you cannot add a vector to a scalar, not possible. Okay. Addition of two vectors. Is it possible? Yes. See guys, if I say over here, F1 is given as 3i cap, F2 is given as 4i cap, okay? We are supposed to find F1 plus F2, okay? Simply guys, F1 plus F2 is 3i cap plus 4i cap. That will be 7i cap. Simple, basic properties. Basic properties. Okay, these are the basic properties that you have. Let's take a break of 10 minutes, guys, huh? It'll take us 1 more hour to complete, because now we have the triangle law of vector addition. We have got parallelogram law of vector addition, polygon law, dot product and cross product. It'll take us 1 more hour and we are done with this. I'll take the break of 10 minutes. So the break is till 10:10 p.m. Like it'll be around 20 more slides and that's it, we are done. Check. Now guys, take a look over here. See? Triangle of vector addition. Let's take a look. First, I'll make you understand, then we'll see the statement. What does triangle session will end at 11 o'clock exactly, okay? What does triangle law of vector addition say? Guys, we say it is valid for two vectors only. What does it say? It says that if you have got a vector, let's suppose this is the A vector over here, and you have got another vector that is B vector over here, and you have to add these two vectors. If you have got two vectors and you are supposed to add these two vectors, you can add these two vectors with the help of a triangle law. So triangle law of vector addition is used to add the two vectors. It is used to add the two vectors. So you have vector A, you have vector B. Now, if you are adding these two vectors using triangle law, what does it say? It says that do one thing. Take this vector from here and place it over here, okay? Parallel shifting of vectors. Yes. Take this vector from here and place it over here. Make sure magnitude and direction should remain the same. This is the vector B here in the upward direction. Here also it is in the upward direction. This is the vector A in the forward direction. Here also it is in the forward direction. Okay. Don't you think that it is making the two sides of a triangle? Yes. So, what does triangle of vector addition say? It says that with the help of these two vectors, try to make the two sides of the triangle. Done. We did that. First side of the triangle, second side of the triangle. Then it says that when you are done with that, when you have made the two sides of the triangle, then the resultant will be given by the third side of the triangle. The resultant will be given by the third side of the triangle. That is this. Okay. So let me show you the statement. It states that if two vectors acting on a particle at the same time are represented with magnitude and direction by the two sides of the triangle. So means if that, because with the help of those two vectors, if you make the two sides of a triangle taken in the same order, then their resultant is represented by the third side of the triangle taken in the opposite order. Like, what does this opposite order mean? This is basically over here. I can say this is the vector. This is the vector. Okay, this is the order over here. This will be the order. But if this is the order of this, this is the order of this, order of resultant will be something like this. So means this will be the resultant. Simply, guys, triangle law of vector addition says that vector addition says that, okay, it says that. Ab suno. See, guys, when it comes to the triangle of vector addition, it says that if you have the two vectors, you want to add those two vectors, try to basically make the two sides of the triangle with the help of those two vectors. Okay. And then third side is represented by the resultant. Okay, third side will give you the resultant. Now, guys, if you ask me, sir, what is the value of this resultant? What is the magnitude of this resultant? Directly, I would want you guys to remember the resultant will be under root of this vector square, a square, plus we say b square, plus we say 2ab, then we say cos of theta, where theta is the angle between a and b. Like I'll show you over here. You have got the two vectors. This is a vector and this is b vector. Okay. Angle between a and b over here is, let's suppose, theta. What you are supposed to do? Just parallel shift this vector and make it over here so that you can complete the triangle. Then third side will give you the resultant. Okay, guys, you have got A vector, B vector. Angle between A and B is theta. Okay, just try to make the two sides of the triangle. This is one side, another side. Resultant will be given by the third side. And here, in this particular case, I can say a resultant will be, that is under root of this vector square, whatever is this, plus this vector square, plus then we say 2ab and we say cos of theta. This is how we find the resultant of the two vectors. This is how we find the resultant of the two vectors in this particular case. Okay. Okay. Now, guys, tell me one thing. In this case, sir, if this is a vector, guys, if this is the angle theta over here, don't you think that this would be also theta? Because here B vector is making with the x-axis theta. Here also the same B vector will be making the theta. If this is theta, this is B, which component of this it will be? This will be B cos of theta. And which component of this will be? This will be B sine of theta. B sine of theta. Now take a look. Guys. Since we got the resultant, let's now take a look. Can you take a look at this bigger triangle? Look at this bigger triangle. What is the value of tan alpha? I can say tan of alpha will be simply perpendicular divided by base. Perpendicular divided by base. What is perpendicular? That is B sine of theta. And what is base? Base is A plus B cos theta. That is A plus B cos of theta. This is the value of tan alpha. And what is this tan alpha actually? We say this tan alpha, I can write over here, this is the angle between resultant and A vector. This is the angle between this resultant and A vector. Maybe if somebody asks you what is the angle between resultant and A, that is tan alpha. And what is this theta? Theta is the angle between A vector and B vector. Okay. Even if somebody asks you what is the angle between, also tan of beta will be, similarly you have to use the geometry, and then in that particular case tan beta will come out to be, here it is B sine theta, in that case it will be A sine theta upon, and here it is A plus B cos theta, in that case it will be B plus A cos theta. And what is the tan beta? Where beta is the angle between resultant and B vector. It is the angle between resultant and B vector. Okay? And alpha is the angle between resultant and A vector. These are the three things which you are supposed to learn when it comes to the triangle of vector addition. Okay? Resultant, angle between, we say R and A, angle between R and B. Yes. Cool. Let's suppose you have the question over here. Two vectors of magnitude 4 Newton and 6 Newton are acting at an angle of 60 degrees. Then find the magnitude of the resultant. Guys, in this particular case, you have got the two vectors and you are supposed to find the resultant. Resultant will be simply under root of A square plus B square plus 2AB cos of theta. So resultant will be simply under root of, what is the value of a square? That is 4 square plus 6 square, 2 into 4 into 6, because one vector is 4, another vector is 6, acting at an angle of 60 degrees. Then we say cos of 60. Okay. Just put the value and get the answer. Just put the value and get the answer. Simple, extremely simple. Okay. Then we say this will be root 76, root 76. Second one, it is saying that angle between the resultant and 4 Newton. Okay. Like if this is the 4 Newton, this is A vector is equal to 4 Newton. This is B vector over here. This is B vector over here, 6 Newton. And this will be the resultant. Angle between this and this is alpha, angle between this and this is beta. Now recently we calculated angle between A vector and R vector. That is tan alpha is B sine theta upon A plus B cos theta. I can say tan of alpha is B sine theta upon A plus B cos theta. And guys, here it says that angle between the two vectors is 60 degrees. So means theta is equal to 60 degrees over here. You can say, what is the value of B? B is given as 6. Then I say sine of theta, sine of 60 divided by A. A is given as 4 plus 6 cos of 60. Just put the values and get the answer. Simple. Sine 60 is root 3 by 2. 4 plus cos 60 is 1 by 2. Just do the calculations from your end. Even you can find the value of this one also. That is tan of beta. Tan of beta will be A sine theta upon B plus A cos theta. Just put the values over here also and you will get the answer. What is A? A is given as 4, B is given as 6. Sine theta, sine 30, here it is cos 30. Sorry, sine 60, cos 60. Okay. Now guys, take a look. Subtraction of two vectors. See guys, let's suppose you have got a vector over here. Okay, this is a vector A. And you have got another vector over here. You have got another vector over here, that is vector B. This is A vector and this is B vector. Okay, yes. Now what I want you guys to do is, could you please tell me what is the resultant of A vector and B vector? What is an angle between these two is, let's suppose theta. It says, sir, this resultant vector will be simply, that is A plus B. How can you find the resultant? With the triangle law that we already studied. This will be A plus B. Okay. Now guys, what if I tell you, you write the vector, you make a vector opposite to this. Previously, I have told you we can write this as negative vector B. If this is the vector which is opposite to this one, this will be negative vector B. Okay. Now, what is the resultant of this one and this one? That would be something like this. That is R dash. And this R dash would be actually equal to this A vector minus, we say, B vector. It is also plus. Plus into minus is minus. Minus B vector. So this is called the subtraction of the vectors. Okay. If you are taking the negative vector of this one, then resultant between this negative vector and this A vector. So that is R dash vector. So where this is called subtraction. Subtraction of two vectors. Two vectors. Now guys, tell me one thing. If this is theta angle, Could you please tell me how much will be this angle? This will be 180 minus theta. Why? Because total is 180 between B and minus B. This is theta, so this will be 180 minus theta. Now tell me one thing. Could you please tell me what is the value of R dash? Sir, value of R dash will be under root of, like we find the magnitude in case of addition, similarly over here. That is a square plus b square plus 2ab cos of, what is the angle between the two vectors? That is 180 minus theta. Cos of 180 minus theta. Okay. In case of addition of two vectors, we'll say under root of a square plus b square plus 2ab cos theta. Here, we write a square plus b square. Okay. This square plus 2ab cos of 180 minus theta. Now I can write this R dash will be under root of a square plus b square. And guys, cos 180 minus theta is minus cos theta. So I can say minus 2ab cos of theta. Minus 2ab cos of theta. This will be the resultant of subtraction of two vectors. This will be the resultant of subtraction of two vectors. Okay? This will be the resultant of subtraction of two vectors. And guys, in this particular case also, I'll write this angle over here, 180 minus theta. In this case also, we say this angle is alpha. In this case also, we say this angle is beta. The angle between the resultant and a vector, like here we define this angle over here is alpha, this angle over here is beta. Similarly, in this case, we define this as alpha and this as beta. This is alpha and this as beta. And in case of subtraction of two vectors, guys, tan alpha will be, what was here. Tan alpha is b sin theta upon a plus b cos theta. A sin theta upon b plus a cos theta. In this particular case, what I want you guys to focus is b sin theta. Instead of theta, how much is the angle over here? 180 minus theta. Upon a plus cos of 180 minus theta. Now, sin 180 minus theta is sin theta. Cos 180 minus theta is minus cos theta. That's why you got minus over here. So what is the value of tan alpha over here? B sin theta upon a minus b cos theta. Are you getting me what I'm trying to say? So basically it was b sin of theta. Here, angle between a and minus b is not theta. It is 180 minus theta. That's why. Similarly, tan beta. Let's see the formula of tan beta. That is a sin theta upon a plus b cos theta. Here, a sin theta upon a plus b, b plus a cos theta, Yes, b plus a cos theta. Now, instead of theta, 180 minus theta, 180 minus theta. Sin of 180 minus theta is sin theta. Cos of 180 minus theta is minus cos theta. So, it will become minus. So, this is the value of tan beta over here. This is the value of tan alpha over here. Okay. This is alpha and this is beta. This is the subtraction of the two vectors. And this is the addition of the two vectors using the triangle law. Okay. Cool. Find the subtraction of the two vectors. Guys. In this particular case, what is the resultant of the subtraction of the two vectors? R dash is equal to under root of a square plus b square plus, not plus, minus 2ab, then we say cos of theta. We have to find the subtraction of two vectors. If they ask us to find the addition of two vectors, then we use this a square plus b square plus 2ab cos theta. But when it comes to the subtraction of two vectors, we say a square plus b square minus 2ab cos theta. A square plus b square minus 2ab cos theta. That will be under root of a square. A is 4 square plus 3 square minus 2 into 4 into 3. cos theta. What is the angle between the two? That is 60. Cos of 60. Okay. In reality, what are we doing? Sir, we take its negative vector in the opposite direction, then find their resultant. This is B. We are actually this is minus B. We are actually finding resultant of this one and this one, that is R dash. That is called the subtraction of the two vectors. Okay. Is this clear, guys? Is this clear? Okay. And this comes out to be equal to root 37. Root 37. Then it says that also find the direction of the subtraction of the two vectors. We are supposed to find the value of tan alpha also. We are supposed to find the value of tan alpha also. This alpha. So what is the value of tan of alpha? Guys, tell me. Tan alpha is b sine theta upon a minus b cos theta. B sine theta upon a minus b cos theta. This will be b sine theta. What is b? That is 3 sine of 60 divided by a is 4 minus 3 cos of 60. Just put the values and get the answer. Sine 60 is root 3 by 2. Cos 60 is 1 by 2. Okay. Okay. First, we'll move on to the parallelogram law of vectors. Parallelogram law of vector addition. Guys, see, it states that if the two, I'll just show you with the diagram itself. When it comes to the parallelogram law of two vector addition, let's suppose you have got the two vectors. Okay. You have got the two vectors. This is the vector over here. This is the vector over here. This is vector A and this is vector B. Oh, and this is theta. You have to add these two vectors with parallelogram law. What does it say? It says that try to make the parallelogram with these vectors over here. Try to make the parallelogram with these two vectors over here. Do the parallel shifting. Guys, take this vector, place it over here. Okay. Take this vector, place it over here. Okay. Also, I will show over here. Parallelogram law of vector addition says, if you have got the two vectors, let's suppose A and this is B. Angle between these two is theta. And you guys are supposed to do the addition of these two vectors using parallelogram law. What does triangle law say? Triangle law says that try to make the triangle with the two vectors. This says try to make the parallelogram with the two vectors. Now guys, do the parallel shifting of vectors. I'll show you. This vector, make it over here, this is A. This vector, make it over here, this is B. This is B. Okay. Now. Guys, see. We say if this is A, this is B. I'm saying take one more vector exactly like this. Okay. This will be also B. And take one more vector parallel to this, which is also like this. This will be A. Okay. This is A. This is B over here. Don't you think that it looks like the parallelogram? Four sides. Yes. Now. It says the diagonal of the parallelogram will give the resultant. So try to make the parallelogram with these two vectors, then resultant will be given by the diagonal. Okay. This angle over here is theta total. This is alpha and this is beta. Now guys, tell me one thing. What is the value of this resultant? It will be exactly similar as you studied in triangle law. That is a square plus b square plus 2ab cos of theta. Okay. Rest everything is same. Rest everything is same. Guys, a square plus b square plus 2ab cos theta. Okay. And tan of alpha is same. Tan of beta is same. Exactly same. B sin theta upon a plus b cos theta. A sin theta upon b plus a cos theta. Sir, what is the difference between parallelogram law and triangle law? Triangle law says that try to make the triangle with the help of the two vectors. Resultant will be given by the third side. Okay. Then when it comes to the parallelogram law, it says that try to make the parallelogram with the help of the two vectors. Then resultant will be given by the diagonal of the parallelogram. That's it. Rest all the values, magnitude and angles, everything is same. Everything is same. Please give me the signal in the chats. Please give me the signal in the chats. Is this clear? Is this clear? Now, next we have the polygon law. What does polygon law actually say? Polygon law of vector addition. Now, this is the vector addition which is used to add more than two vectors. When it comes to the parallelogram law and triangle law, that is used to add only two vectors. This is used to add more than two vectors. It states that if n number of vectors are acting on a particle, okay, we say at the same time are represented in magnitude and direction by the various sides of an open polygon taken in the same order. The resultant is represented by the direction by the closing side. Now see, let's suppose you have got many vectors over here. A vector, B vector, C vector, D vector. Polygon law says that try to make the polygon with the help of these vectors. What does polygon say? What is a polygon? Polygon means which is having many sides. Now guys, see. Take this A vector, make it over here. Parallel shifting of the vector. Don't change the direction, keep the direction same. Take this B vector, make it over here. Take this C vector, make it over here. Take this D vector, make it over here. Okay. If you are done with this, we say resultant will be given by the closing side. This is the side which will close this polygon. Taken in the opposite order. Now see, you see the order of these. This. It was anti-clockwise. This is clockwise. So in case of polygon law says that if you have multiple vectors, okay, you want to add those. Try to make the polygon with the help of those multiple vectors. Then resultant will be given by the closing side in the opposite order. That's it. You don't have to discuss anything else in this one. That's it. And this language is whatever I told you, same is mentioned in this language over here. Okay. Triangle law is done. Parallelogram law is done. Okay. You can see the figure also. It has made a parallelogram over here. Resultant is given by the diagonal. Great. Now guys, take a look. Now guys, take a look over here. See, dot product of two vectors. Guys, see, let's suppose if you have got a vector over here, A, okay, and you have got another, okay, before this dot product, let me just tell you multiplication of two vectors. Multiplication of two vectors. I see. Let's suppose if I tell you multiplication of two numbers, 2 into 4, you say, sir, 8. 8 into 2, you say, sir, 16. This is the normal multiplication of the numbers. Simply you are doing the multiplication. When it comes to the multiplication of vectors, multiplication of the vectors can be done in two ways. One is called the dot product, okay, cross product. It is not like you are multiplying the two numbers. You are multiplying two vectors. So there are two ways, two methods by which you can multiply the two vectors, dot and cross. First one, we need to understand dot product of two vectors. This is the multiplication. Let's suppose you have the A vector over here and you have the B vector over here. I say multiply the two vectors, multiply the two vectors using dot product. Multiply the two vectors using dot product. Multiply the two vectors using dot product. Now guys, if you say I have got a vector over here A, dot we say, sir, B. How do we do the dot product? Directly see guys. We say it is A vector mod of A, then we say mod of B, then we say cos of theta. AB cos theta. What is this theta? Where theta is the angle between A and B, A vector and B vector. So dot product of two vectors is what? If you have A vector, B vector, you are supposed to do the dot product. So that is AB cos of theta. That is AB cos of theta. Okay. That is AB cos of theta. Okay. Now guys, understand one thing very carefully. If you have to do the dot product of the two vectors, now guys, see, take a look over here. Let's suppose, and if somebody asks you what is the value of this cos theta, you simply say that is A dot B divided by, we say mod of A mod of B. So cos theta will be A dot B divided by mod of A mod of B. Okay. Now, since you got this as cos theta, now my dear friends, let's suppose if the vector is given something like, first of all, let's suppose if somebody asks you what is the value of I dot I. So I is the unit vector. Okay. What is the value of I dot I? You can say, sir, A dot B is AB cos theta. That is mod of I. And what is mod of I? That is 1, because magnitude of unit vector is 1. So this is 1. Okay. Then we say cos of I dot I. I is that unit vector which is along x-axis. I dot I. So what is the angle between I and I? That is 0. So we say this is cos of 0. So now this will be cos 0 is 1. So I dot I is 1. Similarly, if somebody asks you what is the value of J dot J, it will be also 1. Similarly, if somebody asks you what is the value of K dot K, that is also 1, because that is mod of K mod of K. Mod of K is 1, mod of K is 1. Cos of 0. Okay, that is also 1. So this will be 1. Okay. Now, one more thing I just want to mention over here. if somebody asks you what is the value of I dot j, I is that unit vector which is along x-axis, j is unit vector which is along y-axis. Okay, now I can say over here it will be, what is mod of I? 1. What is mod of j? 1. Then we say what is the angle between these two I and j? That is 90 degrees. X-axis, y-axis, 90 degrees. Cos 90 is 0, so this will come out to be 0. Okay. Next, my dear friends, we say what is the value of j dot k? Sir, j dot k will be also 0 because angle between these two is 0. What is the value of k dot I? K dot I is also 0 because angle between these two is also 90 degrees. Angle between these two is also 90 degrees. Okay. Now, one more important point I just want to say. If the angle between two vectors is 90 degrees, if the angle between two vectors is 90 degrees, then if the angle between two vectors is 90 degrees, then we say what is a dot b? Then what is a dot b? Guys, you'll say, sir, that is a b cos of 90. If you have the two vectors, angle between these two is 90. So we say a dot b cos of theta. So in this particular case, so this will be 0. Then in that case, dot product of the two vectors is 0. If the angle between the two vectors is 90 degrees, then the dot product of the two vectors will come out to be 0 in that particular case. Okay. Now guys, since you got this, let's suppose one more thing I just want to mention over here. Let's suppose you get a question something like this. If a vector is ax I cap plus ay j cap plus az k cap, okay, like 2i cap, 3j cap, 4k cap, and another vector is given something like this, that is bx I cap plus by j cap plus bz k cap, okay, and they ask you to find the dot product. Okay, find a dot b, guys. If you ever get a question something like this, okay, if you ever get a question something like this, in that particular case, what you are supposed to say? We say directly, guys, this ax into bx. Directly say this ax into bx. Then we say plus this ay into by. This ay into by. Then we say plus this az into bz. Az into bz. So if you have the two vectors, their I cap, j cap, and k cap, all the three are given over here. In that case, you have to find the dot product. You simply say we say coefficient of I, multiply these two simply, and we say coefficient of y, coefficient of z. Okay, and one more thing, my dear friends, we say dot product of two vectors is a scalar. Dot product of two vectors is a scalar. Dot product of two vectors is a scalar. Okay, so I hope this is the complete detail when it comes to the dot product of two vectors. It is AB cos theta. Cos theta comes out to be A dot B upon AB. And I dot I comes out to be 1. J dot J comes out to be 1. K dot K comes out to be 1. Okay. I dot j is 0, j dot k is 0, k dot I is 0. Okay, if angle between the two vectors is 90, a dot b is 0 in that case. And this is how we basically, this is if the vector is in the Cartesian form. In that case, this is how we find the dot product. Let me show you the question first. See guys, if a vector is given this, okay, a vector is 3i cap, 4j cap, 2k cap. B vector is 2i cap, 3j cap, minus k cap. Find a dot b. Guys. Could you please tell me what is a dot b in this particular case? Coefficient of this ax into bx. That is over here. I'll write guys, see. A vector will be 3i cap plus 4j cap plus 2k cap. B vector will be 2i cap plus 3j cap minus k cap. Now, if I say a dot b, what will you say? Sir, ax into bx, that is 3 into 2 is 6, plus, sir, 4 into 3 is 12, minus this minus. 2 into minus 1 is minus 2. Okay, now tell me. So this is 18 minus 2, that is 16. See, this is a scalar. This is scalar. Dot product of two vectors is a scalar. Find the angle between the two vectors. Guys, we say cos of theta is equal to a dot b divided by mod of a mod of b. Now tell me guys one thing. A dot b, what is the value of a? That is 3i plus 4j. Dot b, that is 12i plus 5j. Because this is how we find the cos theta. Recently I told you. Cos theta is equal to a dot b upon mod of a mod of b. Okay, then divided by, what is the value of mod of a? Guys, mod of a I can write over here under root of 3 square plus 4 square, that is root 25, that will be 5. Similarly, mod of b I can write over here under root of 12 square plus 5 square. Okay, 144 plus 25. Okay, now put it over here. Put it over here in this particular case. Okay, now guys, so this will come out to be, we say 13. Now tell me, we say mod of a is 5 into, we say sir 13. Now you guys can do 3i into 12, 3 into 12, that is 36, plus 4 into 5, that is 20, upon 5 into 13. So this is cos of theta. Further you can solve this. See, here it is dot directly. Ax into bx, ay into by. This is your homework. This is your homework. One more question, I'll give you the homework. Yes. This is your homework. This is simple, by the way. 2a plus 3b. I is given. What is the value of 2a minus 3b? 2a minus 3b. Guys, see. A vector is this. B vector is this. 2a. What is the value of 2a? Multiply this vector with 2. So 2 into I cap plus j cap minus 2k cap. Minus 3b. Multiply this b vector with 3. So this will be 2i cap minus j cap plus k cap. That is 2a, a vector, b vector. So I can write this is 2i plus 2j minus 4k. Then minus 3 2s are 6i minus, okay, 6i minus, we say 3j plus 3k. Okay. Now tell me guys over here. So this will be 2i plus 2j minus 4k minus 6i, minus into minus is plus 3j, minus into plus is minus 3k. Now guys, 2i minus 6i. So it will be minus 4i, 2i plus 3i plus 5j. Sorry, 2j plus 5j is 2j is 3, 2j plus 3j is 5j. Minus 4 minus 3 is minus 7k. I guess this should be the answer. Do check it later on. This is your homework. A simple, bro. A is equal to 3i plus 4j. What is the value of ax? Ax in this case is 3. This is ax, this is ay. Ay in this case is 4. And what is az? Az is 0. And what is mod of a? Simple, mod of a is 3 square plus 4 square. That is root 25, that is 5. Mod of a. Angle of a from the x-axis. Okay. Angle of a from the y-axis. These three you guys are supposed to do it from your own. Okay. Unit vector of a. That is also simple. This question I'll also give you as homework. Okay. This question is homework. This question is homework. This question is homework. Now we have got the cross product. See guys, what does cross product of two vectors actually mean? See, when it comes to the cross product of two vectors, let's suppose I have got a vector A over here, okay, and I say you have got, if we have two vectors, if we have two vectors, A vector and B vector. If we have two vectors, A vector and B vector. Okay. Let's find its cross product. Cross product. Guys, when I say A vector, then I do cross B vector. It will be A, B, mod of A, mod of B. Then I'll write over here sine theta and I say n cap. Why this n cap? I'll tell you. So cross product of two vectors is AB sine theta. Dot product of two vectors is AB cos theta. Dot product of two vectors is AB cos theta. And this is AB sine theta. Now guys, understand one thing very carefully. Let's suppose I say, sir, this dot product, cross product of two vectors is itself a vector. This is itself a vector. Let's suppose I call this as C vector. This is a C vector. So cross product of two vectors is a vector. What about dot product of two vectors? Is that a vector? No, that is a scalar. So my dear friends, let's suppose I'll give you, let me show you, let me give you the feel of this one. Let me give you the feel of this one. Let's suppose you have got the two vectors. Sir, this is the vector A over here. This is the vector A over here. And this is the vector B over here. Don't you know that, sir, we have already studied this is the vector R. This is the resultant. Okay. And this resultant is A plus B. This resultant is A vector plus B vector. And how do we find its magnitude? Under root of A square plus B square plus 2AB cos theta. Then you have got, sir, this is the resultant of the two vectors, addition of the two vectors. Then you have got cross product of the two vectors, that will be this. This is the cross product of the two vectors, that is C. Okay, where C is the cross product of two vectors, where C is the cross product of two vectors and is perpendicular to, guys, it is perpendicular to the plane. It is perpendicular to the plane carrying A vector and B vector. What I'm trying to say is that, guys, see. If this is a vector A, this is the vector B, okay? This will be the resultant R. Resultant is A plus B, okay? Now, if this is vector A, this is vector B, it is in this plane, xz plane. Sir, what is the cross product? What is the direction? Cross product will be perpendicular, something like this. Perpendicular to this plane. Perpendicular to the vector A, perpendicular to the vector B, perpendicular to the plane which carries A and B. That's why I made it something like this. Okay? Okay? So we said this C vector is perpendicular to A vector. Okay? This C vector is perpendicular to B vector. Even the C vector is perpendicular to this R vector. If somebody asks you, what is the direction of this C vectors? Direction of the C vector is always perpendicular to these vectors. And cross, sir, you didn't show us the direction of the resultant of direction of the dot product. Dot product is not a vector, bro. It's a scalar. That's why here I am showing you the direction. It is perpendicular. And what is this n cap? N cap gives the direction of the C vector. That's why I'm mentioning n cap is the unit vector. We say also mention this point. N cap is the unit vector which gives the direction. N cap is the unit vector which gives the direction of C vector. Which gives the direction of C vector. Okay? 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 Now, guys, let's suppose if I ask you, what is the value of I cross I vector cross I vector? What will you say? Sir, I cross I will be mod of I, that is 1, mod of I, that is 1, mod of A, mod of B, sine theta, sine of 0. What is the angle between I and I? That is 0. Sine 0 is 0, so this will be 0. Similarly, J cross J, that will be also 0. Because angle between J and J is also 0. Similarly, K cross K, that is also 0. Let's say, if I say, what is the value of I cross J? You say, sir, that is mod of A, mod of B. That is mod of I, mod of J. That is 1. Then we say sine of, what is the angle between these two? That is 90. Angle between these two is 90. Sine 90 is 1. So this will come out to be 1. I cross J is 1. And if I say J cross K, J cross K is also 1. If I say K cross I, that is also 1. K cross I is also 1. I cross J is 1, J cross K is 1, K cross I is also 1. Okay? Okay, okay, yes. What else? Okay. Now guys, take a look. Let me show you the important one, the last question of the class, and we are done. The last question and we are done. Let's suppose you have got the two vectors over here. A vector. You have got the two vectors over here. A vector is I cap minus 2j cap plus 4k cap. And you have got B vector over here. That is 3i cap minus j cap plus 2k cap plus 2k cap. Okay. These are the two vectors over here. And my dear friends, I am asking you to find A cross B. Find A cross B. Sir, if I would have asked you find A dot B, what will you say? 1 into 3, 2 into 1, 4 into 2. Direct multiplication. But when it comes to the A cross B, here you have to make the determinant. Draw a line over here. Draw a line over here. Guys, whatever the thing I say, method I say, just remember it. Okay. Then you write over here I. Then you write over here J. And then you write over here K. I, J, K. How do we do the dot? Dot will be AX, BX plus AY, BY plus AZ, BZ. But here it is I, J, K. Draw a two lines. This is called the determinant. And then guys, here below I, guys, understand what is the coefficient of this I? That is 1. What is coefficient of J? Minus 2. This is 4. I'll write 1 minus 2 and this is 4. Coefficients of first vector. Coefficients of second vector. 3 minus 1 and that is 2. Now you have to solve this determinant. Now you have to solve this determinant over here. How do you solve this determinant? I'll tell you. Guys, first we will solve it for I. First we will solve it for I. So A cross B. First we will solve it for I. So I'll write over here I cap. Then, guys, take that row in which I is present. Sir, this is that column. Hide this. Take that row in which I is present. This column and this row. What remains over here? 2, 2, 1, 4. Do the cross multiply of these. 2 into 2 is minus 2 into minus 2 is minus 4. 4, then we say minus. This into this minus, this into this. Minus 1 into 4 is, again I say minus 4. Okay, we have solved it for I. Then we say minus J. Now solve it for J. Place minus over here. Okay, guys, hide that row in which J is present. Hide that column in which J is present. What remains over here? 1, 2, 3, 4. Do the cross. 1 into 2 is 2 minus 3 into 4 is 12. Then plus K. Here in front of the J you have to plus minus. Put minus. Here you have to put plus. Now guys, take that column in which K is present. Take that row in which K is present. Okay, hide these. What is this? 1 into minus 1, 3 into minus 2. That is 1 into 1 is minus 1 is minus 1. 3 into minus 2 is minus, it is minus 6. Now guys, tell me, this is I. Minus into minus is plus. Minus 4 plus 4, this will be 0. Minus J. 12 minus 10, 2, that is minus 10. So it will be minus into minus is plus 10. So I'll be writing over here plus 10 J cap. Then we say plus K cap. Tell me, guys. Minus into minus is plus. 6 minus 1 is 5. So it will be 5k cap. 5k cap. So A cross B came out to be, that is 10j cap plus 5k cap. Now you guys clearly see cross product of two vectors came out to be the vector itself. See, it is a vector. How do we do the cross product? Make a determinant, then solve this determinant. I have shown you the rules. Okay. So with this we are done. So thank you so much. This was all about it. Done and dusted. And guys, do let me know in the comments how was the session, each and every single thing. Okay, once I end the live stream. So take care and bye-bye. Okay. Okay, guys. Take care. Take care. Take care. Huh?